Start Checha. Hello all. Today we have to complete the chapter Ionic Equilibrium, and the next chapter that we have for tomorrow exam is Periodic Classification. I'll try to explain a few important trends from the Periodic Classification chapter, but before that we need to finish equilibrium. Coming to the point, you have an exam tomorrow. I don't know if somebody has told you or not. The timetable for the exam and the paper explanation will be given to you by 11 o'clock, and probably there will be an exam early hours of the day, like from 8:40 to 11:40, and then from 11:40 there will be paper explanation taking place. Per subject there will be 1 hour paper explanation session taken. So you remember this. Okay, na? So coming to chemistry, whatever the chapters, those have been covered by Ramarao sir and also by me, will be there for exam tomorrow. And coming to my track, there will be thermodynamics, equilibrium and periodic classification. And you also, Ramarao sir will also tell you the syllabus, and the syllabus sheet has been already sent to you. So follow the same thing, there are no deviations from that. So now I am going to talk about the next important part of the chapter after dissociation constants of weak acid and weak base. We will now talk about dissociation of a polybasic acid. When we consider dissociation of a polybasic acid, ಪಾಲಿಬೇಸಿಕ್ ಆಸಿಡ್ ಅಂದರೆ ಒಂದು H+ ಅಯಾನ್ಗಿಂತ ಜಾಸ್ತಿ H+ ಅಯಾನ್ಸನ್ನು ಕೊಡುವ ಎಬಿಲಿಟಿ ಇರುವ ಆಸಿಡ್ಸ್. ದೇರ್ಫೋರ್ ಆಸಿಡ್ ಅನ್ನೋದು ಒಂದು H+ ಅಯಾನ್ಗಿಂತ ಜಾಸ್ತಿ H+ ಅಯಾನ್ಸನ್ನು ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಲೈಕ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅ ಪಾಲಿಬೇಸಿಕ್ ಆಸಿಡ್. H3PO4 ಈಸ್ ಅ ಪಾಲಿಬೇಸಿಕ್ ಆಸಿಡ್. Therefore, ಈ ಆಸಿಡ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ಸನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ನಾನು ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ. ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಡಿಸೋಸಿಯೇಟ್ಸ್ ಟು ಗಿವ್ H+ and HSO4- ಇನ್ ಸ್ಟೆಪ್ 1 ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್. ಆ ಥರ ಆದಾಗ ಅದರ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟನ್ನು Ka1 ಅಂತ ಅನ್ಕೋಬೋದು. ಎರಡನೇ ಆಸಿಡ್ ಇಲ್ಲಿ ಬಂದುಬಿಟ್ಟು HSO4- ಆಗುತ್ತೆ. ಈ HSO4- ಡಿಸೋಸಿಯೇಟ್ ಆದರೆ ಅದು H+ ಮತ್ತು SO4- ಆಗುತ್ತೆ. ಇದು Ka2 ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ನಂಬರ್ 2. ಇದು ಫಸ್ಟ್ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ಇದು ಸೆಕೆಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಈಗ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದ ವಿಷಯ ಏನಂತಂದರೆ, ಈ ಎರಡು ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಕೂಡ ಒಂದೇ ಆ್ಯಸಿಡ್ರಿಂದ ಬಂದಿದ್ದ ಎರಡು ಆ್ಯಸಿಡ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ದಾವೆ. ಅಂದರೆ ಫಸ್ಟ್ ಬಂದುಬಿಟ್ಟು ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ H2SO4, ಎರಡನೇದು ಬಂದುಬಿಟ್ಟು ಬೈಸಲ್ಫೇಟ್ ಅಯಾನ್ HSO4-. ಈ ಎರಡೂ ಕೂಡ ನಮಗೆ ಇಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಕಮಿಂಗ್ ಟು ದ ಪಾಯಿಂಟ್ ಹಿಯರ್, ವಾಟ್ ವಿ ಆರ್ ಸಪೋಸ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಸ್, ಈ ಫಸ್ಟ್ ಆ್ಯಸಿಡ್ನ ಇದು ಸ್ಟ್ರಾಂಗರ್ ಆ್ಯಸಿಡಾ ಇದು ಸ್ಟ್ರಾಂಗರ್ ಆ್ಯಸಿಡಾ ಅನ್ನುವ ಕ್ವೆಶ್ಚನ್ ಬಂದಿದಾಗ ನಮಗೆ ಫಸ್ಟ್ ಆ್ಯಸಿಡ್ ಏನಿದೆ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್, ಇದು ಯಾವಾಗಲೂ ಸ್ಟ್ರಾಂಗರ್ ಆ್ಯಸಿಡ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ Ka1 ಅನ್ನೋದು ಇಟ್ ಈಸ್ ಆಲ್ವೇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ Ka2. ದೇರ್ಫೋರ್ Ka1 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ Ka2 is what we need to understand here. And therefore what we need to also understand here is Ka is not just greater than Ka2, it is far much greater than Ka1 is far much greater than Ka2. Coming to sulfuric acid and bisulfate ions, this particular relation tells us that sulfuric acid is a stronger acid than bisulfate ion. What is the reason behind this? ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾಗ ಇದರಲ್ಲಿ ಇದು ನ್ಯೂಟ್ರಲ್ ಮಾಲಿಕ್ಯೂಲ್. ಇದು ಈ ನ್ಯೂಟ್ರಲ್ ಮಾಲಿಕ್ಯೂಲ್ ಇರುವುದರಿಂದ ಈ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ ಏನಿದೆ, ಈ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ನಿಂದ H+ ಅಯಾನನ್ನು ತೆಗೆಯೋದು ತುಂಬ ಈಸಿ ಆಗುತ್ತೆ. ಆದರೆ when we consider bisulfate ion here, ಈ bisulfate ion ಅನ್ನೋದು ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಅಯಾನ್ ಆಗಿರೋದ್ರಿಂದ ಈ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಅಯಾನ್ರಿಂದ ಒಂದು H ಪ್ಲಸ್ ಅಂದರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜನ್ನು, ಒಂದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ನಿಂದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜನ್ನು ತೆಗೆಯೋದು ತುಂಬ ಕಷ್ಟ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಈ ಡಿಸೋಸಿಯೇಷನ್ ತುಂಬ ಕಮ್ಮಿಯಾಗಿ Ka2 is always greater than Ka1. I mean Ka1 is always greater than Ka2 ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ. Therefore Ka1 ಅನ್ನೋದು ತುಂಬ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಈ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಆ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಎರಡೂ ಕೂಡ ಒಂದೇ ವೆಸಲ್ನಲ್ಲಿ ಒಂದೇ ಸತ ಫಸ್ಟ್ ಆ್ಯಸಿಡ್ರಿಂದಾನು H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಬರ್ತಿದ್ದಾವೆ, ಸೆಕೆಂಡ್ ಆ್ಯಸಿಡ್ರಿಂದಾನು H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಬರ್ತಿದ್ದಾವೆ. ಆದರೆ ಫಸ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ಡಿಸೋಸಿಯೇಷನ್ ತುಂಬ ಜಾಸ್ತಿ ಇದೆ, ಎರಡನೇ ಕೇಸ್ನಲ್ಲಿ ಡಿಸೋಸಿಯೇಷನ್ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಇದೆ. ಇದರ ಪ್ರಕಾರ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದೆ ಏನಂತಂದರೆ ಈ ಫಸ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ಬಂದಿದ್ದ ಜಾಸ್ತಿ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ನ ನಂಬರ್ ಏನಿದೆ ಅದನ್ನು ಮಾತ್ರ ನಾವು ಈ ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟ್ನಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ಇದನ್ನು ಇಗ್ನೋರ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಯಾಕಂದರೆ ಈ ಫಸ್ಟ್ ಡಿಸೋಸಿಯೇಷನ್ ಆದಮೇಲೆ ಇದು ಖಂಡಿತ ಇದರ ಮೇಲೆ ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟನ್ನು ತೋರಿಸುತ್ತೆ. ಈ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಇಲ್ಲಿ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಜಾಸ್ತಿ ಅದಾವೆ, ಇಲ್ಲಿ ಜಾಸ್ತಿ ಅದಾವೆ, ಇವು ಕಮ್ಮಿ ಅದಾವೆ. Therefore ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆದಾಗ ರಿಯಾಕ್ಷನ್ ರಿವರ್ಸ್ ಹೋಗುತ್ತೆ ಅನ್ನೋ ವಿಷಯ ನಿಮಗೆ ಗೊತ್ತಿದೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ಲೀ-ಶಾರ್ಟ್ಲೆಸ್ ಪ್ರಿನ್ಸಿಪಲ್. ಹಾಗಾಗಿ ಈ ಡಿಸೋಸಿಯೇಷನ್ ತುಂಬ ವೀಕ್ ಆಗತ್ತೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಎರಡರಲ್ಲಿ ಯಾವುದರಿಂದ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು ನಾವು ಅಂತಂದರೆ ಫಸ್ಟ್ ಡಿಸೋಸಿಯೇಷನ್ರಿಂದ ಬಂದಿದ H ಪ್ಲಸ್ ಅಯಾನ್ಸನ್ನು ಮಾತ್ರ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟ್ನಲ್ಲಿ ಯಾವಾಗಲೂ ಕೂಡ ಸ್ಟ್ರಾಂಗರ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ರಿಂದ ಬಂದಿದ್ದ ಕಾಮನ್ ಅಯಾನ್ ಏನಿರುತ್ತೆ ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಮಾತ್ರ ನಾವು ಆ್ಯಕ್ಚುಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ ತಗೋಬೇಕಾಗತ್ತೆ. ಈಗ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ನೋಡೋಣ. ಈಗ ಇದಾದ ನಂತರ ನಾವು ಇನ್ನೊಂದು ವಿಷಯ ತಿಳ್ಕೋಬೇಕು. ಒಂದು ವೇಳೆ ನನಗೆ ಓವರಾಲ್ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಬೇಕಂದರೆ ಮಾತ್ರ ಓವರಾಲ್ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ Ka ಈಕ್ವಲ್ಸ್ Ka1 ಇಂಟು Ka2 ಇದು ತಿಳ್ಕೋಬೇಕು. ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಅನ್ ಆ್ಯಸಿಡ್. ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಅನ್ ಆ್ಯಸಿಡನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಆನ್ ಆ್ಯಸಿಡ್ ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಇದನ್ನು ಒಂದು ಪೀರಿಯಡ್ನಲ್ಲಿ ಒಂದು ಗ್ರೂಪ್ನಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ವಿ. ಒಂದು ಗ್ರೂಪ್ನಲ್ಲಿ ಯಾವ ತರಹ ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಅನ್ ಆ್ಯಸಿಡ್ ಚೇಂಜ್ ಆಗತ್ತೆ ಅನ್ನೋದನ್ನು ನಾವು ನೋಡೋಣ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ HF, HCl, HBr, HI ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಆ್ಯಸಿಡ್ಸ್ನಲ್ಲಿ ಯಾವ ತರಹ ಎಸಿಡಿಕ್ ಸ್ಟ್ರೆಂಗ್ತ್ ವೇರಿ ಆಗ್ತಾ ಇದೆ ಅಂತ ನೋಡಿದರೆ ಟಾಪ್ ಟು ಬಾಟಮ್ ನಮಗೆ ಸೈಜ್ ಅನ್ನೋದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಡಿಕ್ರೀಸ್ ಆಗತ್ತೆ. ಹಾಗಾಗಿ HFಗಿಂತ ಕೂಡ HI ಈಸ್ ಅ ವೆರಿ ಗುಡ್ ಆ್ಯಸಿಡ್. ದೇರ್ಫೋರ್ ಟಾಪ್ ಟು ಬಾಟಮ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸಸ್, ಹಾಗಾಗಿ ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಡಿಕ್ರೀಸಸ್. ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಡಿಕ್ರೀಸ್ ಆಗಿದ್ದಕ್ಕೆ ಈ H ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಬಹಳ ಬೇಗ ರಿಲೀಸ್ ಆಗ್ತವೆ, ಜಾಸ್ತಿ ರಿಲೀಸ್ ಆಗ್ತವೆ. ಅದಕ್ಕೆ HI ಅನ್ನೋದು ಸ್ಟ್ರಾಂಗರ್ ಆ್ಯಸಿಡ್ ಅನ್ನುವ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಸೊ ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಆ್ಯಸಿಡ್ ಇನ್ಕ್ರೀಸಸ್. ಇದೇ ನಾವು ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಆ್ಯಸಿಡ್ ಇನ್ಕ್ರೀಸಸ್ ಅಂತ ಅರ್ಥ ಮಾಡಿಕೊಳ್ತಾ ಇದ್ವಿ. ಇದು ನಾನು 17th ಗ್ರೂಪ್ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಅದು ಯಾವ ಗ್ರೂಪ್ಗಾದರೂ ಕೂಡ ಇದೇ ತರಹ ನಾವು ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ HI ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್, HBr ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್, HCl ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ HF. ಇದು ಗ್ರೂಪ್ 17ಗೆ ಬಂದಾಗ. ಗ್ರೂಪ್ 16ಗೆ ಬಂದಾಗ H2TE ಗ್ರೇಟರ್ ದ್ಯಾನ್, H2SE ಗ್ರೇಟರ್ ದ್ಯಾನ್, H2S ಗ್ರೇಟರ್ ದ್ಯಾನ್ H2O ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಗ್ರೂಪ್ 17ಗೆ ಬಂದಾಗ ಇದು ಡಿಫರೆಂಟ್ ಇರುತ್ತೆ. ಗ್ರೂಪ್ 17ನಲ್ಲಿ H2 NH3 ಏನಿದೆ ಈ NH3ಗಿಂತ ಕೂಡ ನಮಗೆ BiH3 is the strongest acid of all, and then comes stibium or antimony hydride SpH3 ಬರುತ್ತೆ. ಅದಾದ ನಂತರ ಆರ್ಸಿನಸ್ ಹೈಡ್ರೈಡ್ AsH3 ಅನ್ನೋದು ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಬಂದುಬಿಟ್ಟು ನಮಗೆ PH3 ಫಾಸ್ಫೀನ್, ಆ್ಯಂಡ್ ದ ವೀಕೆಸ್ಟ್ ಆ್ಯಸಿಡ್ ಅಮಾಂಗ್ ಆಲ್ ಆಫ್ ದೋಸ್ ಈಸ್ ಅಮೋನಿಯಾ. ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಏನಂತಂದರೆ ಇದರಲ್ಲಿ ಈ ಟೋಟಲ್ ಟಾಪ್ ಟು ಬಾಟಮ್ ಅನ್ನೋದು ನಮಗೆ H+ ಅಯಾನ್ಸನ್ನು ರಿಲೀಸ್ ಮಾಡ್ತಾ ಇದೆ ಅಲ್ವಾ, ಯಾವುದು ಹೈಡ್ರೋಜನ್ಸನ್ನು ಕೊಡ್ತಾ ಇದೆ ಅದು ಖಂಡಿತ ಗುಡ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ಟಾಪ್ ಟು ಬಾಟಮ್ ಇನ್ ದ ಗ್ರೂಪ್ ರೆಡ್ಯೂಸಿಂಗ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸಸ್ ಅಂತ ಕೂಡ ನಾವು ತಿಳ್ಕೋಬೇಕು. ರೆಡ್ಯೂಸಿಂಗ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸಸ್ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಎಬಿಲಿಟಿ ಟು ಗಿವ್ H+ ions increases from top to bottom. The next important thing that we need to take a look at is the strength of the conjugate bases. Let us take a look at that. HF, HCl, HBr, HI ಗಳಲ್ಲಿ HI, HBr and then HCl and then HF ಈ ಆರ್ಡರ್ ಇದೆ ಅಲ್ವಾ, ಇವುಗಳ ಕಾಂಜುಗೇಟ್ ಬೇಸಸ್ ಅಂದರೆ I- Br- Cl- F- ಗಳಲ್ಲಿ ಯಾವುದು ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ಬೇಸ್ ಅಂತ ಅಂದರೆ F-, then Cl-, then Br-. So it is opposite to the strength of conjugate bases is opposite to the strength of branched acids order. ಈ ವಿಷಯವನ್ನು ನಾವು ತಿಳ್ಕೋಬೇಕು, ಇದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್. Let us go to the next important thing. What we are supposed to understand next is, ಇದಾದ ನಂತರ we are now focusing on the next important part, which is the strength of acid in a period. ಒಂದು ಪೀರಿಯಡ್ನಲ್ಲಿ ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಆಸಿಡ್ ಯಾವ ತರಹ ಇದೆ ಅನ್ನೋದನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಆಸಿಡ್ ಇನ್ ಅ ಪೀರಿಯಡ್ ಅಂದರೆ ಮೀಥೇನ್, ಅಮೋನಿಯಾ, H2O ಅನಂತರ HFಗಳಲ್ಲಿ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಸೈಡ್ ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಎಬಿಲಿಟಿ ಟು ರಿಲೀಸ್ H+ ಅಯಾನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಎಸಿಡಿಕ್ ಸ್ಟ್ರೆಂಗ್ತ್ ಏನಿದೆ ಅದು ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ದೇರ್ಫೋರ್ ಮೀಥೇನ್, ಅಮೋನಿಯಾ, ವಾಟರ್, HFಗಳಲ್ಲಿ HF is the strongest acid, then comes H2O, then comes ammonia and finally it ends with methane. ಇದು ಆರ್ಡರ್. ಇನ್ ಅ ಪೀರಿಯಡ್ ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗೋದನ್ನು ನೋಡಬೇಕು, ಇನ್ ಅ ಗ್ರೂಪ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗೋದನ್ನು ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಲೆಟ್ಸ್ ಪ್ರೊಸೀಡ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್. ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್ ದಟ್ ಐ ಆಮ್ ಟ್ರೈಂಗ್ ಟು ಟೆಲ್ ಯು ಈಸ್ ದ ಕ್ವೆಶ್ಚನ್ಸ್ ಆನ್ ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟ್. ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಂದ್ರೆ, ವೆನ್ ಐ ಕನ್ಸಿಡರ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್, ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ತರಹ ಒಂದು ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಏನಿದೆ, ಈ ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಎಸಿಟೇಟ್ ಮತ್ತು H+ ಅಯಾನ್ಸನ್ನು ಕೊಡ್ತಾ ಇದೆ. ಇದಕ್ಕೆ ನಾನು ಕಾಮನ್ ಅಯಾನ್ ಇರುವಂತಹ ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟನ್ನು HCl ಅನ್ನು ಹಾಕಿದರೆ ಇದರಿಂದ ಕೂಡ H+ ಮತ್ತು Cl- ಅಯಾನ್ಸ್ ಬರ್ತವೆ. ಆದರೆ ಇಲ್ಲಿಂದ ಬಂದಿದ್ದ H+ ಅಯಾನ್ಸ್ ತುಂಬ ಕಮ್ಮಿ ಇರ್ತವೆ, ಇಲ್ಲಿಂದ ಬಂದಿದ್ದ H+ ಅಯಾನ್ಸ್ ತುಂಬ ಜಾಸ್ತಿ ಇರ್ತವೆ. ಈ ಥರ ಈ HClನಿಂದ ಬಂದಿದ್ದ H+ ಅಯಾನ್ಸ್ ತುಂಬ ಜಾಸ್ತಿ ಇರುವುದರಿಂದ ನಾನು ಈ H+ ಅಯಾನ್ಸನ್ನು ಕೌಂಟಿಗೆ ತಗೋಬೇಕಾ, ಇದನ್ನು ಕೌಂಟಿಗೆ ತಗೋಬೇಕಾ ಅಂದರೆ ಈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎದುರುಗಡೆ ಇದು ತುಂಬ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದರೆ ಅದು ತುಂಬ ಕಮ್ಮಿ ಇರುತ್ತೆ ಡ್ಯೂ ಟು ಕಾಮನ್ ಅಯಾನ್ ಎಫೆಕ್ಟ್. ಈ ಅಯಾನ್ಸ್ ಎಲ್ಲ ಸೇರಿ ಮತ್ತೆ ವಾಪಸ್ ಕಂಬೈನ್ ಆಗಿ ಹೋಗಿಬಿಡ್ತವೆ. ಸೊ ಬಹಳ ಕಮ್ಮಿ H+ ಅಯಾನ್ಸ್ ಇಲ್ಲಿ ಉಳಿದಿರ್ತವೆ. ಸೊ ಕಾಮನ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಯಾವತ್ತೂ ಕೂಡ ನಾವು ಹೇಗೆ ತಗೋಬೇಕು ಅಂತಂದರೆ ಕೇವಲ H+ ಅಯಾನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಫ್ರಮ್ HCl ತಗೋಬೇಕು. ಸೊ ಕಾಮನ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನೇ ಕಾಮನ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. ಈಗ ಇದು H+ ಆಯಿತು. ಈಗ ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು 0.1 ಮೋಲಾರ್ HCl, 0.01 ಮೋಲಾರ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ತೊಗೊಂಡಿದ್ದೀನಿ ಅನ್ಕೋ. ಆವಾಗ ನಾನು H+ ಅಯಾನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಾಗಿ ತಗೋಬೇಕು, ಇದು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಆಗಿರೋದ್ರಿಂದ ಇದು ಪೂರ್ತಿ ಡಿಸೋಸಿಯೇಟ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಇದು 0.1 ಮೋಲಾರ್, ಇದು 0.1 ಮೋಲಾರ್ ಬರುತ್ತೆ. ಸೊ H+ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಇದು ಇಗ್ನೋರ್ ಮಾಡಿ ಇದು ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. Cl- ಅಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ನಲ್ಲಿ 0.1 ಮೋಲಾರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ನ ತಗೋಬೇಕು. ಮತ್ತು ಎಸಿಟೇಟ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ನ ಯಾವತ್ತು ತಗೋಬೇಕು, ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದು 0.01 ಆದರೂ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದ್ದೇನೂ ಇಲ್ಲ ಅಲ್ಲಿ. ದೇರ್ ಫಾರ್ ಎಸಿಟೇಟ್ ಅಯಾನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನೋದು ತುಂಬ ಕಮ್ಮಿ ಇರುತ್ತೆ. ದೇರ್ ಫಾರ್ ಅದನ್ನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂತಂದರೆ ವಿ ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ್ಯಾಟ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ತಗೋಬೇಕಾಗತ್ತೆ. ಸೊ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಈಸ್ ಟು ಬಿ ಟೇಕನ್ ಫುಲ್ಲಿ, ಯಾಕಂದರೆ ಅದರಿಂದ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದ್ದು ಏನೂ ಇಲ್ಲ. ಈಗ ನಾನು ಇದೆಲ್ಲ ಯೂಸ್ ಮಾಡಿ ಎಸಿಟೇಟ್ ಅಯಾನ್ಸನ್ನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ನನಗೆ ಕೆ ಎ ವ್ಯಾಲ್ಯೂ ಬೇಕೇ ಬೇಕಾಗತ್ತೆ. ಸೊ ಕೆ ಎ ವ್ಯಾಲ್ಯೂ 1.8 × 10⁻⁻⁵. ಅದು ಎಂಥ ಕಾಮನ್ ಅಯಾನ್ ಎಫೆಕ್ಟ್ ಬಂದಿದ್ರು ಕೆ ಎ ಅನ್ನೋದು ಚೇಂಜ್ ಆಗಲ್ಲ, ಇಟ್ ರಿಮೇನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ದೇರ್ ಫೋರ್ ಕೆ ಎಗೆ ಒಂದು ಈಕ್ವೇಷನ್ ಬರೆದುಕೊಂಡು ಅದರಲ್ಲಿ ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಎಸಿಟೇಟ್ ಮತ್ತು H+ ಅಯಾನ್ಸನ್ನು ಬರೆದು ಡಿವೈಡೆಡ್ ಬೈ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡನ್ನು ಬರೆದು, ಅಂದರೆ ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬೈ ರಿಯಾಕ್ಟೆಂಟ್ಸನ್ನು ಬರೆಯಬೇಕು. ಈಗ ಕೆ ಎ ಪ್ಲೇಸ್ನಲ್ಲಿ 1.8 × 10⁻⁻⁵ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಎಸಿಟೇಟ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿದೆ ಅಂತ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೀನಿ. H+ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಿದೆ ಅದು ನಾನು ಇಲ್ಲಿಂದ ತಗೋಬಾರ್ದು, ಯಾಕಂದರೆ ಇದು ತಗೋಬೇಕು. ದೇರ್ ಫೋರ್ ಅದು 10⁻⁻⁻1 ಇರುತ್ತೆ. ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಆಲ್ಮೋಸ್ಟ್ ಏನು ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದ್ದೇ ಇಲ್ಲ, ದೇರ್ ಫೋರ್ 0.01 ಆಗುತ್ತೆ. ನಾನು ಈ ಎರಡು ತಗೊಂಡು ಈ ಕಡೆ ಬಂದರೆ ಈ 10⁻⁻1 0.01ನಲ್ಲಿ 10⁻⁻1 ಟೈಮ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಈಗ 1.8 × 10⁻⁻6 is a concentration of acetate ion ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ತಿಳ್ಕೋಬೇಕಾಗತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ದಿಸ್ ಇಸ್ ದ ಹೋಲ್ ಥಿಂಗ್ that we need to understand to make calculations with regard to common ion effect. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಅನ್ನೋದು ಒಂದು ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್, ಅದು ಡಿಸೋಸಿಯೇಟ್ ಆಗೋದೇ ಕಮ್ಮಿ. ನಾನು ಅದರಲ್ಲಿ ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್, ಅದು ಕೂಡ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡಿನ ಅಯಾನ್ಸ್ಗೆ ಕಾಮನ್ ಅಯಾನ್ ಇರುವಂತಹ ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟನ್ನು ಹಾಕಿದ್ದೀನಿ. ಈ ಥರ ಹಾಕಿದ ಮೇಲೆ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದರೆ ಈ HCl ಅನ್ನೋದು H+ ಮತ್ತು Cl- ಅಯಾನ್ಸ್ ಆಗಿ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿಬಿಟ್ಟು ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, H+ ಅಯಾನ್ಸ್ನ ನಂಬರ್ ಬಹಳ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಅಂದರೆ ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತುಂಬ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಈ ಪ್ರಾಡಕ್ಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದ್ದ ಕಾರಣಕ್ಕೆ ನಮಗೆ ರಿಯಾಕ್ಷನ್ ಎಲ್ಲ ಕೂಡ ರಿವರ್ಸ್ ಹೋಗ್ತಾ ಇದೆ. ಹಾಗಾಗಿ ಕಾಮನ್ ಅಯಾನ್ ಎಫೆಕ್ಟನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೊಳ್ತಾ ಇದ್ವಿ. ಇದರಲ್ಲಿ ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಏನಂತಂದರೆ, ಒಂದು ವೇಳೆ ನಮಗೆ ಎಸಿಟೇಟ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಂಥ ಕ್ವೆಶ್ಚನ್ ಕೊಟ್ಟಿದ್ದಾಗ ನಾವು ಯಾವ ಥರ ಮಾಡಬೇಕು, ಇಲ್ಲಿ H+ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆ್ಯಸಿಡ್ ಕಾನ್ಸಂಟ್ರೇಷನೇ, Cl- ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನೇ. ಎಸಿಟೇಟ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗೊತ್ತಿಲ್ಲ, ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಬಟ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನಿಷಿಯಲಿ ಏನು ತೊಗೊಂಡಿರ್ತಾರೆ ಅದನ್ನೇ ತಗೋಬೇಕು. ಕಾರಣ ಏನಂದರೆ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಅನ್ನೋದು ಡಿಸೋಸಿಯೇಟ್ ಆಲ್ಮೋಸ್ಟ್ ಆಗೇ ಇಲ್ಲ, ಹಾಗಾಗಿ ಅದನ್ನೇ ತಗೋಬೇಕು. ಆ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸನ್ನು ನಾನು ಕರೆಕ್ಟಾಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಕೆ ಎದೊಂದಿಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ನನಗೆ ಎಸಿಟೇಟ್ ಅಯಾನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬರುತ್ತೆ. ಇದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಗೆ ಹೋಗೋಣ. ಇದರ ಮೇಲೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಇದೆ, ಸಾಲ್ವ್ ಮಾಡೋಣ. ಇದು ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ H2A ಕೊಟ್ಟಿದ್ದಾರೆ. H2A ಅನ್ನೋದು ಒಂದು ಡೈಬೇಸಿಕ್ ಆ್ಯಸಿಡ್. ಈ H2Aಗೆ ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ವಿಚ್ ಈಸ್ 8.1 × 10⁻⁻8. ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಿದ್ದಾರೆ, 0.1 mole ಆಫ್ H2A ಅನ್ನು 1 molar 1 liter 0.1 molar 1 liter HCl ನಲ್ಲಿ ಹಾಕಿದ್ದಾರೆ. ನಿಮಗೆ ಅರ್ಥ ಆಗುತ್ತೆ, HCl is a strong electrolyte, H2A is a weak electrolyte, weak dibasic mono acid, dibasic acid. ಇದು ಈ dibasic acid is a weak electrolyte. ಈ weak electrolyteಗೂ ಆ HClಗೂ ಮಧ್ಯದಲ್ಲಿ ಕಾಮನ್ ಅಯಾನ್ ಇದೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಅದರ ಪ್ರಕಾರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ HA- ಅನ್ನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಈ ಥರ ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, H2A ಯಾವ ಥರ ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ತಾ ಇದೆ ನೋಡಬೇಕು. ಅದು HA- ಮತ್ತು H+ ಆಗ್ತಾ ಇದೆ. ಅದೇ ರಿಯಾಕ್ಷನ್ ವೆಸಲ್ನಲ್ಲಿ HCl ಕೂಡ ಇದೆ. ಅಂದರೆ H+ ಮತ್ತು Cl- ಆಗಿ ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ತಾ ಇದೆ. ಅದು ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ಗೆ ಈಕ್ವೇಷನ್ ಬರೆದು HA- ಅಂತ ಬರೆದು H+ ಅಂತ ಬರೆದು H2A ಈಕ್ವೇಷನ್ ಬರೆಯಬೇಕು. ಇನಿ ಇದು ಡಿಸೋಸಿಯೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟನ್ನು 8.1 × 10⁻⁸ ಕೊಟ್ಟಿದ್ದಾರೆ. ನಾನು HA- ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೀನಿ. H+ ಅಯಾನ್ ಎರಡು ಕಡೆಯಿಂದ ಬರ್ತಾ ಇದೆ. ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್, ಒಂದು ವೀಕ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಕಾಮನ್ ಅಯಾನ್ ಇದೆ. ಕಾಮನ್ ಅಯಾನಿಂದ ಯಾವಾಗಲೂ ಕೂಡ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ನೇ ತಗೋಬೇಕು. ಅಂದರೆ 0.1 ಮೋಲಾರ್ ಇದಿದ್ದಾಗ ಇದು 0.1 ಮೋಲಾರೇ ಬರುತ್ತೆ. ದೇರ್ಫೋರ್ ಇದನ್ನು 0.1 ಮೋಲಾರ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಈಗ H2A ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ತಗೋಬೇಕು? ಅವರು ಹಾಕಿದ್ದು 0.1 ಮೋಲ್ ಇನ್ 1 ಲೀಟರ್ ಆಫ್ HCl. ಆ 1 ಲೀಟರ್ ಅನ್ನೋದು HClನಲ್ಲಿ ಹಾಕಿದ್ದಾರೆ ಇವರು. ಅಂದರೆ 0.1 ಮೋಲ್ ಇನ್ 1 ಲೀಟರ್ ಅಂದರೆ 0.1 ಮೋಲಾರ್ ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕೂಡ. ದೇರ್ಫೋರ್ ಅದು ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಫೈನಲಿ HA- ಕಾನ್ಸಂಟ್ರೇಷನ್ 8.1 × 10⁻⁸ ಆಗುತ್ತೆ. ಇದಿಷ್ಟು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಗೆ ಹೋಗೋಣ. What we are trying to understand next is buffers. ಬಫರ್ಸ್ಗೆ ಬಂದಾಗ ನಮಗೆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಬಫರ್ಸ್ ಇರ್ತವೆ. ಈ ಬಫರ್ಸ್ನಲ್ಲಿ ಫಸ್ಟ್ ಬಫರ್ ಬಂದ್ಬಿಟ್ಟು ಇಟ್ ಈಸ್ ಅನ್ ಎಸಿಡಿಕ್ ಬಫರ್ ದಟ್ ಐ ವುಡ್ ಲೈಕ್ ಟು ಟಾಕ್ ಅಬೌಟ್. ಎಸಿಡಿಕ್ ಬಫರ್ ಬಗ್ಗೆ ನಾನು ಮಾತಾಡ್ತಿರೋದಾಗ ಇದನ್ನು ಯಾವ ಥರ ತಯಾರಿ ಮಾಡಬೇಕು, ವಾಟ್ ಈಸ್ ದ ಕಾಂಪೋಸಿಷನ್ ಆಫ್ ಆ್ಯನ್ ಎಸಿಡಿಕ್ ಬಫರ್ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ, ಎಸಿಡಿಕ್ ಬಫರ್ ಈಸ್ ಆ್ಯಕ್ಚುಲಿ ಕಂಟೈನಿಂಗ್ ವೀಕ್ ಆ್ಯಸಿಡ್. ವೀಕ್ ಆ್ಯಸಿಡ್ದಿಂದ ಆಮೇಲೆ ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್, ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ದಿಂದ ಮಾತ್ರ ಇದನ್ನು ತಯಾರಿ ಮಾಡಲು ಸಾಧ್ಯವಾಗತ್ತೆ. ಇದು ಈ ಥರ ತಗೋಬೋದು. ಇನ್ ಎನಿ ಕಾಂಪೋಸಿಷನ್ ಈ ತರಹ ನಾವು ಯಾವ ಕಾಂಪೋಸಿಷನ್ನಲ್ಲಾದರೂ ಕೂಡ ತಗೋಬೋದು. ಅಂದರೆ ಇದು ಹೆಚ್ಚು ತಗೋಬೋದು, ಅದು ಕಮ್ಮಿ ತಗೋಬೋದು, ಇದು ಕಮ್ಮಿ ಅದು ಹೆಚ್ಚು ತಗೋಬೋದು, ಎರಡೂ ಈಕ್ವಲ್ ತಗೋಬೋದು. ಯಾವ ಥರ ತಗೊಂಡ್ರೂ ಕೂಡ ಬಫರ್ ಬರುತ್ತೆ. ಆದರೆ ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಏನಂದರೆ ಇದರಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಕನ್ಸಿಡರ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಪ್ಲಸ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ವೀಕ್ ಆ್ಯಸಿಡ್ ಮತ್ತು ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ಗಳನ್ನು ಮಿಕ್ಸ್ ಮಾಡ್ತಾ ಕೂಡ ನೀನೊಂದು ಎಸಿಡಿಕ್ ಬಫರನ್ನು ತಯಾರಿ ಮಾಡ್ಬೋದು. ಆದರೆ ಇದು ತಯಾರಿ ಮಾಡಬೇಕಂದ್ರೆ ಮಾತ್ರ ಕಂಡೀಷನ್ ಏನಂತಂದರೆ ವೀಕ್ ಆ್ಯಸಿಡ್ ಶುಡ್ ಆಲ್ವೇಸ್ ಬಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ಈ ಕಾಂಪೋಸಿಷನಲ್ಲಿ ತಗೊಂಡ್ರೆ ಮಾತ್ರ ನಮಗಿದು ಬರುತ್ತೆ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಎಸಿಡಿಕ್ ಬಫರ್ ತಗೋಬೇಕು ಅಂದ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. 0.1 ಮೋಲಾರ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡನ್ನು ತಗೊಂಡಿದ್ದೀನಿ. 0.1 ಮೋಲಾರ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಜೊತೆಗೆ 0.1 ಮೋಲಾರ್ ಸೋಡಿಯಂ ಆಸಿಟೇಟ್. ಸೋಡಿಯಂ ಆಸಿಟೇಟ್ ಅಂದರೆ ಸಾಲ್ಟ್ ಆಫ್ ದ ಸೇಮ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ಅನದರ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ಎರಡಿನ ಕಾಂಬಿನೇಷನ್ನಲ್ಲಿ ಬಂದಿದ್ದು. ಇದು ಈಕ್ವಲ್ ತಗೋಬೋದಾ? ಬಫರ್ ಬರುತ್ತಾ? ಖಂಡಿತ ಬರುತ್ತೆ. ಇದು ಜಾಸ್ತಿ ಅದು ಕಮ್ಮಿ ತಗೋಬೋದು, ಬಫರ್ ಬರುತ್ತೆ. ಇದು ಕಮ್ಮಿ ಅದು ಜಾಸ್ತಿ ತಗೋಬೋದಾ? ಆವಾಗ ಕೂಡ ಬಫರ್ ಬರುತ್ತೆ. ಬಟ್ when you take 0.1 molar acetic acid plus 0.1 molar sodium hydroxide ಆವಾಗ ಬಫರ್ ಬರೋದಿಲ್ಲ. ಯಾಕೆ ಬರಲ್ಲ ಅಂತಂದರೆ ಇದು ವೀಕ್ ಆ್ಯಸಿಡೇ, ಅದು ಸ್ಟ್ರಾಂಗ್ ಬೇಸೇ, ಕಂಬೈನ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಈಕ್ವಲ್ಲಿ ಕಂಬೈನ್ ಮಾಡಿದ್ದಕ್ಕೆ ನಿನಗೇನು ಬರುತ್ತೆ ಅಂತಂದರೆ ಒಂದು ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಬರುತ್ತೆ. ಬಟ್ ನನಗೆ ಬಫರ್ ಬೇಕಂದರೆ ವೀಕ್ ಆ್ಯಸಿಡ್ ಎಕ್ಸಸ್ ಇರಬೇಕು. ಹಾಗಾಗಿ ಇದನ್ನು 0.2 ಮೋಲಾರ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಪ್ಲಸ್ 0.1 ಮೋಲಾರ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ತಗೋಬೇಕಾಗತ್ತೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಈಗ ಬೇಸಿಕ್ ಬಫರ್ ಬಗ್ಗೆ ಮಾತಾಡೋಣ. ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ಅ ಬೇಸಿಕ್ ಬಫರ್, ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್ ಇಸ್ ಯಾವ ಕಾಂಪೋಸಿಷನ್ನಲ್ಲಾದರೂ ತಗೋಬೋದು ಅಂತಂದರೆ ಆವಾಗ ಬೇಸಿಕ್ ಬಫರ್ ತಯಾರಿಗೋಸ್ಕರ ವೀಕ್ ಬೇಸ್ ಮತ್ತು ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್, ವೀಕ್ ಬೇಸ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ತಗೋಬೇಕು. ಇದು ಯಾವ ಕಾಂಬಿನೇಷನಲ್ಲಾದರೂ ತೊಗೋಬೋದು. ಸಾಲ್ಟ್ ಬೇಸ್ ತೊಗೊಂಡ್ರೆ ಎನಿ ಕಾಂಪೊಸಿಷನಲ್ಲಿ ತೊಗೋಬೋದು. ಬಟ್ ನಾನು ವೀಕ್ ಬೇಸ್ ತೊಗೊಳ್ತೀನಿ ಆದರೆ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ತೊಗೊಳ್ತೀನಿ ಎರಡು ಕಾಂಬಿನೇಷನ್ ಅಂತಂದರೆ ಮಾತ್ರ ವೀಕ್ ಬೇಸ್ ಶುಡ್ ಆಲ್ವೇಸ್ ಬಿ ಟೇಕನ್ ಎಕ್ಸೆಸ್ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್. ಅಂದರೆ 0.1 ಮೋಲಾರ್ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಪ್ಲಸ್ 0.1 ಮೋಲಾರ್ ಅಮೋನಿಯಂ ಕ್ಲೋರೈಡ್ ತಗೊಂಡಿದ್ದಿ ಅಂತ ಅನ್ಕೋ, ಇದು ವೀಕ್ ಬೇಸ್ ಪ್ಲಸ್ ಸಾಲ್ಟ್, ಅವಾಗ ಎರಡು ಈಕ್ವಲ್ ತಗೋಬೋದು, ಇದು ಜಾಸ್ತಿ ಇದು ಕಮ್ಮಿ ತಗೋಬೋದು, ಏನೇ ಪ್ರಾಬ್ಲಮ್ ಬರಲ್ಲ. ಬಟ್ ವೆನ್ ಯು ಕನ್ಸಿಡರ್ 0.1 ಮೋಲಾರ್ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಪ್ಲಸ್ 0.1 ಮೋಲಾರ್ HCl ಈ ಕಾಂಬಿನೇಷನ್ ತಗೊಳ್ತೀನಿ ಅಂತಂದರೆ ಮಾತ್ರ ಇದು ವೀಕ್ ಬೇಸ್, ಅದು ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್, ಈ ಎರಡರಲ್ಲಿ ನಮಗೆ ಬೇಸ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರಬೇಕು. ಹಾಗಾಗಿ ಇದು 0.2 ಮೋಲಾರ್ ಇರಬೇಕು ಅಥವಾ ಇನ್ನೂ ಜಾಸ್ತಿ ಇರ್ಬೋದು, ಬಟ್ ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಮಾತ್ರ ಇರಬಾರ್ದು. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ದಟ್ ವಿ ನೀಡ್ ಟು ನೋ. ಎನಿವೆ, ಇದು ಬೇಸಿಕ್ ಬಫರ್ ಬಗ್ಗೆ. ಈಗ ನಾನು ಇದರ ನಂತರ ನ್ಯೂಟ್ರಲ್ ಬಫರ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ. ಒಂದು ನ್ಯೂಟ್ರಲ್ ಬಫರನ್ನು ಯಾವ ತರಹ ತಯಾರಿ ಮಾಡ್ಬೋದು ಅಂತ ನಾವು ವಿಚಾರ ಮಾಡಿದರೆ, ನ್ಯೂಟ್ರಲ್ ಬಫರ್ ವೆನ್ ವಿ ಕನ್ಸಿಡರ್, ಈ ನ್ಯೂಟ್ರಲ್ ಬಫರ್ ಈಸ್ ಜಸ್ಟ್ ಅ ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ವೀಕ್ ಬೇಸ್. ಒಂದು ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಮತ್ತು ವೀಕ್ ಬೇಸಿನ ಕಾಂಬಿನೇಷನ್ನೇ ನಾವು ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ನ್ಯೂಟ್ರಲ್ ಬಫರನ್ನು ತೊಗೊಳ್ತಾ ಇದ್ವಿ. ಅಂದರೆ ಅವಾಗ ವೀಕ್ ಆ್ಯಸಿಡ್ ಜಾಸ್ತಿ ತೊಗೊಳ್ಳೋದು, ವೀಕ್ ಬೇಸ್ ಜಾಸ್ತಿ ತೊಗೊಳ್ಳೋದು ಆಗಬಾರ್ದು, ಎರಡು ಈಕ್ವಲ್ ಆಗಿ ತೊಗೋಬೇಕು. ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ವೀಕ್ ಬೇಸ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್, ದೆನ್ ಓನ್ಲಿ ದೇ ಕ್ಯಾನ್ ನ್ಯೂಟ್ರಲೈಸ್ ಈಚ್ ಅದರ್. ಈ ಎಸಿಡಿಕ್ ಬಫರಿನ pH ಯಾವ ಥರ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅಂತಂದರೆ, pH ಈಕ್ವಲ್ಸ್ pKa ಪ್ಲಸ್ ಲಾಗ್ ಸಿ ಅನ್ನುವ ಫಾರ್ಮುಲಾದಿಂದ, ಐ ಮೀನ್ ಲಾಗ್ ಸಾಲ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಡಿವೈಡೆಡ್ ಬೈ ಆಸಿಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನುವ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿ ನಾವು ಈ ಎಸಿಡಿಕ್ ಬಫರ್ಗೆ pH ಅನ್ನು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕು. ಬೇಸಿಕ್ ಬಫರ್ಗೆ POH ಅನ್ನು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡ್ತೀವಿ. POH ಈಕ್ವಲ್ಸ್ pKb ಪ್ಲಸ್ ಲಾಗ್ ಆಫ್ ಸಾಲ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಡಿವೈಡೆಡ್ ಬೈ ಬೇಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬರುತ್ತೆ. ಒಂದು ವೇಳೆ pH ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಮಾತ್ರ pH ಪ್ಲಸ್ POH ಈಕ್ವಲ್ಸ್ 14 ಯೂಸ್ ಮಾಡಿ pH ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡ್ಕೋಬೋದು. ಅದು ಬೇಸಿಕ್ ಬಫರ್ ಆಗಿರೋದ್ರಿಂದ ಆ ಥರ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಅದೇ ನ್ಯೂಟ್ರಲ್ ಬಫರಿನ pH ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ 7 ಪ್ಲಸ್ ಹಾಫ್ ಇಂಟು pKa ಮೈನಸ್ pKb ಅನ್ನುವ ಫಾರ್ಮುಲಾನ್ನು ಯೂಸ್ ಮಾಡಿ ನಾವು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ ಈ ಬಫರ್ಸ್ ಮೇಲೆ ಒಂದು ಕ್ವೆಶ್ಚನನ್ನು ನೋಡೋಣ. ನಮಗೆ ಈ ಕ್ವೆಶ್ಚನ್ ಇದೆ, 20 ಮಿಲಿಲೀಟರ್ ಆಫ್ ಅ ಸೊಲ್ಯೂಷನ್ ತಗೊಂಡಿದ್ದಾರೆ ಆಫ್ ಎಸಿಟಿಕ್ ಆಸಿಡ್. 20 ಮಿಲಿಲೀಟರ್ milliliter of acetic acid ತಗೊಂಡಿದ್ದಾರೆ and it required 28.4 milliliter of (0.1 molar sodium hydroxide ನ್ಯೂಟ್ರಲೈಸೇಷನ್ಗೆ. ಅಂದರೆ ಅವರು ಡೈರೆಕ್ಟ್ ಆಗಿ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿದೆ ಅನ್ನೋದು ಕೊಡಲಾರ್ದ ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ಅದನ್ನು ನಾವೇ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡೋ ಹಂಗೆ ಮಾಡಿದ್ದಾರೆ. ಇದು ಯಾವ ಥರ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ, ಇದು ವೀಕ್ ಆ್ಯಸಿಡ್, ಇದು ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್, ದೇರ್ ಫೋರ್ A1 M1 B1 ಈಕ್ವಲ್ಸ್ A2 M2 V2 ಹಾಕಿದರೆ ನಮಗೆ ಎಷ್ಟು ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ಅರ್ಥ ಮಾಡಿಕೋಬೋದು. H+ ಒಂದೇ ಇದೆ, ಅದಕ್ಕೆ A1ನ ವ್ಯಾಲ್ಯೂ 1 ಆಗುತ್ತೆ. M1 ಮೊಲಾರಿಟಿ ಬಂದುಬಿಟ್ಟು ನಮಗೆ ಗೊತ್ತಿಲ್ಲ, ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕು. ವಾಲ್ಯೂಮ್ ಇಸ್ 20 milliliter, A2 value 1, M2 value 0.1 and 28.4 milliliter of volume is what we get. ಈಗ M1 equals 0.1 into 28.4 divided by 20 is what we get. ದೇರ್ಫೋರ್ ಇದು ಸುಮಾರು ನಮಗೆ 2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ 2.84 ಡಿವೈಡೆಡ್ ಬೈ 20 ಬರುತ್ತೆ, ಅಂದರೆ 0.284 ಡಿವೈಡೆಡ್ ಬೈ 2 ಬರುತ್ತೆ, ಅಂದರೆ 0.142 ಮೋಲಾರ್. ಇದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಟೇಕನ್. ಅದು ನಮ್ಮ ಪ್ರಾಬ್ಲಮ್ಗೆ ಫೈನಲ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲವೇ ಅಲ್ಲ. ನಾವು ನೆಕ್ಸ್ಟ್ ನೋಡಬೇಕಾಗಿದ್ದು ಏನಂತಂದರೆ, ಅದರಲ್ಲಿ ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದರ್ ಕ್ವೆಶ್ಚನ್, other part of the question is right here. ಈಗ ಏನು ಮಾಡಿದ್ದಾರೆ, a solution of X is prepared by mixing 20 milliliter of this acid, 20 milliliter of 0.142 molar acetic acid ತಗೊಂಡಿದ್ದಾರೆ. ಅದರ ಜೊತೆಗೆ ಏನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದಾರೆ, 14.2 milliliter of 0.1 ಮೋಲಾರ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದಾರೆ. ಈ ಎರಡನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಬಂದಿದೆ. ಅದರ pH ಏನು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಕೇಳ್ತಿದ್ದಾರೆ. ನೀನು ಈ ತರಹ ಕ್ವೆಶ್ಚನ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾಗ ಅದೇನಾದರೂ ಬಫರ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತಾ ಅನ್ನೋ ಯೋಚನೆಯನ್ನ ಮಾಡಬೇಕಾಗತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ, ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ವೀಕ್ ಆ್ಯಸಿಡ್, ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಬಂದ್ಬಿಟ್ಟು ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್, ಮತ್ತು ವೀಕ್ ಆ್ಯಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ನಲ್ಲಿ ವೀಕ್ ಆ್ಯಸಿಡ್ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅನ್ಕೋ ಅಥವಾ ಈಕ್ವಲ್ ಇದೆ ಅನ್ಕೋ, ಆಬ್ವಿಯಸ್ಲಿ ಏನಾಗುತ್ತೆ, ದೇರ್ ವಿಲ್ ಬಿ ಡೆಫಿನೆಟ್ಲಿ ನ್ಯೂಟ್ರಲೈಸೇಷನ್. ಇದನ್ನು ನೋಡಿದರೆ ನಮಗೆ 2.84 ಬರುತ್ತೆ. ಇದು ಎಕ್ಸಾಕ್ಟ್ಲಿ ವಿ ವಿಲ್ ಗೆಟ್ 2.84. ಇಲ್ಲೇನು ಬರ್ತಾ ಇದೆ, ಇಲ್ಲಿ ಕೂಡ 14.2 ಇಂಟು 0.1 ಅಂದರೆ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ, 0.142 ಬರ್ತಾ ಇದೆ. ಸೊ ಇಫ್ ಐ ಮಲ್ಟಿಪ್ಲೈ ದೀಸ್ ಟು, A1 M1 V1 equals 20 into 0.142 which is 2.84 molar. ಆ ಕಡೆ ನಾನು A2 M2 V2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ 14.2 ಇಂಟು 0.1 ಅಂದರೆ 0.142 ಮೋಲಾರ್ ಬರ್ತಾ ಇದೆ. ಅಂದರೆ ಸ್ಪಷ್ಟವಾಗಿ ಆ್ಯಸಿಡ್ ಜಾಸ್ತಿ ಇದೆ, ವೀಕ್ ಆ್ಯಸಿಡ್, ಆ್ಯಂಡ್ ಬೇಸ್ ಕಮ್ಮಿ ಇದೆ. ಅಂದರೆ ಡಸಂಟ್ ಇಟ್ ಲೀಡ್ ಟು ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಅ ಬಫರ್. ದೇರ್ಫೋರ್ ನಾವು pH ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಬಫರಿನ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ pH ಈಕ್ವಲ್ಸ್ pKa ಪ್ಲಸ್ ಲಾಗ್ ಆಫ್ salt concentration divided by acid concentration ಅನ್ನುವ ಫಾರ್ಮುಲಾನ ತಗೋಬೇಕಾಗತ್ತೆ. ಇದಕ್ಕೆ ಅವರು ಆಲ್ರೆಡಿ pKa ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. pKa ಆಫ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ ಇಸ್ 4.75. 4.75 is the pKa of the acid. Therefore ನಾನು pH ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ pH equals pKa is 4.75 plus log of ಸಾಲ್ಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಾಗತ್ತೆ ಅಂತ ನೀನು ವಿಚಾರ ಮಾಡಿದೆ ಅನ್ಕೋ. ಇದು 2.84 ಐತಿ, ಅದು 0.142 ಐತಿ, ಅಂದರೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇದರಲ್ಲಿ ಅದು ಹಾಫ್ ಇದೆ. ಅಂದರೆ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಮತ್ತು ಇದು ಸೇರಿ ಎರಡೂ ಕೂಡ ಇದು ಹಾಫ್, ಇದರಲ್ಲಿ ಹಾಫ್ ಅದಿದೆ. ಅಂದರೆ ಇದರಲ್ಲಿ 0.142 ಮೋಲಾರನ್ನು ಅದು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಿಬಿಡುತ್ತೆ. ಇನ್ನೆಷ್ಟು ಆ್ಯಸಿಡ್ ಉಳಿದಿರುತ್ತೆ, ಇನ್ನೂ 0.142 ಅಷ್ಟು ಆ್ಯಸಿಡ್ ಉಳಿದಿರುತ್ತೆ. 2.84ನಲ್ಲಿ 0.142 ಅನ್ನೋದು ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಇದೆ ಅಲ್ವಾ, ಅದು ಎಷ್ಟಿದೆಯೋ ಅಷ್ಟು ಆ್ಯಸಿಡನ್ನು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡುತ್ತೆ. ಅಂದರೆ 0.142 ಇದರಲ್ಲಿ ಕೂಡ 0.142 ಅನ್ನು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡ್ತಾ ಇದೆ. ಅದೆಲ್ಲ ಸಾಲ್ಟ್ ಆಗಿ ಬರುತ್ತೆ. ಅಂದರೆ 0.142 ಅಷ್ಟು ಆ್ಯಸಿಡ್ 0.142 ಅಷ್ಟು ಬೇಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಾಗ 0.142 ಮೋಲಾರ್ ಅಷ್ಟು ಸಾಲ್ಟ್ ಬರುತ್ತೆ. ಸೊ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸಾಲ್ಟ್ ಈಸ್ 0.142. ಈಗ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹಾಕಬೇಕು. ಇದರಲ್ಲಿ ಹಾಫ್ ರಿಯಾಕ್ಟ್ ಆಗಿ ಹೋಯಿತು ಅಂದರೆ ನಮಗೆ ಇನ್ನೂ ಉಳಿದಿದ್ದೆಷ್ಟು ಇದು ಆ್ಯಕ್ಚುಲಿ 1.42 ಬರುತ್ತೆ, ನಾಟ್ 0.2. ಸೊ ನಾನು ಇಲ್ಲಿ ಕೂಡ 1.42 ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಈ 1.42 ಏನಿದೆ, ಆ 1.42 ಇದರಲ್ಲಿರುವ 1.42 ಅನ್ನು ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡಿ 1.42 ಮೋಲಾರ್ ಅಷ್ಟು ಸಾಲ್ಟ್ ಫಾರ್ಮ್ ಮಾಡಿದೆ. ಇನ್ನು ಉಳಿದಿದ್ದ ಪಾರ್ಟ್ ಏನಿಲ್ಲಿ 1.42 ರಿಯಾಕ್ಟ್ ಆಗಿ ಹೋಗಿದೆ, ಇನ್ನೂ 1.42 ಉಳಿದಿದೆ. ಹಾಗಾಗಿ ಆ ಉಳಿದಿದ್ದೆಲ್ಲ ಕೂಡ ಆಸಿಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹಾಕಬೇಕಾಗತ್ತೆ. ಅದು ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಅಂದರೆ pH ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ವಿಲ್ ಬಿ, pH ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ವಿಲ್ ಬಿ 4.75 ಅಂತ ನಾವು ತಗೋಬೇಕಾಗತ್ತೆ. ನಾನು ಇನ್ನೊಂದು ಸಲ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ರಿ, ಅರ್ಥ ಮಾಡಿಕೊಳ್ಳಿ ಕ್ವೆಶ್ಚನನ್ನು. 20 ml acetic acid required 28.4 milliliter of 0.1 molar sodium hydroxide ಅಂದರು. ಇದರ ಅರ್ಥ ಏನಂತಂದರೆ ನಾವು ಎರಡರಲ್ಲಿ ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಾಗ ಇದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಇದು ಆ್ಯಸಿಡ್ ಅದು ಬೇಸ್ ಎರಡು ರಿಯಾಕ್ಟ್ ಆಗ್ತಿದ್ದಾವೆ, ಅದಕ್ಕೆ A1M1V1 ಈಕ್ವಲ್ಸ್ A2 M2V2 ಫಾರ್ಮುಲಾ ಹಾಕಿ ಎಷ್ಟು ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆ ಅನ್ನೋದನ್ನು ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀನಿ. ಆನಂತರ ಏನು ಹೇಳ್ತಿದ್ದಾರೆ, 20 ml ಈ ಆ್ಯಸಿಡನ್ನು 14.2 ml 0.1 molar ಬೇಸಿಗೆ ಸೇರಿಸಿದ್ದಾರೆ. ಅಂದರೆ ಆವಾಗ pH ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ಏನು ಬರುತ್ತೆ ಅಂತಿದ್ದಾರೆ. ಅದು ಆ್ಯಸಿಡ್ ಆಗ್ಬೋದು, ಬೇಸ್ ಆಗ್ಬೋದು, ಏನಾದರೂ ಆಗ್ಬೋದು. ಅದರಗೋಸ್ಕರ ನಾನು ಏನು ಮಾಡಿದ್ದೀನಿ, ಇದು ವೀಕ್ ಆ್ಯಸಿಡ್ ಅದು ಬೇಸ್ ಅಲ್ವಾ, 99% ಕೇಸಸ್ನಲ್ಲಿ ಇದು ಬಫರೇ ಆಗುತ್ತೆ. ಅದು ಬಫರ್ ಆಗುತ್ತಾ ಇಲ್ಲ ತಿಳ್ಕೊಳ್ಳೋಕ್ಕೆ ನಾನು ಈ ಎರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ನೋಡಿದ್ದೀನಿ, ಅದು 2.84 ಬಂತು. ಇದು ಕೂಡ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ನೋಡಿದ್ದೀನಿ, ಅದು 1.42 ಬಂತು. ಈ ಕಾರಣಗಳಿಂದ ನಾನು ಇದು ಜಾಸ್ತಿ ಇದೆ ಅಲ್ವಾ, ಇದು ಜಾಸ್ತಿ ಇದೆ ಅಂತಂದರೆ ಖಂಡಿತ ಆ್ಯಸಿಡ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಜಾಸ್ತಿ ಇದ್ದರೆ ಅದು ಎಸಿಡಿಕ್ ಬಫರ್ ಆಗುತ್ತೆ ಅಂತ ನಾನು ಕನ್ಕ್ಲೂಷನ್ಗೆ ಬಂದು ಆ ಫಾರ್ಮುಲಾನ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಈಗ ಇನ್ನೊಂದು ವಿಷಯ ಏನಿದರಲ್ಲಿ ಅಂತ ಅಂದರೆ ಈ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಏನಿದೆ, ಈ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ 1.42 ಇದೆ, ಇದು 2.84 ಇದೆ. ಅಂದರೆ ಅದರಲ್ಲಿ ಹಾಫ್ ಇದರಲ್ಲಿ ಹಾಫ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಇದು ಅದು ಹಾಫ್ ರಿಯಾಕ್ಟ್ ಆಗಿ ಇನ್ನು ಹಾಫ್ ಉಳಿತದೆ. ಅಂದರೆ ಸಾಲ್ಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ 1.42, ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ 1.42. ಸಾಲ್ಟ್ ಮತ್ತು ಆ್ಯಸಿಡ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಈಕ್ವಲ್ ಆದರೆ pH ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು pKa. ದೇರ್ಫೋರ್ ಇದು ಸೊಲ್ಯೂಷನ್ ಫಾರ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್. ಈಗ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ಸಾಲ್ಟ್ಸ್ ಬಗ್ಗೆ, ಸಾಲ್ಟ್ ಹೈಡ್ರೋಲೈಸಿಸ್ ಬಗ್ಗೆ. ಸಾಲ್ಟ್ ಹೈಡ್ರೋಲೈಸಿಸ್ ಅನ್ನು ಒಂದ್ಸಲ ನೋಡಿಬಿಟ್ಟು ಸಾಲಿಬಿಲಿಟಿ ಆ್ಯಂಡ್ ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಪ್ರಾಬ್ಲಮ್ಸ್ಗೆ ಹೋಗ್ಬಿಡೋಣ. ಸೊ ಕಮಿಂಗ್ ಟು ದ ಪಾಯಿಂಟ್ ಹಿಯರ್, ಸಾಲ್ಟ್ಸ್ನಲ್ಲಿ ನಾನು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ಏನಂತಂದರೆ ನಮಗೆ 4 ಟೈಪ್ಸ್ ಆಫ್ ಸಾಲ್ಟ್ಸ್ ಇರ್ತವೆ. ಫಸ್ಟ್ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟನ್ನು ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಎರಡನೇ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ ಏನಂತಂದರೆ ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ವೀಕ್ ಬೇಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಮೂರನೇ ಸಾಲ್ಟ್ ಏನಂತಂದರೆ ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ನಾಲ್ಕನೇ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ ಏನಂತಂದರೆ ಸಾಲ್ಟ್ ಆಫ್ ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ವೀಕ್ ಬೇಸ್. ಇವು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ಸ್. ಈ 4 ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ಸ್ನಲ್ಲಿ ಆ ಸೊಲ್ಯೂಷನ್ ವಾಟರ್ನಲ್ಲಿ ತಯಾರಿ ಮಾಡಿದಾಗ ಇದು ಯಾವ ತರಹದ ಸೊಲ್ಯೂಷನ್ ಆಗಿರುತ್ತೆ ಅಂದರೆ ಎಲ್ಲ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ಸ್ ನ್ಯೂಟ್ರಲ್ ಆಗಲ್ಲ. ದೇರ್ಫೋರ್ ಇದು ವೀಕ್ ಆ್ಯಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ನಿನಗೆ ವೀಕ್ ಆ್ಯಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಅನ್ನೋ ಪೇರೆಂಟ್ಸ್ ಅನ್ಕೋ, ಬರುವ ಸಾಲ್ಟ್ ಡಾಟರ್ ಅನ್ಕೋ. ಆ ಡಾಟರ್ ಕಂಪೌಂಡ್ನಲ್ಲಿ ಯಾರು ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂತಂದರೆ ಯಾರಿದು ಡಾಮಿನೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅದಾವೋ ಅವರು ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಬೇಸಿಂದು ಡಾಮಿನೆನ್ಸ್ ಐತಿ ಅಂದರೆ ಫೈನಲ್ ಸೊಲ್ಯೂಷನ್ಗೆ ಬೇಸಿಕ್ ನೇಚರ್ ಬರುತ್ತೆ. ಅಂದರೆ pH ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 7. ಈ ಥರ ನೆನಪಿಟ್ಕೋಬೇಕು. ಇದು ಶಾರ್ಟ್ ಕಟ್ ಟು ರಿಮೆಂಬರ್ ದ್ಯಾಟ್. ಇನ್ನೊಂದು ವಿಷಯ ಏನಂದರೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ಕೋ, ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಒಂದು ತಗೋ, ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್. ವೀಕ್ ಬೇಸ್ ಒಂದು ತಗೋ, ವೀಕ್ ಆ್ಯಸಿಡನ್ನು ತಗೋ. ವೀಕ್ ಆ್ಯಸಿಡ್ ಅಂದರೆ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್, ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಅಂದರೆ ಒಂದು ತಗೋ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್. ಎರಡಿನ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ತಗೊಂಡ್ರೆ ಸೋಡಿಯಂ ಆಸಿಟೇಟ್. ಈ ತರಹ ಒಂದು ಸಾಲ್ಟ್ ಕೊಟ್ಟು ಇದರ ಸೊಲ್ಯೂಷನ್ಗೆ ಯಾವ ನೇಚರ್ ಇರುತ್ತೆ ಅಂತ ಕೇಳಾರಂತ ಅನ್ಕೋ. ನೀನು ಇದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡು. ಫಸ್ಟು ಎಸಿಟೇಟ್ ಅಯಾನ್ ಇದೆ ಅಲ್ವಾ, ಎಸಿಟೇಟ್ ಅಯಾನ್ ಎಸಿಟಿಕ್ ಆ್ಯಸಿಡ್ರಿಂದ ಬಂದಿದೆ ಅಂದರೆ ವೀಕ್ ಆ್ಯಸಿಡ್ರಿಂದ ಬಂದಿದೆ. ಸೋಡಿಯಂ ಅನ್ನೋದು ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅಂದರೆ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ದಿಂದ ಬಂದಿದೆ. ಇದರಲ್ಲಿ ಬೇಸ್ ಸ್ಟ್ರಾಂಗ್ ಇದೆ. ಸೊ ಸಾಲ್ಟಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಿದೆ ಅದು ಬೇಸಿಗೆ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಸೊಲ್ಯೂಷನ್ಗೆ ಬೇಸಿಕ್ ನೇಚರ್ ಬಂದಿರುತ್ತೆ. ಸೊ pH ಅನ್ನೋದು ಗ್ರೇಟರ್ ದ್ಯಾನ್ 7 ಇರುತ್ತೆ ಅಂತ ಕನ್ಕ್ಲೂಷನ್ ಮಾಡ್ಕೋಬೇಕು. ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಮತ್ತು ವೀಕ್ ಬೇಸ್ ಇದೆ ಅಂತ ಅನ್ಕೋ. ಇದರಲ್ಲಿ ಯಾವುದು ಸ್ಟ್ರಾಂಗ್ ಇದೆ? ಆ್ಯಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಇದೆ, ಡಾಮಿನೆಂಟ್ ಆ್ಯಸಿಡ್ ಇದೆ. ಸೊ ಫೈನಲಿ ನಮಗೆ ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಬರುತ್ತೆ. ಆ್ಯಸಿಡಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಮಗೆ ಫೈನಲಿ ಬರುತ್ತೆ ಸೊಲ್ಯೂಷನ್ಗೆ. ಸೊ ದ pH ಆಫ್ ದ್ಯಾಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೊಲ್ಯೂಷನ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಲೆಸ್ ದ್ಯಾನ್ 7. ಆ್ಯಂಡ್ ದೆನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದ್ಯಾಟ್ ತಗೋಬೇಕಂದ್ರೆ ನಾನು ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ಗೆ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ತೊಗೊಳ್ತೀನಿ, ವೀಕ್ ಬೇಸ್ಗೆ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ತೊಗೊಳ್ತೀನಿ. ಸೊ ಎರಡು ಸೇರಿ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್, ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಈ ತರಹದ ಸಾಲ್ಟ್ಸ್ ಎಲ್ಲ ಕೂಡ ನಮಗೆ ಈ ನೇಚರ್ಗೆ ಬಂದಿರ್ತವೆ. ಅಮೋನಿಯಂ ಅಯಾನ್ ಅನ್ನೋದು ವೀಕ್ ಬೇಸ್ರಿಂದ ಬಂದಿದೆ, ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಅನ್ನೋದು ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ರಿಂದ ಬಂದಿದೆ. ಆ ಎರಡಿನ ಕಾಂಬಿನೇಷನ್ ನನಗೆ ಆಬ್ವಿಯಸ್ಲಿ ಈ ಥರ ಬರುತ್ತೆ. ಈಗ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ನೋಡಿ, ಕಾಪರ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಇಸ್ ಅ ವೀಕ್ ಬೇಸ್ ಆ್ಯಂಡ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್. ಸೊ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಂಬಿನೇಷನ್ ಸಾಲ್ಟ್ ಆ್ಯಸಿಡಿಕ್ ಆಗುತ್ತೆ. ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸಿನ ಕಾಂಬಿನೇಷನ್ ನೋಡೋಣ. ಸ್ಟ್ರಾಂಗ್ ಆ್ಯಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸಿನ ಕಾಂಬಿನೇಷನ್ ತೊಗೊಂಡಿದ್ದಾಗ ಇದು ಯಾವಾಗಲೂ ಕೂಡ ನ್ಯೂಟ್ರಲೇ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ಅದು ಯಾವಾಗಲೂ pH ಅನ್ನೋದು 7 ಇರುತ್ತೆ. ಇಷ್ಟು ವಿಷಯ ನೀವು ತಿಳ್ಕೋಬೇಕು. ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ವೀಕ್ ಬೇಸಿನ ಕಾಂಬಿನೇಷನ್ ನೋಡೋಣ. ವೀಕ್ ಆ್ಯಸಿಡ್ ಆ್ಯಂಡ್ ವೀಕ್ ಬೇಸಿನ ಕಾಂಬಿನೇಷನ್ನಲ್ಲಿ ಎರಡೂ ವೀಕ್ ಅದಾವೆ, ಆದರೆ ಆ ಎರಡರಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಸ್ಟ್ರಾಂಗ್ ಇರ್ಬೋದು, ಒಂದು ವೀಕ್ ಇರ್ಬೋದು, ಬಟ್ ಎರಡೂ ಈಕ್ವಲ್ಲಿ ವೀಕ್ ಇರ್ಬೋದು. ಅದಕ್ಕೆ ಈ ನೇಚರ್ ಅನ್ನೋದು ಸ್ಪಷ್ಟವಾಗಿ ಇಷ್ಟೇ ಬರುತ್ತೆ ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಬರಲ್ಲ. ಅದಕ್ಕೆ ಒಂದು ವೇಳೆ ಸ್ವಲ್ಪ ಆ್ಯಸಿಡ್ ಅನ್ನೋದು ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಅಂತ ಅನ್ಕೋ, ವೀಕ್ಲಿ ಎಸಿಡಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಅಥವಾ ಒಂದು ವೇಳೆ ಸ್ವಲ್ಪ ಬೇಸ್ ಅನ್ನೋದು ಆ್ಯಸಿಡ್ಗಿಂತ ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಅಂತ ಅನ್ಕೋ, ಆವಾಗ ಅದು ವೀಕ್ಲಿ ಬೇಸಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಅಥವಾ ಎರಡು ಈಕ್ವಲ್ಲಿ ವೀಕ್ ಅದಾವಂತ ಅನ್ಕೋ, ಆವಾಗ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೊಲ್ಯೂಷನ್ ನ್ಯೂಟ್ರಲ್ ಆಗತ್ತೆ ಅನ್ನುವ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ವೀಕ್ಲಿ ಅಸಿಡಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆದರೆ ಏನಾಗುತ್ತೆ, ವೀಕ್ಲಿ ಅಸಿಡಿಕ್ ಇರಲಿ, ವೀಕ್ಲಿ ಬೇಸಿಕ್ ಇರಲಿ ಆ್ಯಂಡ್ ನ್ಯೂಟ್ರಲ್ ಅಂದರೆ pH 7 ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ pH is going to be 7. ವೀಕ್ಲಿ ಅಸಿಡಿಕ್ ಅಂದರೆ pH is going to be slightly less than 7. ವೀಕ್ಲಿ ಬೇಸಿಕ್ ಅಂದರೆ pH is going to be slightly above 7, 7.1, 7.2 ಆ ರೇಂಜ್ನಲ್ಲಿ ಬರ್ತಾ ಇರುತ್ತೆ. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಾಲ್ಟ್ಗೆ ನಮಗೆ pH ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದ್ದಾರೆ. pH ಈಕ್ವಲ್ 7 + ½ ಇಂಟು pKa ಮೈನಸ್ pKb ಅನ್ನುವ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಿ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಾಲ್ಟ್ಗೆ ನಾವು ಈ pH ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ ವಿ ಹ್ಯಾವ್ 4 ಟೈಪ್ಸ್ ಆಫ್ ಸಾಲ್ಟ್ಸ್: salt of weak acid and strong base, salt of strong acid and weak base, salt of strong acid and strong base, salt of weak acid and weak base. ಫಸ್ಟ್ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ನಲ್ಲಿ ಬೇಸಿಕ್ ನೇಚರ್ ಬರುತ್ತೆ, pH ಗ್ರೇಟರ್ ದ್ಯಾನ್ 7 ಇರುತ್ತೆ. ಸೆಕೆಂಡ್ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ನಲ್ಲಿ ಅಸಿಡಿಕ್ ಬರುತ್ತೆ, pH ಲೆಸ್ ದ್ಯಾನ್ 7 ಬರುತ್ತೆ. ಥರ್ಡ್ ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ನಲ್ಲಿ ಅಸಿಡಿಕ್ ಆ್ಯಂಡ್ ಬೇಸಿಕ್ ಎರಡೂ ಕೂಡ ಸ್ಟ್ರಾಂಗ್ ಕಂಡೀಷನ್ಸ್ ಇರೋದ್ರಿಂದ pH ಅನ್ನೋದು 7 ಬರ್ತಾ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಕಂಡೀಷನ್ಗೆ ವೀಕ್ ಆ್ಯಸಿಡ್ ವೀಕ್ ಬೇಸನ್ನು ತೊಗೊಂಡಿದ್ದಾಗ ಅದರಲ್ಲಿ ಸ್ಲೈಟ್ಲಿ ಬೇಸ್ ಸ್ಟ್ರಾಂಗ್ ಇದ್ದರೆ ಆವಾಗ ಸೊಲ್ಯೂಷನ್ ಸ್ಲೈಟ್ಲಿ ಬೇಸಿಕ್ ಆಗುತ್ತೆ. ಅಥವಾ ಆ್ಯಸಿಡ್ ಅನ್ನೋದು ಸ್ವಲ್ಪ ಸ್ಟ್ರಾಂಗ್ ಇದ್ದರೆ ಅದರಲ್ಲಿ ವೀಕ್ಲಿ ಎಸಿಡಿಕ್ ಆಗಿ ಬರುತ್ತೆ. ಒಂದು ವೇಳೆ ಎರಡೂ ಈಕ್ವಲ್ಲಿ ವೀಕ್ ಇದ್ದರೆ ನ್ಯೂಟ್ರಲ್ ಬರುತ್ತೆ. ಒಂದು ವೇಳೆ ಇಂಥ ಸಾಲ್ಟ್ಗೆ pH ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಇದು ನಮಗೆ ಸಿಲೆಬಸ್ನಲ್ಲಿದೆ. ಸೊ 7 + ½ ಇಂಟು pKa ಮೈನಸ್ pKb ಅನ್ನುವ ಫಾರ್ಮುಲಾನ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗತ್ತೆ. So let's proceed to the next important point that we need to know here. After this, I'm going to talk about the next important concept called solubility and solubility product constant. These are the things that we are going to talk about here. Solubility and solubility product constants are applicable for sparingly soluble salts. So I'm here considering relations for solubility and KSP for various types of salts. For example, salt ಅನ್ನೋದು AB ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ ಇದೆ ಅಂತ ಅನ್ಕೋ. ಈ AB ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ ಇದ್ದಾಗ ನಮಗೆ KSP ಈಕ್ವಲ್ಸ್ S² ಆಗುತ್ತೆ, ಅಥವಾ S is equal to √KSP ಆಗಿರುತ್ತೆ. ಈ ರಿಲೇಷನನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗತ್ತೆ. ಇದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಏನೇನು ಬರ್ತವೆ AB ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್ಗೆ? ಬೇರಿಯಂ ಸಲ್ಫೈಡ್, ಬೇರಿಯಂ ಸಲ್ಫೇಟ್, ಆಮೇಲೆ ಕಾಪರ್ ಸಲ್ಫೈಡ್, ನಿಕೆಲ್ ಸಲ್ಫೈಡ್, and other than that we have silver chloride, silver bromide. Most of the sparingly soluble salts ಈ ಕ್ಯಾಟಗರಿದಲ್ಲೇ ಸೇರ್ತವೆ. ಎರಡನೇದು A to B ಟೈಪ್. A to B ಟೈಪ್ ಇರಲಿ, AB2 ಟೈಪ್ ಇರಲಿ, ಎರಡಕ್ಕೂ ಕೂಡ KSP ಈಕ್ವಲ್ಸ್ 4s³ ಅನ್ನುವ ರಿಲೇಷನ್ ಅಪ್ಲಿಕಬಲ್ ಆಗುತ್ತೆ. ಅಂದರೆ S is equal to √= KSP/4 ಅನ್ನು ತಗೋಬೇಕಾಗತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಬಂದುಬಿಟ್ಟು ನಮಗೆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಅದಾವೆ. ಅದರಲ್ಲಿ A2B3 ಆರ್ A3B2 ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟನ್ನು ತೊಗೊಂಡಿದ್ದೀವಿ ಅಂತ ಅನ್ಕೋ, ಆವಾಗ KSP ಈಕ್ವಲ್ಸ್ 108 S ಪವರ್ 5 ಬರುತ್ತೆ. ಈ ಫಾರ್ಮುಲಾನ ನಾನು ಅಪ್ಲೈ ಮಾಡಿದರೆ ಸಾಲಿಬಿಲಿಟಿ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ 5th ರೂಟ್ ಆಫ್ KSP ಡಿವೈಡೆಡ್ ಬೈ 108 ಅನ್ನು ಇದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗತ್ತೆ. ಇದರಲ್ಲಿ ನಾವು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾದ ವಿಷಯ ಏನು ಅಂತಂದರೆ, ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ದಿಸ್, ಇದರಲ್ಲಿ ಅಯಾನಿಕ್ ಪ್ರಾಡಕ್ಟ್ ಮತ್ತು ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ಸ್ ಮಧ್ಯದಲ್ಲಿ ರಿಲೇಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಆ ರಿಲೇಷನ್ ತಗೊಂಡು ಯಾವ ತರಹ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗತ್ತೆ, ಯಾವ ಕಂಡೀಷನಲ್ಲಿ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗತ್ತೆ, ಯಾವ ಕಂಡೀಷನಲ್ಲಿ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗಲ್ಲ ಅನ್ನೋದನ್ನು ನಾವು ನೋಡಬೇಕಾಗತ್ತೆ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಅಯಾನಿಕ್ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನೋದು ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಆಗಿದೆ ಅಂತ ಅನ್ಕೋ, ಆವಾಗ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆ ಸೊಲ್ಯೂಷನನ್ನು ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ದೆನ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅಕರ್ಸ್. ಆ ಕಂಡೀಷನಲ್ಲಿ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಖಂಡಿತ ಆಗತ್ತೆ. ಒಂದು ವೇಳೆ ಅಯಾನಿಕ್ ಪ್ರಾಡಕ್ಟ್ ಆ್ಯಂಡ್ ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನೋದು ಈಕ್ವಲ್ ಆದರೆ ಆ ಕಂಡೀಷನ್ನಲ್ಲಿ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗಲ್ಲ. ದೇರ್ಫೋರ್ ಅಂತಹ ಒಂದು ಸೊಲ್ಯೂಷನ್ನ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನಬೇಕು. ಬಟ್ ದೇರ್ ವೋಂಟ್ ಬಿ ಎನಿ ಕೈಂಡ್ ಆಫ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅಕರ್ಡ್. ದೆನ್ ಎನದರ್ ಥಿಂಗ್, KIP ಅನ್ನೋದು ಲೆಸ್ ದ್ಯಾನ್ KSP ಇದ್ದರೆ ಅಯಾನಿಕ್ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನೋದು, ದೆನ್ ವಿ ನೀಡ್ ಟು ಸೇ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಎನ್ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್. ಈ ಕಂಡೀಷನನ್ನು ನಾವು ಹೇಳಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ಕೂಡ ಪ್ರೆಸಿಪಿಟೇಟ್ ಅನ್ನೋದು ಆಗಲ್ಲ. ಅಂದರೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗಬೇಕಂದ್ರೆ ಖಂಡಿತ ಅಯಾನಿಕ್ ಪ್ರಾಡಕ್ಟ್ ಶುಡ್ ಕ್ರಾಸ್ ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನೋದನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇದರಲ್ಲಿ ನಮಗಿನ್ನೂ AXBY ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟನ್ನು ಕೂಡ ಕೊಡ್ತಿರ್ತಾರೆ. AXBY ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟನ್ನು ಕೊಟ್ಟಿದ್ದಾಗ ನಾವೇನು ತಗೋಬೇಕು? ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ AXBY ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್, ಇಟ್ ವಿಲ್ ಬಿ X ಪವರ್ X ಆ್ಯಂಡ್ ದೆನ್ Y ಪವರ್ Y ಆ್ಯಂಡ್ ದೆನ್ S ಇಂಟು X ಪ್ಲಸ್ Y ಆಗುತ್ತೆ. ಅಂದರೆ ಫಾರ್ AXBY ಟೈಪ್ ಆಫ್ ಸಾಲ್ಟ್, KSP ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ X ಪವರ್ X ಆ್ಯಂಡ್ ದೆನ್ Y ಪವರ್ Y ಇಂಟು S ಪವರ್ X ಪ್ಲಸ್ Y. ಇದನ್ನೇ ನಾನು KSPಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕಂದ್ರೆ, ಅಂದರೆ S ಬರಬೇಕಂದ್ರೆ ನಾನು ಏನು ಮಾಡಬೇಕು? KSP ಡಿವೈಡೆಡ್ ಬೈ X ಪವರ್ X, Y ಪವರ್ Y ಆ್ಯಂಡ್ X ಪ್ಲಸ್ Yth ರೂಟ್ ಆಫ್ KSP ಡಿವೈಡೆಡ್ ಬೈ X ಪವರ್ X ಆ್ಯಂಡ್ Y ಪವರ್ Y ಬರುತ್ತೆ. ಇದರಲ್ಲೇ ಜಿರ್ಕೋನಿಯಂ ಫಾಸ್ಫೇಟ್ ಕೂಡ ಕೇಳ್ತಿರ್ತಾರೆ ಒಂದೊಂದು ಸಲ, ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ KSP ಆ್ಯಂಡ್ S. ಅದು ಯಾವ ಥರ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅಂದರೆ, ಫೈಂಡ್ ಔಟ್ ಮಾಡುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಈಸಿ ಆಗುತ್ತೆ, ಬೇಗ ಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಸೊ ಜಿರ್ಕೋನಿಯಂ ಫಾಸ್ಫೇಟ್ ಬಂದುಬಿಟ್ಟು ಇಟ್ ಈಸ್ Zr3PO4 ಆಗುತ್ತೆ. ಇದರಲ್ಲಿ ನಮಗೆ ರಿಲೇಷನ್ ಬಂದುಬಿಟ್ಟು KSP ಈಕ್ವಲ್ಸ್ 6912 S to the power 7 ಬರುತ್ತೆ. ಈ ತರಹ ಬಂದಾಗ ನಾನು 7th ರೂಟ್ ಆಫ್ KSP ಡಿವೈಡೆಡ್ ಬೈ 6912 ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗತ್ತೆ ಇದಕ್ಕೆ. ಇದರ ಮೇಲೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಸಾಲ್ವ್ ಮಾಡೋಣ. ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ KSP ಆ್ಯಂಡ್ KIP ಮೇಲೆ ಯಾವ ತರಹ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಬರುತ್ತೆ ಅನ್ನೋ ಕ್ವೆಶ್ಚನ್ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಅದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಕ್ವೆಶ್ಚನ್ ಕೇಳಿದರೆ ಅದರ ಮೇಲೆ ಕೇಳ್ಬೋದು. ಸೊ ಕ್ವೆಶ್ಚನ್ ಈ ಥರ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಫ್ ಈಕ್ವಲ್ ವಾಲ್ಯೂಮ್ಸ್ ಆಫ್ ABT, AB2 ಆ್ಯಂಡ್ XY ಆರ್ ಟೇಕನ್. AB2 ಅನ್ನುವ ಸಾಲ್ಟನ್ನು ತಗೊಂಡಿದ್ದಾರೆ, XY ಅನ್ನುವ ಸಾಲ್ಟನ್ನು ತಗೊಂಡಿದ್ದಾರೆ. ಈ ಸಾಲ್ಟ್ಸ್ ತಗೊಂಡು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದಾರೆ, ಎರಡು ಸೊಲ್ಯೂಷನ್ಸನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದಾರೆ. ಎರಡು ಸೊಲ್ಯೂಷನ್ಸನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಅವರಿಗೆ AY2 ಅನ್ನುವ ಸಾಲ್ಟ್ ಬಂದಿದೆ. ಇಲ್ಲಿ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ, ನಾನು ಹೇಳ್ತಿರೋದು ಯಾವ ಸಾಲ್ಟ್ ಬಂದಿದೆ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್. ಉಳಿದಿದ್ದು BX ಆಗತ್ತೆ, ಅದು ಆಬ್ವಿಯಸ್ಲಿ. ಸೊ AY2 ಅನ್ನುವ ಸಾಲ್ಟ್ ಬಂದಿದೆ. ಈ AY2 ಅನ್ನುವ ಸಾಲ್ಟನ್ನು ಇದು ಎಷ್ಟು ಅದು ಎಷ್ಟು ತಗೊಂಡ್ರೆ AY2 ಸಾಲ್ಟ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಅದರ ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಕೂಡ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಾಲಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ AY2 ಈಕ್ವಲ್ಸ್ 5.2 ಇಂಟು 10 to the power -7 ಅನ್ನೋದು ಇದು ವ್ಯಾಲ್ಯೂ ಆಗಿರುತ್ತೆ. ಈಗ ನಾನು AB2 ಮತ್ತು XY ಸಾಲ್ಟ್ಸನ್ನು ಎಷ್ಟೆಷ್ಟು ತಗೊಂಡ್ರೆ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗತ್ತೆ ಅನ್ನೋದನ್ನು ನೋಡಬೇಕು. ಫಸ್ಟ್ ಆಪ್ಷನ್ ಬಂದುಬಿಟ್ಟು 2 ಇಂಟು 10 to the power -4 ಮೋಲಾರ್ ಆಫ್ AB2 ಪ್ಲಸ್ 0.8 ಇಂಟು 10 to the power -3 ಅಂದರೆ 8 ಇಂಟು 10 to the power -4 ಅನ್ಕೋಬೋದು. ಅದರ XY ಅನ್ನು ತಗೊಂಡಿದ್ದಾರೆ. ಈ ಎರಡಿನ ಕಾಂಬಿನೇಷನ್ ತಗೊಂಡ್ರೆ ನಮಗೆ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗತ್ತಾ ಆಗಲ್ವಾ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಫಸ್ಟ್ ಆಪ್ಷನ್ ಚೆಕ್ ಮಾಡಿ, ಅದು ಆಗಿಲ್ಲ ಅಂದರೆ ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ಗೆ ಹೋಗಬೇಕಾಗತ್ತೆ. ಸೊ ಇವಾಗ ಇದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ A/2ಗೆ ರಿಲೇಷನ್ ಏನು? A/2ಗೆ KSP ಈಕ್ವಲ್ಸ್ ಆರ್ KIP ಈಕ್ವಲ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ A+2 ಇಂಟು y minus whole square. ಇಲ್ಲಿ 2 ಇದೆ, that becomes the power A+2 ಇಂಟು y minus 2 whole square. ಅದನ್ನು ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಬೇಕು. KIP ಈಕ್ವಲ್ಸ್ A+2 ಇಂಟು y minus whole square. A+2 ಇದರಲ್ಲಿ ಒಂದೇ ಇದೆ, ಸೊ ಇದೆಷ್ಟು ತಗೊಳ್ತೀವಿ ಅಷ್ಟೇ ಬರುತ್ತೆ A ಕೂಡ. therefore 2 ಇಂಟು 10 to the power minus 4 and then y minus ಇದರಲ್ಲಿ ಒಂದೇ ಇದೆ, therefore 8 ಇಂಟು 10 to the power minus 4 whole square. ಅಪ್ಲೈ ಮಾಡಿದಾಗ 2 ಇಂಟು 10 power minus 4 ಇಂಟು 8 8s are 64 ಇಂಟು 10 to the power minus 8 ಬರುತ್ತೆ. ಅಂದರೆ ದಿಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ 10 to the power minus 12 ಅಂದರೆ 1.28 ಇಂಟು 10 to the power minus 10 ಬರುತ್ತೆ. ಬಟ್ ನಮಗಿಲ್ಲಿರೋದು 10 power minus 7. ಇದು KIP ಅನ್ನೋದು ಇಟ್ ಈಸ್ ಮಚ್ ಲೆಸ್ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ KSP. ಹಾಗಾಗಿ ಇದು ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಆಗುತ್ತೆ, ಹಾಗಾಗಿ ಇದರಲ್ಲಿ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅನ್ನೋದು ಬರೋದಿಲ್ಲ. ಸೊ ಫಸ್ಟ್ ಆಪ್ಷನ್ ವರ್ಕೌಟ್ ಆಗಲ್ಲ. ಸೆಕೆಂಡ್ ಆಪ್ಷನನ್ನು ಚೆಕ್ ಮಾಡೋಣ. ಸೊ ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ನಲ್ಲಿ 2 ಇಂಟು 10 to the power minus 2 ಮೋಲಾರ್ AB2 ಪ್ಲಸ್ 2 ಇಂಟು 10 to the power minus 2 ಮೋಲಾರ್ XY ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಆವಾಗ ನಾನು ಮತ್ತೆ KIP ಈಕ್ವಲ್ಸ್ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. A+2 ಇಂಟು y minus whole square ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ A+2 2 ಇಂಟು 10 to the power minus 2 ಬರುತ್ತೆ, y minus 2 ಇಂಟು 10 to the power minus 2 ಬರುತ್ತೆ. ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ 2 ಇಂಟು 2 4 2 ಇಂಟು 2 ಅಂದರೆ 8 ಬರುತ್ತೆ, ಇಂಟು 10 to the power minus 4 ಬರುತ್ತೆ. ಇದು minus 2 ಇಂಟು ಅದು minus 4, therefore 8 ಇಂಟು 10 to the power minus 6, which is definitely greater than KSP. Therefore when KIP becomes greater than KSP, there would be precipitation occurring. So ಈ ಕಂಡೀಷನ್ನಲ್ಲಿ ನಮಗೆ KIP is greater than KSP ಬಂದಿದೆ. So precipitation definitely occurs in this case. ಇದೇ ಆನ್ಸರ್ ಆಗಿ ತಗೋಬೇಕಾಗತ್ತೆ. ಈ ತರಹ ನಮಗೆ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗತ್ತಾ ಆಗಲ್ವಾ ಅನ್ನುವ ಕ್ವೆಶ್ಚನ್ಸನ್ನು ಕೇಳ್ತಿರ್ತಾರೆ. ವಿ ಶಾಲ್ ಬಿ ಏಬಲ್ ಟು ಆನ್ಸರ್ ದಟ್ ಕ್ವೆಶ್ಚನ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ನೋಡಿ, ಇನ್ನೊಂದು ಕ್ವೆಶ್ಚನ್, ಸಾಲಿಬಿಲಿಟಿ ಎಷ್ಟಿದೆ ಅಂತ ಕೇಳ್ಬೋದು. ಆ ಸಾಲಿಬಿಲಿಟಿ ಬಗ್ಗೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಯಾವುದು? ದ ಸಾಲಿಬಿಲಿಟಿ ಆಫ್ AgCl. The solubility of AgCl is max in. ಎದರಲ್ಲಿ ಜಾಸ್ತಿ ಸಾಲ್ಯುಬಲ್ ಆಗತ್ತೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಇದರಲ್ಲಿ 0.01 ಮೋಲಾರ್ KCl ಕೊಟ್ಟಿದ್ದಾರೆ, 0.01 ಮೋಲಾರ್ HCl ಕೊಟ್ಟಿದ್ದಾರೆ, 0.01 ಮೋಲಾರ್ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಲಾಸ್ಟ್ ಆಪ್ಷನ್ ಡಿಅಯೋನೈಸ್ಡ್ ವಾಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ನಾನು ಇನ್ನೊಂದು ಆಪ್ಷನ್ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಅಮೋನಿಯಾ. ಈ 5ರಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಇದರಲ್ಲಿ ನೋಡಿ ClClAg, AgCl, ClClAg 3ರಲ್ಲಿ ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟ್ ಇದೆ. ಕಾಮನ್ ಅಯಾನ್ ಇಫೆಕ್ಟ್ ಇದ್ದರೆ ಸಾಲ್ಯುಬಿಲಿಟಿ ಕಮ್ಮಿ ಆಗಿಬಿಡುತ್ತೆ. ದೇರ್ಫೋರ್ ಈ 3ರಲ್ಲಿ ಸಾಲ್ಯುಬಿಲಿಟಿ ಅನ್ನೋದು ಕಮ್ಮಿ ಇರುತ್ತೆ. ಈಗ ಸಾಲ್ಯುಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇರೋದು ಡಿಅಯೋನೈಸ್ಡ್ ವಾಟರ್ನಲ್ಲಿ, ಅಮೋನಿಯಾದಲ್ಲಿ. 2ರಲ್ಲಿ ಅದರಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂತಂದರೆ ಅಮೋನಿಯಾದಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಕಾರಣ ಏನಂದರೆ AgCl ಕಂಬೈನ್ಸ್ ವಿತ್ ಅಮೋನಿಯಾ and then forms a soluble complex AgNH3 twice Cl. ಇದು ಕರಗುತ್ತೆ ವಾಟರ್ನಲ್ಲಿ. ಇಟ್ ಈಸ್ ಅ ಸಾಲ್ಯುಬಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಫ್ ಸಿಲ್ವರ್. ಸೊ ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್ ಅಮೋನಿಯಾದಲ್ಲಿ ಡಿಸೋಸಿಯೇಟ್ ಕರಗುತ್ತೆ, ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ನೀವು ಪ್ರಾಕ್ಟಿಕಲ್ ಪಾರ್ಟ್ನಲ್ಲಿ ಕೂಡ ಕಲ್ತಿದ್ದೀರಿ. ಕರ್ಡಿ ವೈಟ್ PPT ಆಫ್ AgCl ಇಸ್ ಸಾಲ್ಯುಬಲ್ ಇನ್ ಅಮೋನಿಯಾ. ಅದೇ ಸೆಕೆಂಡ್ ಕೇಸ್ ತಗೋಬೇಕಂದ್ರೆ ಡಿಅಯೋನೈಸ್ಡ್ ವಾಟರ್ ಬರುತ್ತೆ. ಅಂದರೆ ವಾಟರ್ನಲ್ಲಿ ಎಷ್ಟು ಸಾಲ್ಯುಬಿಲಿಟಿ ಇದೆ ಅಷ್ಟೇ ಇರುತ್ತೆ, ಕಾಮನ್ ಅಯಾನ್ ಎಫೆಕ್ಟ್ ಅನ್ನೋದು ಇಲ್ಲಿ ಬರಲ್ಲ. ಇದು ಇಷ್ಟು ವಿಷಯ ನಾವು ತಿಳ್ಕೋಬೇಕು ಅಬೌಟ್ ಅಯಾನಿಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಈಗ ಪೀರಿಯಾಡಿಕ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ನಲ್ಲಿ ಸಮ್ ಆಫ್ ದಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟ್ರೆಂಡ್ಸನ್ನು ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಎಟಾಮಿಕ್ ರೇಡಿಯಸ್ನಲ್ಲಿ ಯಾವ ಟ್ರೆಂಡ್ಸ್ ಅದಾವೆ? ಎಟಾಮಿಕ್ ರೇಡಿಯಸ್ನಲ್ಲಿ ನಾನು ರೆಗ್ಯುಲರ್ ಇರೋ ಹೇಳ್ತಾ ಇಲ್ಲ, ಯಾವುದು ಚೇಂಜ್ ಬರ್ತಾ ಇದೆ ಅದನ್ನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಇನ್ ಎ ಗ್ರೂಪ್ ಜನರಲಿ ಎಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಏನಾಗುತ್ತೆ, ಇನ್ ಎನಿ ಗ್ರೂಪ್ ಎಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಅನ್ನೋದು ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ಇನ್ಕ್ರೀಸಸ್ ಡೌನ್ ದ ಗ್ರೂಪ್. ಬಟ್ ಎದರಲ್ಲಿ ಡಿವಿಯೇಷನ್ಸ್ ಬಂದಿದ್ದಾವಲ್ವಾ ಅದರ ಬಗ್ಗೆ ನಾನು ಮೇಯ್ನ್ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಅದನ್ನು ಅರ್ಥ ಮಾಡಿಕೊಳ್ಳಿ ಫಸ್ಟ್. ಸೊ ಡಿವಿಯೇಷನ್ಸ್ ಬಂದಿರೋದು ನಮಗೆ ಗ್ರೂಪ್ 13ನಲ್ಲಿ. ಗ್ರೂಪ್ 13ನಲ್ಲಿ ಬೋರಾನ್, ಅಲ್ಯೂಮಿನಿಯಂ, ಗ್ಯಾಲಿಯಂ, ಇಂಡಿಯಂ, ಥ್ಯಾಲಿಯಂಗಳಲ್ಲಿ ಸೈಜ್ ಅನ್ನೋದು ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ಬಟ್ ಬೋರಾನ್ ಟು ಅಲ್ಯೂಮಿನಿಯಂ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಬಟ್ ಮತ್ತೆ ಅಲ್ಯೂಮಿನಿಯಂ ಟು ಗ್ಯಾಲಿಯಂ ಅನ್ನೋದು ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ನಮಗೆ ಬೋರಾನ್, ಗ್ಯಾಲಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ ಆ್ಯಂಡ್ ದೆನ್ ಇಂಡಿಯಂ, ಥ್ಯಾಲಿಯಂ ಅನ್ನೋದು ಸೈಜ್ಗೆ ಆರ್ಡರ್ ಆಗುತ್ತೆ. ಏನಿಲ್ಲ, ಇದಿಲ್ಲಿ ಹಾಕೋಬೇಕಷ್ಟೆ. ಇದು ಗ್ರೂಪ್ 13ನಲ್ಲಿ. ಇನ್ನೊಂದು ಸೈಜ್ ಡಿವಿಯೇಷನ್ ನಮಗೆ ಬರೋದು ಎಲ್ಲಿ ಅಂತಂದರೆ ಇಟ್ ಅಕರ್ಸ್ ಇನ್ ಆ್ಯಕ್ಚುಲಿ ಡಿ ಬ್ಲಾಕ್. ಡಿ ಬ್ಲಾಕ್ನಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿರೋ ವಿಷಯ ಏನು ಅಂತಂದರೆ ದೆರ್ ಈಸ್ ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಟ್ರಾಕ್ಷನ್. ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಇರೋದ್ರಿಂದ 4D ಆ್ಯಂಡ್ 5D ಸೀರೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಮಧ್ಯದಲ್ಲಿರುವ ಸೈಜ್ ಅನ್ನೋದು ಸೇಮ್ ಇರುತ್ತೆ. Therefore zirconium, hafnium, niobium, tantalum, ಈ ತರಹ molybdenum, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, etc. hafnium, tantalum, tungsten, rhenium, osmium, iridium, etc. ಈ ಎರಡಿನ ಸೈಜ್ ಸೇಮ್, ಈ ಎರಡಿನ ಸೈಜ್ ಸೇಮ್, ಈ ಎರಡಿನ ಸೈಜ್ ಸೇಮ್. The sizes remain same for 4D and 5D series ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್, ಎಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಅನಂತರ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ದಿಸ್ ಥಿಂಗ್ ಕಾಲ್ಡ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪೀಸ್ನಲ್ಲಿ ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಬಗ್ಗೆ ಮಾತಾಡೋಣ. ಈ ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಗ್ರೂಪ್ಸ್ನಲ್ಲಿ ಎಲ್ಲೆಲ್ಲಿ ಎಕ್ಸೆಪ್ಷನ್ಸ್ ಬರ್ತಾ ಇದೆ. ಜನರಲಿ ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಡಿಕ್ರೀಸ್ ಆಗಬೇಕು, ಬಟ್ ನಾನು ಎಲ್ಲೆಲ್ಲಿ ಎಕ್ಸೆಪ್ಷನ್ಸ್ ಬರ್ತಿದ್ದಾವೆ ಅಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಗ್ರೂಪ್ 13ನಲ್ಲಿ ನಮಗೆ ಬಂದುಬಿಟ್ಟು ಸೈಜ್ನಲ್ಲಿ ತುಂಬ ವೇರಿಯೇಷನ್ಸ್ ಇರೋದು, ಆಮೇಲೆ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಆಫ್ D and F ಆರ್ಬಿಟಾಲ್ಸ್ ಅಪ್ಲೈ ಆಗೋದ್ರಿಂದ ಇದು ಈ ಥರ ಇರುತ್ತೆ. ಗ್ರೂಪ್ 14 ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಈ ಗ್ರೂಪ್ 14ನಲ್ಲಿ ಕಾರ್ಬನ್, ಸಿಲಿಕಾನ್, ಜರ್ಮೇನಿಯಂ ಲಾಸ್ಟ್ 2 ಎಲಿಮೆಂಟ್ಸ್ ಮಾತ್ರ ರಿವರ್ಸ್ ಆಗ್ತವೆ. ಸೊ ಲೆಡ್ ಫಸ್ಟ್, ಟಿನ್ಗೆ ಲಾಸ್ಟ್. ಇದು ಗ್ರೂಪ್ 14ನಲ್ಲಿ. ಈ 2 ಗ್ರೂಪ್ಸ್ನಲ್ಲಿ ನಮಗೆ ಮೇನ್ಲಿ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ 1ನಲ್ಲಿ ಡಿವಿಯೇಷನ್ಸ್ ಅನ್ನೋವು ಬರ್ತಿರ್ತವೆ. ಇದಾದ ನಂತರ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ಡಿ ಬ್ಲಾಕ್ನಲ್ಲಿ 4D 5D ಸೀರೀಸ್ನ ಎಲಿಮೆಂಟ್ಸ್ನ ಸೈಜಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪೀಸ್ನಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಬರ್ತಾ ಇದೆ. ಸೊ ಜಿರ್ಕೋನಿಯಂ, ಹಾಫ್ನಿಯಂಗಳಲ್ಲಿ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಜಿರ್ಕೋನಿಯಂಕ್ಕಿಂತ ಕೂಡ ಹಾಫ್ನಿಯಂ ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ದಟ್. ನಿಯೋಬಿಯಂಕ್ಕಿಂತ ಕೂಡ ಟ್ಯಾಂಥಲಮ್ ಹ್ಯಾಸ್ ಅ ಹೈಯರ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಈ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಇವು ಇಂಪಾರ್ಟೆಂಟ್ ಡಿವಿಯೇಷನ್ಸ್ ಇನ್ ಗ್ರೂಪ್ಸ್ ಆಫ್ ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಈಗ ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇನ್ ಪೀರಿಯಡ್ ಅಬ್ಸರ್ವ್ ಮಾಡೋಣ. ಇನ್ ಅ ಪೀರಿಯಡ್ ನಾವು ಫಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿಯನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಇದು ಈ ಥರ ಇರುತ್ತೆ. ಫಾರ್ ಲಿಥಿಯಂ, ಬೆರಿಲಿಯಂ, ಬೋರಾನ್, ಕಾರ್ಬನ್, ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ಫ್ಲೋರಿನ್, ನಿಯಾನ್. ಜನರಲಿ ಏನಾಗುತ್ತೆ, ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಸೈಡ್ ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ ಎಕ್ಸೆಪ್ಟ್ ಫಾರ್ ನಿಯಾನ್ಗೆ ವ್ಯಾನ್ಡರ್ ವಾಲ್ ರೇಡಿಯಸ್ ಬರುತ್ತೆ. ಸೊ ಅದು ಎಕ್ಸೆಪ್ಷನ್. ಬಟ್ ಫ್ರಮ್ ಲಿಥಿಯಂ ಟು ಫ್ಲೋರಿನ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಸೈಜ್ ಅನ್ನೋದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅನ್ನೋದು ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ಆದರೆ ಡ್ಯೂ ಟು ದಿ exceptions in electronic configurations that we have here, there is an exception of ionization enthalpy also. Let's focus on that. ಇದರಲ್ಲಿ NS2 ಕಾನ್ಫಿಗರೇಷನ್ ಬರ್ತಾ ಇದೆ, ಇದರಲ್ಲಿ NS2 NP1 ಕಾನ್ಫಿಗರೇಷನ್ ಬರ್ತಾ ಇದೆ. ಇಟ್ ಈಸ್ ಈಸಿ ಟು ರಿಮೂವ್ ಅ P ಎಲೆಕ್ಟ್ರಾನ್ ಡ್ಯೂ ಟು ಲೆಸ್ ಪೆನೆಟ್ರೇಷನ್ ಎಫೆಕ್ಟ್ ಕಂಪೇರ್ಡ್ ಟು S ಎಲೆಕ್ಟ್ರಾನ್. ಹಾಗಾಗಿ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ಗೆ ಹೈಯರ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇರುತ್ತೆ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ ಗ್ರೂಪ್ 13 ಎಲಿಮೆಂಟ್ಸ್. ದೇರ್ ಫೋರ್ ಲಿಥಿಯಂಗೆ ಲೀಸ್ಟ್ ಇದೆ, ನೆಕ್ಸ್ಟ್ ಬೆರಿಲಿಯಂ ಬರಲ್ಲ, ಅದರ ಬದಲು ಬೋರಾನ್ ಬರುತ್ತೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಅನಾಮಲಿ ಟು ಬಿ ಅಬ್ಸರ್ವ್ಡ್. ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್ ಸೇಮ್ ಇರುತ್ತೆ. ಇದಾದ ನಂತರ ನೈಟ್ರೋಜನ್ ಮತ್ತು ಆಕ್ಸಿಜನ್ ಕೇಸ್ನಲ್ಲಿ ಇದೇ ತರಹ ಒಂದು ರಿವರ್ಸಲ್ ಬರುತ್ತೆ. ನೈಟ್ರೋಜನ್ NS2 NP3 ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನು ಹೊಂದಿದರೆ ಆಕ್ಸಿಜನ್ NS2 NP4 ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನು ಹೊಂದಿದೆ. NP4 ನಲ್ಲಿ ಫಸ್ಟ್ ಆರ್ಬಿಟಾಲ್ನಲ್ಲಿ ದೇರ್ ಆರ್ ರಿಪಲ್ಷನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. NP3 ನಲ್ಲಿ ಅಂಥ ರಿಪಲ್ಷನ್ಸ್ ಏನಿಲ್ಲ. ದೇರ್ ಫೋರ್ NP3 ರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತೆಗೆಯೋದು ಕಷ್ಟ ಕಂಪೇರ್ಡ್ ಟು ದಟ್ ಆಫ್ NP4. ಹಾಗಾಗಿ ಆಕ್ಸಿಜನ್ಗೆ ಕಮ್ಮಿ, ನೈಟ್ರೋಜನ್ಗೆ ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಬರುತ್ತೆ. ಅದಾದ ನಂತರ ಫ್ಲೋರಿನ್, ನೆಕ್ಸ್ಟ್ ನಿಯಾನ್. ಇದು ಇದೇ ತರಹ ಫಸ್ಟ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆರ್ಡರ್ ಅನ್ನೋದು ಇರುತ್ತೆ. ಇದು ಗ್ರೂಪ್ಸ್ನಲ್ಲಿ ಪೀರಿಯಡ್ನಲ್ಲಿ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗಿದೆ. ಇದೇ ತರಹ ನೆಕ್ಸ್ಟ್ ಫಾಲೋವಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಕೂಡ. ಫಾಲೋವಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದರೆ ಏನು ಬರ್ತವೆ? ವಿ ಹ್ಯಾವ್ ಸೋಡಿಯಂ, ಮ್ಯಾಗ್ನೀಷಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ, ಸಿಲಿಕಾನ್, ಫಾಸ್ಫರಸ್, ಸಲ್ಫರ್, ಕ್ಲೋರಿನ್, ಆರ್ಗಾನ್. ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತ ಕೂಡ ಲೀಸ್ಟ್ ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಇರೋದು ಸೋಡಿಯಂ. ಥರ್ಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಇಲ್ಲಿ, 13th ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಇಲ್ಲಿ, ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಚೇಂಜ್. ದೇರ್ ಫೋರ್ ಇಟ್ ಬಿಕಮ್ಸ್ ಮ್ಯಾಗ್ನೀಷಿಯಂ ಹಿಯರ್. And then silicon is followed as it is. ಫಾಸ್ಫರಸ್ಗೂ ಸಲ್ಫರ್ಗೂ ಒಂದು ಎಕ್ಸ್ಚೇಂಜ್ ಈ ಥರ ಆಗ್ತಾ ಇದೆ. ದೇರ್ ಫಾರ್ ಸಲ್ಫರ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ಫಾಸ್ಫರಸ್ ದೇರ್, ಕ್ಲೋರಿನ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ಆರ್ಗಾನ್ ದೇರ್. This is the order for the first two periods of the periodic table with regard to first ionization enthalpy. Therefore, the chapters I'm reminding you once again from my track for tomorrow's exam. There will be thermodynamics, equilibrium, and also there will be periodic classification. And follow the sheet that has been sent to you with regard to the syllabus. We will stop here for today, and on Monday we will start with another chapter. Thank you.
Good morning, students. Last class lo ray optics amma only refraction on the plane surface and the lenses some important models are complete amma. Today prism and optical instruments. On tomorrow exam syllabus dual nature, atoms, nuclei, semiconductors and ray optics in my track. So already on another track na sorry is explained also, right? Okay, so in a ray optics amma today concept is a prism. Now first okay 5 minutes I am explaining the some important formulas. So in a prism, this is the known as angle of the prism or refracting angle. Angle of the prism or refracting angle. Light ray incident, here this is the normal line, make some angle I1, refraction, light emergence. Here R1, here emo R2, this one emo I2. I1 incident angle, I2 is the emergent angle. R1, R2 are the refraction angles. A is the angle of the prism or refracting angle. Is the refracting angle. Now this light ray can be extended amma. Emergent light ray can be extended. The angle between them is known as deviation. The angle between the incident ray and emergent ray, incident ray and emergent ray, that angle between them is known as deviation, is known as deviation. Okay, deviation. Now first point, what is the relation between A, R1 and R2? A is equal to R1 plus R2. A is equal to R1 plus R2. What is the formula of deviation? I1 plus I2 minus A. Deviation is equal to I1 plus I2 minus A. Very important formula. Next point, the graph between the angle of the incidence and deviation is like this one. Okay, like first, as the incident angle is increases, as the incident angle increases, deviation value first decreases and then increases. Very important formula. Now at a particular deviation, this is the one light, one imaginary line, you can draw them. This is the deviation gamma. Here the angle of the incident I1, no, this one is the angle of the emergence I2 gamma. At a particular deviation, this is the deviation I1 plus I2 minus A ga. At the deviation incident angle, emergent angle. At the deviation incident angle, this is the emergent angle. Now here minimum deviation. Minimum deviation exactly in this line what happens? This I1 and I2 both are at the same point. That means I1 is equal to I2. At the minimum deviation, incident angle is equal to emergent angle. At the minimum deviation, incident angle is equal to emergent angle. Now another important point. Now at the minimum deviation, this is the incident light, this is the emergent light, this is the inside the light. That inside light is parallel to the base. Base and this light, these two are parallel only at minimum deviation. Only at a minimum deviation, the light ray inside the prism is parallel to the base, right? At a minimum deviation, the refractive index is equal to sin A plus minimum deviation by 2 by sin A by 2. At a minimum deviation, the refractive index of the prism mu is equal to sin A plus minimum deviation by 2 by sin A by 2. Another important formula. Now next one, the deviation is equal to mu minus 1 into A. Deviation is equal to mu minus 1 into A. That deviation is directly proportional to refractive index. So more deviation having the more refractive index material. More deviation of the light is produced by the more refractive index of the material. Now that point is also important one. So in a prism, these all are the main important points. A is equal to R1 plus R2. At the minimum deviation, what happens? I1 is equal to I2 nega. I1 is equal to I2, then R1 is equal to R2. I1 is equal to I2, R1 is equal to R2 only at the minimum deviation. Only at the minimum deviation, what is the refractive index? Sin A plus minimum deviation by 2 by sin A by 2. At the minimum deviation, what is the light ray inside the prism? Parallel to the base. Parallel to the base. This is the graph deviation and angle of the incidence. What happened? As the incident angle is increases gradually, first deviation decreases and then increases. At a particular deviation, we can draw the one dotted imaginary line. This one is I1, this one is the I2. This is the least value. At the least value here, I1 and I2 are both are same. I1 and I2 both are same. Another important point. At the minimum deviation, I1 is equal to I2. I1 is equal to I2. Then R1 is equal to R2 also. R1 is equal to R2 also. That is the another point. Next. Deviation is equal to mu minus 1 into A. So the deviation value is proportional to refractive index. So these all are the simply important points on the prism. Now we can explain the some models. Compulsory. Already previous I am told that one in every year one question on the lens, one question on the prism is compulsory is given. I am explained the number of times. But on 2026 on May 3rd an exam also ray optics lo 2 questions. One is lens, one is prism. So on next time on re-NEET exam also one is nothing but lens, one is another nothing but prism. Maximum 99% lens prism questions are given. So we can practice that model samma. Right 2026 on May 3rd exam this question is the given. Diagram is given. Equilateral prism like 60 degrees. Equilateral prism like 60 degrees. The refracted ray is parallel to the base and the angle of the incident is 50. Here angle of the incident is 50. The refracted ray is parallel to the base. Clearly given. The refracted ray is parallel to the base and the light is emergent. Right. What is the deviation? What is the deviation? I1 value 50 Angle of the prism is 60 What is the deviation? How to find that one What is the deviation? Already we know that the light ray inside the prism parallel to the base, at that condition deviation is minimum. Now at the minimum deviation, generally deviation formula I is equal to I1 plus I2 minus A. But parallel to the base means it is the minimum deviation at the minimum deviation. In minimum deviation I1 is equal to I2 and these two values are same 2I minus A. 2I minus A. 2. What is the value of I is given 50 minus 60. 100 minus 60. So the minimum deviation is 40. That is the 2026 question. Not only 2026 previous questions are also the same This whatever may be the models are given, same models. Now explain the some important models. On rough paper please note it Now another model. First listen carefully. A light ray is incident at an angle of 60 degrees on a prism of the refracting angle 60. The refractive index is root 3. What is the angle between the incident and emergent ray? This is the prism Light ray is incident at an angle 60. Light ray is incident at an angle 60 degrees on a prism of refracting angle. Refracting angle means angle of the prism. Incident angle means 60 is given. Refractive index value, mu value root 3. That's why what is the angle between the incident and emergent? Light ray, incident light ray, this is the emergent light ray. extending them. What is the angle between the incident and emergent? Is the deviation ega? Is asking the what is the deviation? What is the deviation? How to solve that one, Amma? So here Amma is asking the deviation. Angle of the prism is 60. So here Amma, angle of the incident is 60. Is asking the deviation. What is the deviation formula? I1 plus I2 minus A. In a question Amma is not given the minimum deviation. Not given a compulsory take the formula I1 plus I2 minus A. At a minimum deviation Amma 2I minus A. But here minimum deviation is not given. So general case. How to solve that one? I1 value is equal to how much? 60 plus I2 value don't know. I2 value don't know. What is the angle of the prism? Minus value as it is, A value 60. Just we can find the I2 value Amma, we get the answer. How to solve that one? Now listen carefully. Here R1 ga, here R2 ga. Angle of the incident, refractive index, R1 value don't know. Apply the Snell's law and the first refracting surface. What is the Snell's law? This medium refractive index 1 ega. What is the angle of the incident? Sin 60. What is the medium refractive index? Root 3. What is the angle of refraction? R1. Snell's law. Sin 60. Root 3 by 2. Sin R1. Root 3 cancel. Sin R1 is equal to 1 by 2. R1 value is how much Amma? 30. This value 30 Amma. This value 30. How to find the R2 Amma? Already we know that A is equal to R1 plus R2 nega. A value is equal to how much? 60. R1 value is equal to how much? 30. Then automatically this value is also 30 nega. This value is also 30 nega. Because of A is equal to R1 plus R2. A is equal to R1 plus R2. R2 value is also 30. Next, R2 value 30, refractive index is given. How to find the I2 value Amma? Again Snell's law. Again Snell's law. What is the Snell's law? Root 3 into sin 30. Root 3 into, take them again one more step. Root 3 into sin 30. Air medium egada 1. 1 into sin I2. Root 3 into sin 30 1 by 2. Sin I2. Therefore, I2 is equal to how much Amma? 16 ega. I2 is equal to 60. I2 is equal to 60. So already here 60 value is there, substituting plus 60 minus 60. Therefore, the deviation value is 60. So this is the another model Amma. Now listen carefully. Angle of the prism given. Incident angle is given. Refractive index value given. These three values are given. Find the deviation. What is the formula of deviation? I1 plus I2 minus A. I1 value, angle of the prism is given Amma. But we don't know about the I2 value. How to solve that one? Here Amma, mu value given gamma. First we can find the R1 by the Snell's law. 1 into sin 60 is equal to root 3 into sin R1. Sin R1. We don't know value ga. So sin 60 root 3 by 2 root 3 into sin R1. R1 value 30. R1 value 30. Right. Already we know that A is equal to R1 plus R2. A value 60. R1 value 30 plus R2. Then R2 value is automatic 30 gamma. R2 value 30. Again Snell's law. Mu root 3 into sin 30. 1 into sin I2. So root 3 into sin 30 1 by 2 sin I2. That's why I2 value is nothing but 60. That value substituting here Amma, we get the deviation. So this is the one of the important formula. And the model is also the very, very important Amma. Only minimum deviation 2I minus A. Otherwise, take them I1 plus I2 minus A. So model is important Amma. Right. Now one more model. One more model. So this is also the important model, amma. Now listen carefully. One face of the prism with a refracting angle of 37 is coated with silver. This is the prism. One face is the silver coating, amma. One face is the silver coating. Whose refracting angle means angle of the prism is 37. A light ray is incident of one face at an angle 60 degrees. Light ray is incident at an angle 60 degrees. Is refracted, here surface ga light is refracted and reflected back from the silver coated face and retrace its path. Actually, this is the silver coating means plane mirror. When this light is striking on the mirror, it rebounds back and retrace its path. What is the meaning of retrace its path, amma? Whatever may be the going the path, amma, it is a reverse. That is known as retrace its path. That's why what is a refractive index? Is asking the question. Now listen. Light ray is retrace its path means, amma, exactly rebound back. At rebound back means, amma, now listen carefully, this is the plane mirror. Light is striking normally. Normally striking, what happen, amma? Rebound back. So compulsory rebound back means the light ray striking the surface normally. Here also same one. Here, amma, after refraction, light is striking normally. Light is striking normally. What happens, amma? Retrace its path as it is reverse back and going away. That's why what is the value of mu? Now listen carefully. This is 90. This is the 37. Automatic this one 53. 53 because of sum of the angles 180. This is the normal line. Normal line. This surface the normal. 53 means this one 37. This one is 37. This one is remove it. Amma. So here incident angle 60, refracting angle 37. How to find the mu value, amma? Snell's law. What is the medium refractive index? 1 into sin 60. What is the medium, mu into sin 37? Sin 37. Sin 60, root 3 by 2. Mu, sin 37, 3 by 5. Therefore, mu is equal to 5 root 3 by 6. Is the given mu is equal to 5 root 3 by 6. Now problem is over. Options are is given like this one. So very important model, amma. Retrace its path. Retrace its path means this is the plane mirror. Silver coating, amma, this surface is behaves as a plane mirror. In case of the plane mirror, light ray striking exactly normally and rebound back. So that's why here angle 90. This is the 37 and is 53. This value 53 means this value automatic 37 because of normal line. Normal line means with the surface 90 and 37. Apply the Snell's law. That's why we get the mu value. So another important model. Now one more model, amma. In a 2024 question, amma. In a 2024 question, actually the diagram is given very clearly. Here 90 degrees, amma. In a diagram, amma, 90 degrees is given. Here, amma, light ray is incident, amma, with 30 degrees is given, amma. Light ray is a refraction, amma. After that, it is the grazing. After that, it is the grazing. So, what is the refractive index of the prism? Again, amma, what is the refractive index of the prism? Here, what is the angle of the prism, amma? 90. Angle of the prism is 90. That's why, what is the refractive index of the prism? This is the diagram is clearly given, amma. Here, amma, angle of the prism is 60. The light ray incident, how much angle, amma? 30 degrees. After refraction, the light ray on the second surface is grazing to the surface. Grazing to the surface. That's why, what is the refractive index? Now, one more model, important one. Now listen carefully, amma. Here angle is equal to how much, amma? 90 nega, grazing and 90. Already we know that on yesterday class, amma. When light ray incident with an angle, critical angle, after refraction the light ray makes 90 degrees ega. And here 90 degrees is there means compulsory here is the critical angle. And like scene. Apply the Snell's law. Here outer medium is the air vacuum ega. Apply the Snell's law. Mu into sin C. Here 1 into sin 90. Mu sin C sin 90 1 no. Sin C is equal to 1 by mu. On the second refracting surface, we can apply the Snell's law. Sin C is equal to 1 by mu. Like take the one right angle triangle, amma. C. Sin theta means opposite side by hypotenuse. Opposite side to hypotenuse. What is the other side, amma? Hypotenuse square minus 1. Okay, just take them one triangle, we can value substituting, we get the one new triangle, leave it. Now listen, but our aim is to finding the mu number. Our aim is to finding the mu. Now listen carefully, what is the value of A, amma? R1 plus R2. What is the value of A? 90. R1 value, this is the R1 value, we don't know. R2 value, what is the R2 value, amma? C. Therefore, R1 is equal to 90 minus C nega. R1 is equal to 90 minus C nega. Right. Here R1 value is noun. Here I1 value 30. Again mu value how to find, amma? Again Snell's law. Here air vacuum 1 into sin 30. This is the refractive index mu into sin R1. What is the value of R1? 90 minus C. Sin 30 1 by 2 mu. Sin 90 minus theta cos theta mu cos C. Now we can observe them. This is the right angle triangle. What is the cos C, amma? Cos theta. Adjacent side by hypotenuse. Adjacent side is root of mu square minus 1 by hypotenuse is mu. These two are cancelled. Squaring on both sides 1 by 4. Here root cancel. Therefore, mu square is equal to 1 by 4 minus 1, take them on left side plus 1. 5 by 4. 5 by 4. This is the mu square value, amma. Therefore, mu is equal to root 5 by 4, root 5 by 4 gamma like 2. Root 5 by 2. This is the 2024 question. Now again, angle of the prism is 90 degrees is given, amma. What is the angle of the incidence, amma? 30. After refraction, amma, on the second surface, the light ray is grazing to the surface. That's why, what is the refractive index? First, grazing to the surface ka angle 90, then the corresponding angle is known as a critical angle. Snell's law. Mu into sin C, 1 into sin 90. Therefore, mu sin C is equal to sin 90, 1 no. Sin C is equal to 1 by mu. Take them right angle triangle. Sin C, opposite side by hypotenuse. Now, root of mu square minus 1 remaining side. Next, apply the Snell's law on the first surface. Before that, A is equal to R1 plus R2. A value 90, R1 value we don't know, R2 value C. Therefore, R1 is equal to 90 minus C. R1 value came. Here I1 value 30. Apply Snell's law. 1 into sin 30 is equal to mu into sin R1. R1 means 90 minus C. Sin 30 1 by 2 cos C. So 1 by 2 mu cos C is nothing but adjacent side by hypotenuse. Cancel, squaring on both sides, we get the answer. This is the another important model. So in every year, maximum possibility question prism. Simple models are is given. So compulsory in our material we can do that total models. Right. Now one more question. Now one more question. Here diagram is given. Diagram is given. Here 90 degrees. One light ray horizontally striking. Now here this is the normal ga, light ray is nothing but emerges. Here mu value is 3 by 2 is the given. Here angle is 6 degrees amma. What is the angle of the prism amma? Angle of the prism is 6. Now what is the question amma? A horizontal light is incident on the right angled prism of an angle 6 degrees. If the refractive index of the prism is 3 by 2, then find the angle of the emergence like this angle. What is the angle of the emergence? What is the angle of the emergence? Like I2, emergent angle is nothing but I2. What is the angle of the emergence? Now listen, here light ray is striking horizontally. What is the incident angle amma? Incident angle like I1 value, not 90, it is the 0. Incident angle can be always taken with normal ga. With normal, the angle of the incident is 0. With the surface 90 amma. With normal 0. I1 value 0, then automatic R1 value is also 0 ne. R1 value is also 0 ne. Right, that is the first point. Next one. Our aim is to finding the I2. Mu value is given. How to find the R2? R2 value is equal to how much amma? We can observe them amma. This is the right angle triangle ga. Here 90. This one 6. Automatically this is the 84 ga. Because of total sum of the angle 180 ga. So 84 and automatically this one is 6 ga. This one is also 6. And like R2 value 6 amma. Now apply Snell's law. What is the mu value amma? 3 by 2 into sin 6 is equal to outer medium 1 into sin I2. But here amma sin 6 and very small angle. Already we know that for small angle sin theta value is approximately equal to theta ne. That value is also equal to tan theta also. Only for small angle, sin theta value is equal to theta, that value is also equal to tan theta. Now 3 by 2, sin theta is equal to theta nega. Sin theta is equal to theta nega. Right, 2 here 3 times amma, 3 3s are 9. Therefore, the angle of the emergence is nothing but 9. Angle of emergence is 9 degrees. So this is the, for small angled point of view amma, this is the one of the important model. Next amma, now one more model. All of you try this model amma. Mu value is root 3, here angle 60. Light ray striking here this one. What is the angle of the emergence? Find angle of emergence. Find angle of emergence. Find angle of emergence amma. Right. Same model amma, same model, but another model is the given amma on the previous NEET question era. Right, all of you note that one amma, try it that one. Right, when light ray, here amma, this is the right angle prism amma, here 90 amma, this one ammo 60 ra, automatic this one is 30 nega. So first one is angle of the prism is 30. Next, the light ray striking normally, what is the angle of the incident amma? Angle of the incident can be taken with normal ga, and this light ray with normal is nothing but 0 ne. And I1 value is equal to how much amma? 0. Then automatic R1 value is also 0 ne. This light amma striking exactly like this one. After refraction this one is asking like this value. What is the angle of the emergence? How to find the R2 value? Already previous one I am explained. Here is how much amma? 90. This value 30. Automatic this one is 60. Sum of the angles 180 kada. This value 60 means this value 30. Because of this surface with this is the normal line gamma, total 90. and this is the 60 means this is the 30. So mu value 30, here emo air vacuum I2. How to find them? Snell's law. Right, mu value root 3 into sin 30, root 3 into sin 30, 1 into sin I2, 1 into sin I2. Root 3 sin 30, 1 by 2, sin I2, sin root 3 by 2, sin 60, sin 60 root 3 by 2. That's why what is the angle of the emergence, amma? So is asking the angle of the emergence, amma, how much value, amma? 60. So this is the one more model, amma. Compulsory, amma. Already we have the some notebooks are there, amma. We can solve the all the number of the questions on the Prism models. Maximum lenses and prism, lenses and prism compulsory again. That are two concepts na problems are is given. Now, one more last model, amma. Now, last model on the prism. After that, go to the optical instruments. The angle of the incidence for a ray of light and the refracting angle of the prism is 45. Angle of the incidence, amma, is the 45, and angle of the prism is 60. Angle of the prism is 60. If the light ray suffers the minimum deviation through the prism, is the given, amma, minimum deviation. At the minimum deviation, already we know that light is parallel to the base. After that, refraction ega. Right. What is the angle of the minimum deviation and the refractive index of the prism? What is the refractive index? What is the angle of the minimum deviation? That is the question. The only data is incident angle 45 and angle of the prism is 60. But is the clearly given at a minimum deviation. Already we know that at the minimum deviation the light is inside the prism is parallel to the base. That is the important point. How to solve that one? Here amo R1, this one amo R2. Already we know that R1 is equal to R2 nega at the minimum deviation, and also A is equal to R1 plus R2. A value is how much, amma? 60. Both are same ega, 2R. Therefore, R value is how much? 30. And this value 30 ne, this value 30 ne. How to solve that one, amma? First, minimum deviation. I1 plus I2 minus A. But already we know that at the minimum deviation, I1, I2 both are same ega, 2I minus A. 2 into I value is how much? 45. A value 60. 100 minus 60. 100. Sorry. 2 into 45. 90 minus 60. 30. Therefore, we get the minimum deviation 30. We get the minimum deviation 30. How to find the refractive index? I value and R value already we know that. How to find the refractive index? Snell's law. Snell's law. This is the air vacuum. 1 into sin 45. 1 into sin 45. This one mu into R value 30. Mu into sin 30. Sin 45 1 by root 2. Sin 30 1 by 2. Therefore, mu is equal to 2 by root 2. This root 2 value root 2 times cancel. Therefore, mu value root 2 and deviation value 30. So, simple model summa. Number of the models, we can do the any number of the model summa. Like one is formula based, other one Snell's law compulsory. Formula Snell's law. Formula Snell's law. That is the important models. So, these all are the important models on the prism. Next simple microscope. Just we can remind the formulas are no simple microscope, compound microscope and astronomical telescope. Each one maximum of 5 to 10 minutes we can remind the formulas and each concept now we can explain the one or two models. Now listen carefully. Simple microscope. This is the convex lens. This is the focus. When object is lies between the focus and optical center this is the object When object is lies between the focus and optical center we get the image like this one. We get the image like this one. And for small object can be magnified and a simple microscope small object can be seen as a larger That's why this is known as a simple microscope. First point if image at infinity, what is the magnification like d by f. Just I am writing the only formulas If image at infinity, what is the magnification d by f. Next, image at d. What is the magnification 1 plus d by f. 1 plus d by f. By using this simple microscope, when final image at infinity, what is the magnification d by f. When final image at d distance, d is nothing but least distance of distant vision, 25 centimeter fixed value. In case of the given take them, otherwise take as a 25. 1 plus d by f. This one d by f This one 1 plus d by f In these two, which value is more This one sometimes is asking the maximum magnification. Maximum magnification is also nothing but image at DNA. Because compared to this one this value is more So maximum magnification is nothing but magnification at DNA. 1 plus d by f. Image at infinity means d by f. So that 2 points are the important on the simple microscope. Only 2 formulas. Right. Now second one, compound microscope. Now listen carefully This one is the important one In last year 2025 the given question are on compound microscope. Now listen carefully. This is the objective, this is the eyepiece. I am not draw the ray diagram Simple clear explanation. Now listen. This one is the objective focal length f0. Eyepiece focal length is fe. When object is like this one like what is that is u0. The image is like this. This is the object this is the image. What is this value? v0. Object u0 v0. The image formed by this object is behaves as an object for eyepiece. The final image is like this. By this eyepiece the final image like this. The image of the object is behaves as object like this distance is ue final distance ve. This is the rough diagram. Very important one. Object this is the lens object to lens u0 object distance image distance. This image is behaves as object like ue final image ve. This is the length of the tube length of the tube is nothing but distance between the object and eyepiece is nothing but length of the tube. Now first case, the total magnification is equal to magnification of the object and eyepiece. Very important formula. The total magnification is equal to magnification of the object into magnification of the eyepiece. First formula. Second one, magnification at infinity. When final image value is infinity, what is the magnification formula? v0 by u0 into d by fe. v0 by u0 into d by fe. Compulsory here minus is there. What is the meaning of minus sign amma? With respect to object, final image is inverted ga, that's why a minus. Only this is the formula important. Third, next point amma. What is the length of the tube? What is the length of the tube at that case amma? V0 plus Fe. Length of the tube, when a magnification at infinity, the length of the tube. These two are the important one. Third point, magnification at D, like minus V0 by U0, 1 plus D by Fe. 1 plus D by Fe. That is the another important formula. Magnification at D, the final image is formed at D, then what is the magnification at D amma? Minus V0 by U0 into 1 plus D by Fe. 1, 2, 3, that three formulas are the very, very important. Now, one small point, now listen carefully. The magnification at infinity, that can be also written as LD by F0 Fe. This is the 2025 question is the given like this one. The magnification at, in case of the V0 to U0 values are given amma, take them like this one. Sometimes direct length of the tube is given. Length of the tube is given amma, like take this formula. The magnification at infinity is equal to LD by F0 Fe. This is the 2025 question amma. Not only 2025 amma, and the previous mains number of the times. So this is the important formula. 1, 2, 3. Okay, 2-3 times we can practice the formula amma. Compulsory possibility is there on the compound microscope. Now last point amma. Just remind the formulas amma. Only note these formulas is enough amma. Astronomical telescope. Astronomical telescope. In astronomical telescope, now listen. This is the objective, this is the eyepiece. Here objective having the smaller focal length, eyepiece having the larger focal length. In a telescope, objective having the larger focal length, eyepiece having the smaller focal length. Now, only one formula. When object is at infinity, object at infinity. Object at infinity means the image is formed at a focus. Object at infinity means the image formed at a focus. The image is behaves as object like UE, like final image like this one. One of the only one point. What is the magnification at infinity? F0 by Fe. Length of the tube is F0 plus Fe. Only this formula is important in astronomical telescope. Just remind the formula sama. Only that explanation one period is there. But here I am only remind the formulas. The magnification at infinity, the final image is formed at infinity. Then what is the magnification amma? F0 by Fe. When magnification is F0 by Fe, what is the length of the tube amma? F0 plus Fe. So on astronomical telescope this is the very important formula. Any models are there amma, maximum 99% of the models are only this concept. So these all are the just formulas, just I can remind astronomical telescope, compound microscope is the important. Just for each one having the one example amma, right. Now one more one example amma. The magnifying power of the telescope is 9. Magnifying power means magnification amma. Magnification is 9. and it is adjusted in a parallel rays, the distance between the objective and eyepiece. Already we know that. What is the distance between the object and eyepiece, like length of the tube? The length of the tube is 20. That's why what is the focal length of the lenses? What is the focal length of the lenses means objective and eyepiece focal lengths are how much? This is the telescope. Telescope lo magnification value is 9 and the length of the tube is nothing but 20 centimeter. Is the clearly given as the final image is parallel to the lens. When light rays are is parallel to the lens means when image is formed infinity nega, like magnification at infinity. What is the formula of magnification infinity for the telescope? F0 by Fe nega. That value is equal to how much? 9. Magnification at infinity, what is the length of the tube formula? F0 plus Fe nega. What is the value? 20. Only one formula. Right. What are the, how to find the focal length? F0 value is equal to how much? 9 Fe. F0 plus low 9 Fe. Already here Fe. 10 Fe. 20. Therefore, Fe is equal to 2. Fe is equal to 2, that Fe value substituting here, F0 value 18. So, F0 plus Fe both are adding, we get 20 nega. F0 by Fe 18 by 2 9 nega. That's where we get the focal length of the objective and eyepiece. This is the important model. So, astronomical telescope lo only one model like this one. So, the magnification formula is F0 by Fe, that value 9. What is the length of the tube at infinity? F0 plus Fe is equal to 20. So, that values are substituting, we get the F0 and Fe. So, important model, right. Now, next another model in a compound microscope we explain the one model. Right. Now listen. One example in a microscope. In a microscope one more example Now listen. In a compound microscope. In a compound microscope, the focal length of the objective and eyepiece are 2 and 5. Take them one rough diagram. Already we know that. What is the focal length of the objective like 2 centimeter. What is the focal length of the eyepiece 5 centimeter. An object is placed 2.4 centimeter in front of the objective lens, like this one, like this value U0, 2.4 centimeter. The final image is formed at infinity. Final image is formed at infinity. Already we know that. This is the object image like this. This image by this one like this one. But this final image value is how much? Infinity. That's why what is the magnification and the length of the tube? What is the magnification and the length of the tube? Is asking the 2 points. Now listen carefully. Right. First, already we know that in a compound microscope, magnification at infinity, what is the formula? Minus V0 by U0 into D by Fe nega. We can check them, What is the magnification at infinity, Minus V0 by U0 into D by Fe. We can check them. Already I am explaining. At the infinity, what is the length of the tube, What is the length of the tube? V0 plus Fe. At infinity, the length of the tube is V0 plus Fe. Only 2 formulas. But we can observe them. F0 to Fe values are already we know that. D value 25 already we know that. U0 value 2.4 centimeter already we know that. What is the unknown value right here? V0. And like this is the lens gamma. The image is formed like this one V0. And we don't know about the V0. Once we have the value of the V0, the 2 parameters is complete. How to find the V0 value? Already we know that this is the lens object distance, focal length. How to find the image distance, Amma? By the lens formula. What is the lens formula? 1 by f is equal to 1 by v minus 1 by u. What is the focal length value? 1 by 2. V value we don't know. Light rays is moving in this side, gamma. Take them object value negative. And minus or minus plus 2.4 and 24 by 10. Right. What is the value of 1 by v? 1 by 2 minus 10 by 24. What is the LCM? 24. 2 here 12 times. 24 1 time 1 into 10 10. And 2 by 24. Reverse. V value 24 by 2 12. And like V naught value came. What is the V naught value? 12 centimeter came. Right. How to find the magnification at infinity? What is the value? Minus V naught by U naught into D by F nega. Minus V naught value is how much? 12. U naught value is how much? 2.4. What is the value of D? 25. What is the value of Fe? 5. So minus 24. The 2.4 means 24 by 10 nega. Here I am 5 times. This value is equal how many times? 5 times. 5 5s are. So the magnification is minus 25. How to find the length of the tube, amma? V naught plus Fe nega. What is the V naught value, camera? 12. Plus what is the value of Fe, amma? 5. How much, amma? 17 centimeter. So that's why, amma, that formulas, amma, only based on the formulas are important. Here, in case of the compound microscope, amma, the final image is formed at infinity and the final image is formed at infinity. Then magnification or length of the tube is asking. But object distance 2.4 centimeter is given. 2.4 centimeter is given. We don't know about the image distance. That image is behaves as the object. The final image is formed at infinity. This one is at infinity. When final image at infinity means object is at focus ega. Object is at focus ega. That's why what is the length of the tube? V naught plus Fe nega. V naught plus Fe. What is the magnification at infinity formula? Minus V naught by U naught into D by Fe. So in these two formulas, only V naught value unknown. V naught value unknown. Once we can find the V naught value, we get these two parameters. How to solve that one? Focal length 2, object distance 2.4. How to find the V naught, by the lens equation. 1 by F is equal to 1 by V minus 1 by U. 1 by 2, 1 by V. U value negative ga, and 2.4 ga, 24 by 10. This value simplifying, we get 12. That 12 centimeter value substituting in these two. First formula and second formula. We get the answer. So compound microscope only is asking the formula based like one of the important model. Right. Already, in our material, some models are there. Just revise the notes and once do that material problems is enough, we do any problem. Now, one more model. Now, one more model, The lateral magnification of the objective of the compound microscope is 100. Objective having the magnification is 100. And magnification of its eyepiece is 20. Eyepiece is 20. That's why what is the total magnification of the compound microscope? What is the total magnification of the compound microscope? What is the formula? The total magnification of the compound microscope is equal to m naught into me. M naught into me. The product of the individual magnification of the objective and eyepiece. Like 100 into 20. Like 2000. Now, one more model. The focal length of the objective and eyepiece are F0 value is 20 and the FE value is 10 centimeters. For a telescope, amma. For a telescope, amma, the objective and eyepiece focal length values are given. What is the length of the tube for the normal adjustment? What is the meaning of normal adjustment? In a normal adjustment, what is the length of the tube? Now listen carefully, amma. Normal adjustment to image at infinity and eye is relaxed. Eye is relaxed. In all the cases are same. Now listen carefully. Normal adjustment to magnification, image at infinity, eye is relaxed. For example, amma, when object is a very, very long distance is there, amma, eye can be seen that very relaxed. So, when image at infinity, eye is relaxed. So, and normal adjustment all are same. So, in a magnific image at infinity, in case of the image at infinity, what is the length of the tube? F0 plus Fe nega. F0 plus Fe nega, 20 plus 10, 30 centimeter. 30 centimeter. So, that is the another important point. So, for a telescope, amma, focal length, eyepiece values are given, amma. In a normal adjustment, what is the length of the tube? Normal adjustment means image at infinity. Image at infinity, what is the length of the tube, amma? F0 plus Fe. 20 plus 10, no, 30. Another important model, amma. Now, next, amma, last example, amma. The minimum magnifying power of the simple microscope is 8. Given the simple microscope. Simple microscope minimum magnifying power is 8. That's why what is the maximum magnifying power? What is the maximum magnifying power? In a simple microscope, one model. Actually, only two formulas are there. Magnification at infinity d by f. Magnification at d 1 plus d by f. This is nothing but maximum magnification. This is the maximum means automatic, this is the minimum ega. For minimum values, how much value is given, amma? 8. And like this value is d by f ega. Maximum means, amma, 1 plus d by f ega. 1 plus, what is the value of d by f, amma? 8 ega. That's why we get the 9. So, in a simple microscope, minimum magnification means d by f, amma. Maximum magnification and 1 plus d by f. D by f value 8, then maximum value 9. This is the another important model on the microscope and a telescope model, amma. Right. So, on tomorrow exam, amma, only this week syllabus, amma, total syllabus, DLO, atoms, nuclei, semiconductors, ray optics. Similarly, on the first year also some chapters. Okay, namma. Right. On Monday class lo, we can start with wave optics. On Monday class lo, wave optics. Right, amma. Next class continue. Thank you. Take care. Do practice.
So good morning everyone again. At the end of the yesterday's class, we are under the discussion related to this molecular basis of inheritance. Then at the end of this chapter, we have to discuss now. Yesterday we have completed the details related to human genome project except the methodology. I mean, yesterday we have seen the basic features. So remember the year 1990 to 2003, 13-year-old project involved by many countries, majorly by US Department of Energy and Wellcome Trust UK. Then see, in this non-human models and all, everything was completed. In this human genome project, the thing we have to discuss is methodology. Methodology of the human genome project. See, this methodology is having two options here. One is going to be the expressed sequence tags EST. Another one is going to be the sequence annotation SA. See here, which is the longest method means expressed sequence, shortest method is expressed sequence tags. Here we are sequencing the only DNA sequences that has represented, that is going to be expressed as RNA. The sequence which are expressed as RNA, those sequences only involved here, whereas in this case of the sequence annotation, we are sequencing the whole genome of the individual. Yesterday I told you total how many chromosomes? 24 chromosomes. Genome means haploid set of chromosomes present in a cell. See here, total 24 chromosomes we are going to sequence here, that is sequence annotation. After sequencing, it is involving two steps majorly. First we are going to sequence the whole genome. After that we are annotating the function. So annotation means assigning the function of a sequence. Then this is a blind approach, it is the lengthiest method, it is used in the human genome project. It is another method, it is a shortcut method in which the expressed sequences only analyzed. See here, sequence annotation part. First step is to isolation of the DNA from a cell. Suppose if this is a cell, inside that nuclear envelope, inside that DNA will be there. First step is going to be the isolation of the DNA. How to isolate the DNA in the biotechnology chapter we have already seen. Let me revise it later on. So first step is isolation. After isolation of the DNA from the cell, we are going to apply the restriction enzymes that leads to dissociation of the DNA into so many fragments. Why like this? DNA is the lengthiest molecule, sequencing the entire length is not an easy task. See here, it is going to be sequence, breakdown into fragments with the help of restriction enzymes. After breakdown, it is going to be involved, either you can go for separation by gel electrophoresis, or you can directly inject into the host with the help of the vector. Here two kinds of vectors are there. One is the yeast artificial chromosome, another one is the bacterial artificial chromosome. If the length of the DNA is large, we can utilize the yeast artificial chromosome. Small DNA fragments can be carried by bacterial artificial chromosome. So both of these two are the vectors which are going to carry the DNA. Then these are going to useful for transferring into the host. The two kinds of hosts are there here. One is the yeast. Yesterday I told you, it is a Saccharomyces cerevisiae, unicellular eukaryotic fungus. Next, bacterial artificial chromosome you can utilize with the bacteria itself. One is a eukaryote, another one is a prokaryote. This leads to the amplification or cloning procedure, making multiple identical copies. After cloning, the next step is going to be the sequencing process. So the sequencing is done by the machine, we can call it as a sequencer, automated DNA sequencer. This is works under the principle provided by Frederick Sanger. Sanger is the scientist who had given the method how to sequence the DNA fragments. Next, after sequencing, we are going to align this. So, alignment of the DNA sequences based on overlapping regions. So, this is not humanly possible. Large number of fragments, so many thousands, hundreds, lakhs, crores of the overlapping regions are there. Humanly it is not possible. That's why we are using the computers. by using the computer, we are going to do the alignment based on overlapping sequences. After aligning them based on overlapping sequences, we are ultimately going for the annotation, assigning the function, a particular sequence, what is its function, assigning the function, it is going to be called as annotation. So, first step is isolation, second step breakdown by restriction enzymes, later on by using the vector transferring into the host, that leads to cloning, later on sequencing by using sequencer machine provided by principle of Frederick Sanger, after that alignment of the overlapping regions by using the computers, later on annotation of the product. Next, after saying that as per the Human Genome Project, the next thing here is going to be salient features of the Human Genome Project. Those are memory based things. Once you go through with them, 3164.7 million base pairs are there. Total how many genes? 30,000 genes are there. On an average, gene contains the 3000 bases. Largest gene is dystrophin. Largest gene is going to be the dystrophin, contains 2.4 million bases. 2.4, one thing you should remember, see, million is a word used in the HGP salient features, there is nowhere billion, don't confuse there. So, million, 2.4 million bases are there. Next, 50% of the discovered gene function is unknown. We know the function of only 50% of the discovered DNA or discovered genes. Next, less than 2% of the genome codes for the protein. Means remaining what is 98%, majority it is made up of repeated DNA sequences. These repeated DNA sequences do not code for any protein, but they are useful to identify the chromosome structure, dynamics and the behavior. And the last one is going to be chromosome number 1 contains 2968 genes, largest chromosome, that is why it was completed in the year 2006 May. Next, the Y chromosome containing very less number of genes, 231 genes are there. Next, SNP, single nucleotide polymorphism, in how many places you can see here is it is going to be 1.4 million locations. I told you already in the Human Genome Project salient features there is no word called billion. Here also million, here also million. Generally students confuse us 2.4, 1.4 where to use. Remember the trick, largest gene contains largest number. So 2.4 is the largest number, 2.4 million bases are there found in the dystrophin, SNP 1.4 million locations. There completes the Human Genome Project. I have touched only the important features which has to be remembered. They based on the time. Next thing to discuss is going to be the DNA fingerprinting. See, this DNA fingerprinting is a procedure which is going to use in different perspectives. Suppose in the forensic analysis to identify the criminal, or paternity testing to identify the parents, genetic diversity identification, species diversity identification, population diversity, different areas we are going to use it. See, this DNA fingerprinting procedure, if you observe, suppose there are two individuals, as per the logic, between two individuals 99.9% of the DNA sequence was same. Where comes the difference? The 0.1% is going to be difference. DNA fingerprinting is a method which is a shortcut method to compare two DNA sequences. It is a shortcut method to compare two DNA sequences. How comes the shortcut method? It is going to involve identification of the differences at some particular regions called as repetitive DNA. DNA fingerprinting should not going to be considered entire genome. It is going to focus on particular pieces of DNA which are repeated over and again. Sometimes 100 to 1000 times it is going to repeat it. Such DNA sequences which are repeated again and again, over and again they are repeated. Such sequences are going to be called as repetitive DNA sequences. This DNA fingerprinting is going to involve in the identification of differences in the repetitive DNA sequences. Next, after saying this, how to separate this repetitive DNA from the normal DNA? By using a technique called density gradient centrifugation. So density gradient centrifugation. By using this method, we are going to separate the repetitive DNA from the normal DNA. See, density gradient centrifugation already we have discussed, Michelson and Stahl experiment. There, cesium chloride density gradient centrifugation we are using. Here, it is based on the density, repetitive DNA and normal DNA will be separated. After doing this procedure, you will get a graph. That graph contains two types of peaks. One is the major peak, another one is the minor peaks. The major peak here is going to form the satellite DNA. It is going to be the satellite DNA. The minor peaks is going to be the bulk genome. What is the bulk genome? Remaining part of the DNA, we can consider it as a bulk genome. What is satellite DNA? Same repetitive DNA. After separation, we can consider it as a satellite DNA. These satellite DNA will be divided into two types. One is going to be the microsatellite DNA. Another one is going to be the mini satellite DNA. So two types are there, microsatellite and the mini satellite. This one of the type of mini satellite is the VNTR, valency number of tandem repeats. I am repeating, valency number of tandem repeats. So observe the procedure properly. DNA fingerprinting is going to identify the differences between two individuals in some particular regions of the DNA called repetitive DNA. That repetitive DNA divided from the normal DNA by using the density gradient centrifugation method. See, after doing the density gradient centrifugation, there are two kinds of peaks are formed. One is a major peak, another one is a minor peak. Major peak is formed by satellite DNA, minor peaks are formed by the bulk genome. That is a point of discussion here. So we are not supposed to involve in the separation of this bulk genome. Already we have got the satellite DNA. Satellite DNA was divided into two types, microsatellite and mini satellite. Base is of 3. Just you can go through that. Base composition first, second one length of the segment, third one number of repetitive units. Base composition, length of the segment and number of repetitive units. Based on these three, these satellite DNA was divided into micro and mini satellite. In our discussion, the type of DNA we are going to utilize is VNTR. It is used as a probe. I will give the clarity at the end of this concept. So VNTR belongs to mini satellite. Generally students confuse us. VNTR belong to micro and mini satellite. And the small trick is there. Here N is there, here N is there. Remember it. Mini satellite, it is VNTR belongs to mini satellite part. Then, after saying that, this DNA fingerprinting works under the principle of polymorphism. Works under the principle of the polymorphism. What is this polymorphism? This is variation at genetic level. Variation at genetic level arises due to mutation. Because of mutation, changes occurs in the genes at the genetic level. Such changes, such variations which are arised because of mutations, we can consider it as a polymorphism. These mutation, related to mutation, many doubts are there related to the students. So simply to say, where I am talking about, if you keep the textbook in front of you, DNA fingerprinting heading will be there. In that page, last paragraph related information I am talking about. So in that last paragraph, first they said polymorphism in bold letters. It is saying that variation at genetic level arises due to mutation. Adhe page, ending lines, I am going to give a flow chart like this, at ending lines and next page until the middle. So this is the area generally students confuses. So mutation leads to polymorphism. First point to say, mutation leads to polymorphism. Polymorphism is a principle of the DNA fingerprinting. That's why first we have to discuss about mutations and their related information. So these mutations, what is mutation? Sudden change in the DNA sequence. This mutation may happen in any kind of cells in the body. In the human genetics part, I told you already, there are particular factors that can promote the mutations. Those are called as mutagens. One of the kind of mutation, do you remember, X-rays and the ultraviolet rays or UV rays. So this mutation may happen in any place in the body. For example, somatic cells are there. Somatic cells means vegetative cells. Simply to say non-reproductive cells like hair, bone, this skin, hands, legs, all those things. Reproductive cells, we can call them as germ cells. The cells which are going to form the gametes, those cells are going to be called as germ cells. Non-reproductive cells and the reproductive cells. So, mutation may happen in the somatic cell, at the same time germ cell. Guess what ma? Which mutation can be transferred to the next generation? Obviously, the mutation which is happening in the germ cells having the capability to get transferred into the next generation. Whereas the cells which are somatic cells, which are not going to involve in the reproduction, they cannot going to cause the mutation that is going to get transferred into the next generation. So, the mutations in this are not inherited to the next generation. Okay. Next. Here the germ cells also, germ cell mutation can be transferred to next generation, no doubt in that, but there is a conditions apply. Here the condition here is the germ cells, if it is the mutation happening in the coding sequences, like our what can you say, exons which are present in RNA, exon coding DNA, structural gene, if any mutations happen in this region, if it is affecting the coding sequence of the germ cells, such mutation going to affect the reproductive ability of a person. So, it is going to affect the reproductive ability of the individual, so that it is not going to get transferred, not inherited. Why? If any mutation happens in the coding sequences, the coding sequence may get affected. It is not going to involve in the coding process. I mean by formation of the protein process that affects the individual reproductive ability, such that it is not going to get inherited to the next generation. If the germ cell mutation happening in a non-coding sequences, if it is happening in the non-coding sequences, such non-coding sequences, it is harmless, it is not going to affect the reproductive ability, so that not affected, reproductive ability is not going to get affected, so that it will be inherited to the next generations. It is go on inheriting, ultimately it will reach the entire population. Saying it again it will transfer to next generation, generation after generation it will be accumulated in the entire population, it may get transferred. If a mutation was present in more than one individual, such mutations frequency will be, if the frequency will be more than 0.01, more than 0.01. I am saying here properly observe, if a mutation happen in germ cells, that too in the non-coding sequences, it is not going to get affect the individual reproductive ability. Such mutations will be inherited and will be transferred generation after generation, and it will be transferred to entire population after some time. In a population, the mutation was found in more than one individual, so that its frequency is more than 0.01. This number is very simple. If it is present in more than one individual, its frequency we can say more than 0.01. Such mutations are called as inheritable mutations. The mutations which are transferring generation to generation and entering into more than one individual, such mutations are going to be called as inheritable mutations. These mutations is going to cause the polymorphism, and this polymorphism will be inherited from the parents to the progeny, such that in the baby what is a polymorphism is there, it will be matchable with their parents. At the same time, this polymorphism is the same in the entire body. My hair follicle, whatever polymorphism will be there, same with my skin. Entire body polymorphism will be same. How it going to work out ma? Suppose two conditions I will say to you. In a crime scene, a murder was happened. Forensic department has identified a small amount of hair follicle. From that hair follicle, they have extracted the DNA and found the polymorphism, and they are having a suspect. 2-3 fellows are there. They are going to collect the DNA samples from the 2-3 fellows. This polymorphism will be matchable to the person to the whom this hair was belongs to. Same way, in the baby, how to identify their parents? From the baby, whatever polymorphism is there is matchable with their parents. So remember two conditions. Polymorphism is inheritable from the parents to the progeny. First thing. Second thing, the type of polymorphism will be same in the entire body of an individual. That is the thing. After saying this, we have to go through the process of the DNA fingerprinting. So I hope so you got the clarity about this. Let me discuss about the process of the DNA fingerprinting. Do you remember the scientist who has given the sequencing in the Human Genome Project? Frederick Sanger. Same way, in the DNA fingerprinting, there is a scientist involved. Such scientist name is called Alec Jeffries. So the scientist is going to be Alec Jeffries is the scientist who has first used the VNTR, variable number of tandem repeat, as probe. Variable number of tandem repeats as probe utilized by Mr. Alec Jeffries. So first thing, from the individual, same first step, isolation of the DNA. We have isolated them into the test tube. After isolation of the DNA, it is going to be by using the restriction enzymes. We are going to do what? Fragmentation procedure, so that it will be broken down into number of fragments. After fragmentation, we are going to involve in the gel electrophoresis. Gel electrophoresis by using the agarose gel. I am not going to explain this again. Agarose gel is a sugar polymer extracted from natural seaweeds like Gelidium and Gracilaria. In this, wells are there at the cathode part. Opposite, it is going to be the anode. DNA was loaded here and applied the electric field. DNA will be separated based on their size. After separation, we are going to move for blotting. This blotting is considered as a southern blotting. We are taking a membrane, nitrocellulose or the nylon membrane. These nitrocellulose are nylon. For example, I am taking here nylon membrane, which are synthetic membranes. By taking this membrane, we are going to place on this, so that the DNA fragments from the gel piece will be transferred onto the nylon membrane. After that, we are going to add this point is not there in the textbook, we are going to add alkaline buffer. What is the work of this alkaline buffer? It will make the double stranded DNA as a single stranded DNA. So after transferring the DNA fragments from the agarose gel piece into the nitrocellulose or nylon membrane, we are adding the alkaline buffer, so the double stranded DNA will become single stranded. Now the DNA present here is going to be the single stranded DNA. On to this next step is going to be the hybridization. Hybridization means addition of the VNTR probe. Addition of what? VNTR probe, valence variable number of tandem repeats. So 1, 2, 3, 4, 5, 6, 7. Let me draw the large diagram for easy understanding. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this, suppose from the individual A, we are taking the repeats. In the chromosome number 1 or 2 or 3, suppose 3 repeats are there, the band will come here. 4 repeats, the band will come here. 5 repeats, the band will come here. 10, the band will come here. 9, the band will come here. In the individual B, suppose 3 are there, the band will come here. 1 is their repeat, the band is going to be here. 6, 9, 10, 12, 11, like that. So this diagram is there in the textbook once you follow that. So here how to read this diagram? Ide at a particular point, if a line is there, it is a number of repeats. It can be identified by VNTR, variable number of tandem repeats. By adding the probe, it is going to be looks like this. Last step is going to be the autoradiography. Autoradiography. First isolation, after that breakdown into pieces by restriction enzymes. Later on we are separating the DNA by using gel electrophoresis. Later on blotting, transferring into nitrocellulose or nylon membrane. Next step is adding the alkaline buffer, then adding the VNTR, variable number of tandem repeats. After that autoradiography, so that we can see the autoradiogram. In this, each band represents the number of repeats. It is autoradiogram, the sheet on which number of repeats can be shown. Suppose this is a crime scene, crime sample C. In this, at what do you say, comparatively 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose at the number 3 one band is there, number 4 one band is there, number 5 one band is there, 10. This is comparable with this one. So C is comparable with A based on the banding pattern. If it is comparable with V, the person B is the culprit. Whereas if it is comparable with the A is the individual that is going to be culprit. These bands are the number of repeats, like that. So if the time permits, we can explain this in detail way, but simply to say number of bands here and number of bands here, by looking at the numbers we have to compare the individual. So this is all about the DNA fingerprinting procedure. DNA fingerprinting is a simple method which is going to compare the differences in DNA in the individuals by employing these DNA or repeated DNA sequences, which are going to be separated by density gradient centrifugation, and it works in the principle of polymorphism. Polymorphism will be inheritable from the parents to progeny, and the kind of polymorphism is the same in the entire body of an individual. Once go through with this now. So there, to be precise, we are giving just the glance of the molecular basis of inheritance. Let me move ahead in the concept biotechnology, principles and the processes. Since now we have completed 2 chapters. One is genetics, which is principles of inheritance and variation. Now we have completed molecular basis of inheritance. Let me enter into biotechnology part. So this is going to be biotechnology. Principles and processes. Same here also, ma'am. In this particular chapter, the most requested topic is about the cloning vectors. Let me enter into that. Before that, let me see some glimpse related to that. Tomorrow, possibly, if time permits today, if not tomorrow, we will cover the cloning vectors concept, ma'am. But directly, if I enter into the cloning vector, it may create the confusion. Let me complete the introductory part first. So below to this heading, ma'am, biotechnology principles and the processes. First 2 principles they had given. One is genetic engineering, another one is bioprocess engineering. What is genetic engineering is all about? It is going to be alteration of the genetic material, changing the sequence of the DNA by either adding the gene or deleting the gene is going to be called as genetic engineering part. And the changed DNA we are going to transfer into the host, whatever the host organism. Sometimes it may be bacteria, sometimes it may be eukaryotic cell also, whether it is a plant cell or animal cell, and we are growing the host in a sterile conditions by providing the suitable conditions for the host to grow, and surrounding to the host we are providing the aseptic conditions or sterile conditions. That is going to be called as bioprocess engineering. Then last before here there is one question they have arised in this NEET examination. What is the fate of alien piece of DNA? What is the fate of alien piece of DNA? To best of my knowledge, it was asked in 24 or 25. So the fate of alien piece of DNA means if you directly transfer a piece of DNA into the host, is it going to multiply? Is it going to multiply or not? That is the question. So, it based on the situation. Any alien piece of DNA, if you directly transfer into the host, it won't get multiplied. There is no doubt in that. Directly if you are transferred into the host body, it won't get multiplied. But if it has to be multiplied, it should be, the alien piece of DNA should be integrated. Alien piece of DNA should be integrated into genome of the host. Integrated into genome of the host. Sir, what happens if it is integrated into genome of the host? Because this genome contains the chromosomes. Genome contains what ma? Chromosomes. The chromosome contains what ma? ORI. What is ORI? Origin of replication. So, overall therefore what we can say, any piece of DNA, if it is linked with the ORI, it will be multiplied. It will be multiplied. Directly if you transfer in a random locations, it won't get multiplied. If a alien piece of DNA is transferred into the genome or integrated into the genome of the sorry for the interruption, internet issue. Sir, see, we are going to discuss here the construction of the first RDNA. First RDNA was constructed in the year 1972 by two scientists. One is Stanley Cohen and Herbert Boyer. Stanley Cohen and Herbert Boyer are the two scientists which are involved in construction of the first RDNA. The main points, 3 points are there, you have to remember. I am going to touch those 3. First thing, they have taken the gene of interest, that is gene resistance to antibiotic resistance gene. Antibiotic resistance gene they have taken, and they want to combine it with the vector. They have used the vector as a plasmid. This plasmid was taken from the Salmonella typhimurium. Salmonella typhimurium. From that they have taken this particular vector plasmid, and both has cut with the same restriction enzyme, and combined with the help of the enzyme ligase, molecular glue. This is molecular scissor, this is molecular glue, that leads to construction of the RDNA. This RDNA will be transferred into the host. The host, what they have used here, E. coli bacteria. Most of the cases, host was E. coli bacteria. So, it was entered into the host. This E. coli bacteria, if we provide the suitable conditions, aseptic conditions, in vitro conditions properly, it will be multiplied. How many times it is going to multiply? That many times the plasmid, that which is containing our gene of interest, will also be multiplied. So, this is the construction of the first RDNA. Mainly 3 questions will come. First, what is the source of this plasmid? The source of the plasmid was the bacteria, that is the Salmonella typhi. It was also taken from another bacteria, which is Salmonella species. Next, both are combined, produced the RDNA, transferred into the host. What is that host, E. coli. To confuse you, they will change these names, Remember, host is the E. coli, plasmid was taken from the Salmonella. And this reconstruction of this RDNA is possible with the discovery of the enzymes which are called as restriction endonucleases. Without this, the construction of RDNA is not at all possible, because it is going to cut the DNA. Next, here the thing we have to extract is what are the tools required for this RDNA technology. First one is restriction enzymes, next one is a ligase enzyme, third one is in the host DNA polymerase enzyme for the amplification process. Next, it requires the vectors and also the host. So, these are the tools of the RDNA technology. Restriction enzyme to cut the DNA, ligase enzyme to join it, to multiply the gene of interest, DNA polymerase, which is present in the host organism. To carry the genes into the host, we need the vector, and host itself is the main character here. So, these are the tools of the RDNA technology. Before going to discuss about the these vectors, cloning vectors, let me talk about the restriction endonucleases or restriction enzymes first. Ma, this restriction enzymes first time discovered in the year 1963. So, scientists had identified the bacteria will be attacked by viruses. Do you remember the name? The viruses which are going to affect this bacteria are the bacteriophages. This bacteriophage is very intelligent fellow. It is attacking the bacteria and injecting the genetic material of the virus into the host. This bacteria is an innocent fellow. See, this bacteria contains the plasmid and it is having its own DNA. It is having its own DNA. We call it as a naked DNA. Let me not complicate this. Keep the plasmid aside. Now, so viruses which are attacking the bacteria, bacteriophages, attacks the bacteria, inject their genetic material which is DNA into this bacteria. Now, bacteria is an innocent fellow. Bacteria feels that the genetic material of the virus as bacteria's own. This genetic material of the virus uses the bacteria to multiply itself. So, to restrict the growth of this viral genetic material, what the bacteria has produced? Bacteria is releasing two enzymes. One enzyme is called methylase. Name is not there in the textbook. One enzyme is methylase. What this methylase do? It will add the methyl groups. It will add the methyl groups to the DNA of the bacteria. DNA of the bacteria. Next, second enzyme is restriction enzyme. What this restriction enzyme going to do? It is going to cut the DNA. Whose DNA has to be cut here? The enzyme was released by bacteria. So, this enzyme work in the favor of the bacteria so that it is going to cut the genetic material of the bacteriophage. How come? How the restriction enzyme able to know this is bacterial, that is viral? Because DNA is made up of adenine, guanine, thymine and cytosine. Both are same. So, how to identify? Wherever the methyl groups are added at that DNA, this restriction enzyme not going to touch. So that without methyl groups the DNA is nothing but the viral genetic material. So, understand the logic here. Methylase is going to add the methyl groups to the DNA of the bacteria. It will works as a protection for the bacterial DNA, and later on restriction enzyme is released. That restriction enzyme is going to cut the genetic material of the virus, so that the growth of the virus within the bacteria was restricted. Such enzymes are called as restriction enzymes. But these restriction enzymes belongs to the class called nuclease. Nucleases going to cut the nucleic acids. It is of two types, all of us know very well. One is the restriction exonucleases, another one is the restriction endonucleases. These exonucleases are going to remove the DNA nucleotides at the ends. From the ends, these are going to remove the nucleotides. Whereas endonucleases methodology is very complicated. They are going to cut the DNA at the middle of this DNA sequences. It is not going to remove the nucleotides at the end. So, in this first identified restriction enzyme, first restriction enzyme is HIND2. So, HIND2 is the enzyme first discovered restriction enzyme in the year 1963. Later on, it has taken 5 years for them to identify the working mode of this HIND2 enzyme. This HIND2 enzyme going to cut the DNA not in the random places. It is going to cut the DNA in some specific regions which is having 6 base pairs. So, it is going to cut the DNA by identify the specific sequence containing 6 base pairs. That is going to be called as recognition sequence. That is going to be called as what? Recognition sequence. The sequence which is going to have 6 base pairs. So, HIND2 enzyme, its methodology of functioning was identified after 5 years. It is not going to cut at the random places. It is going to cut the DNA by identifying a sequence of 6 base pairs, that is called as recognition sequence. After this, now the number is important. 900 different restriction enzymes was isolated. Different restriction enzymes was isolated from 230 different strains of bacteria. One thing you have to remember, this we have extracted the restriction enzymes from the prokaryotes. So, 30 different types of bacteria from there we have isolated. Until now, the number will be updated, 900 different, as per NCERT it is 900. Next. These going to, what is the methodology of function of the restriction endonucleases? Endonucleases methodology, first it will inspect the length of the DNA. Once you add the endonuclease onto a DNA, directly it won't go and cut. There are some steps it will follow. One is going to inspect the length of the entire DNA. After inspecting the length of the DNA, it is going to recognize specific sequences, recognize specific sequences. Those sequences are called as recognition sequences. Such sequences are generally palindromic sequences. Palindromic sequences. So what is mean by this palindromic sequence? It will read on same on both strands when the orientation of reading is kept same. For example, G, A, T, T, C, EQR1, 5 prime to 3 prime. Opposite strand also G, A, T, T, C. This is 5 prime to 3 prime. DNA antipolarity. Some people will, argue. Sir, both strands it has to read the same. No, here it is a GAA, TTC. No. The condition is orientation of reading is kept same. Direction of reading. So here 5 prime to 3 prime you are reading. Opposite strand also you have to read in the same way. That is 5 prime to 3 prime GAA TTC. Here also 5 prime to 3 prime GAA TTC. If you read 3 to 5 CTT AAG. Here also CTT AAG. Such sequences are going to be called as palindromic nucleotide sequences. Our restriction enzyme directly it won't going to cut. It will first inspect the length of the DNA. After that recognize the specific DNA sequences. Later on it is going to cut the DNA. Later on it will bind it. Bind. After binding it is going to cut the recognition sequence. Where? It is not going to cut the recognition sequence in the middle. Important point, ma'am. It is not going to cut the recognition sequence in the middle. It is going to cut the DNA slightly away from the middle. Slightly away from the middle, but between same two bases of the opposite strands. Here between G and A, here also between G and A. This leads to formation of cohesive sequences. Sticky ends. 5 prime G, it was separated. 3 prime C, T, T, A, A. Plus here A, T, T, C, G. So it was separated. 3 prime, this is 5 prime. Separated like this. How many hydrogen bonds are broken down? Here 2, 4, 6, 8. Total 8 hydrogen bonds are broken down here. GAA, TTC between G and A, here also G and A it is going to cut. These are called as sticky ends. These are going to be called as sticky ends. Why they are sticky ends? They are ready to attach. If the counterpart was, if this come closer, it will attach again like that. So this is going to be joined by the enzyme DNA ligase. So this is all about restriction endonucleases. Inspecting the length, identifying the recognition sequence, later on binding to that sequence, then cutting the recognition sequence slightly away from the middle, same two bases of opposite strand. What is the bond going to broken down here? Phosphodiester bond. How many phosphodiester bonds are broken here? Here 1, 2. 2 phosphodiester bonds are broken. How many hydrogen bonds are broken here? 1, 2, 3, 4, 2 to each. So that is 8 hydrogen bonds are broken down in this particular scenario. That is the thing. Next. After this, let me come back related to restriction enzyme. It was done. What is about ligase enzyme? Ligase enzyme is a molecular glue. It is going to combine the DNA sequences. Join the DNA sequences. Next enzyme is DNA polymerase enzyme. And the most awaited topic we have to go through is the vectors. Vectors, cloning vectors. Still 15 minutes is there, ma. Let me try our best to complete this. Cloning vectors. So as per NCERT I will go maximum possibly. See, these cloning vectors which are used in the RDNA technology are of namely two types. One is bacteriophages One is bacteriophages, which is having high copy number. Another one is plasmids. Both can be used as vectors. In our story of discussion, mainly we are going to focus on what? Plasmids. See, these plasmids are genetically engineered. We have modified them to carry our own concept, genes of interest. These plasmids, for example, constructed plasmid, one is a PBr322. PBr322. This PBr322 is the plasmid which is under discussion. If you observe the diagram of the PBr322, it is having like this. In this left side, we are going to have resistance gene for the ampicillin. This is ampicillin resistance gene. Here is going to be the tetrasilin resistance gene. Sorry, it is ampicillin resistance and it is tetrasilin resistance. See, first character the cloning vector should have is ORI. What is ORI? Origin of replication. We can find it here, ORI. So, it provides the origin of replication. If you want to have more copies of our gene of interest, it should be linked to a plasmid whose ORI can support more copy number. This ORI is going to control the copy number. Remember this, copy number will be controlled by ORI. Second one is what can you say? Selectable markers. Selectable markers. Who can act as selectable markers? Antibiotic resistance genes are acting as a selectable markers. I am repeating, antibiotic resistance gene will act as selectable marker. In the PBr322, two selectable markers are there. One is ampicillin resistance gene, another one is tetrasilin resistance genes. These are going to use for identification of transferments and the non-transferments. Transferments will be promoted and the non-transferments will be eliminated. So, to identify and eliminate the non-transferments and selectively permitting the growth of the transferments, who is useful? Selectable markers. The selectable markers generally are antibiotic resistance genes. So, for example, ampicillin, tetrasilin, kanamycin, chloramphenicol, different types are there. General E. coli cells, key point this is, normal E. coli cells do not have resistance to antibiotics, do not have resistance to commonly used antibiotics. Next, the third character here we have to understand is cloning sites. Cloning sites. Cloning sites generally how many are required? Generally one or few, preferably one. If more number of cloning sites are there, the plasmid will be broken down into several fragments. The process of RDNA technology will be complicated. In this we can see different cloning sites are there. Before going to say that, here there is one sequence called as ROP, proteins of replication. It is going to code for the proteins which are going to help for the replication process. Now, in this, first let me start from here. This is the BAM-H1. If you use the BAM-H1 enzyme, it is going to cut here. BAM-H1 enzyme do not have the cloning site anywhere in this. So, I told you one cloning site is a preferable one for one restriction enzyme. Another enzyme restriction site is SAL1. For SAL1 only one place is there. Sir, you only said only one cloning site is required. For one enzyme, one cloning site. If I use BAM-H1, it is going to cut at this place only. It is not going to get somewhere else, because this is the place where its recognition sequence is there. This is the endonuclease enzyme, SAL1. Next, here PVU2. PVU2. Here is going to be PST1. Here PVU1. Next, here 3 are there. Here 3 are there. One is EcoR1. Another one is CLA1. Here is going to be the HIND3. First discovered restriction enzyme was HIND2. This is HIND3. Total how many restriction sites are there here? 1, 2, 3, 4, 5, 6, 7, 8. In them, how many are within the selectable markers? 4. How many are out of the selectable markers? 4. How many are there within tetrasilin? 1, 2. How many are within ampicillin? 1, 2. If I use BAM-H1, it is going to cut the tetrasilin. If I use a PVU2, it is going to cut the ROP. If I want to inactivate a tetrasilin, what are the options I am having? PVU1 and PST1. Let we enter into the procedure. First, suppose I have taken a test tube. Cloning process I was going through here. Suppose I have taken a test tube. In this, I have added 2 vectors, 2 plasmids I have added. Into this, I have added BAM-H1. BAM-H1 I have, remember, if I use BAM-H1, it is going to cut the tetrasilin. And here, I am adding my gene of interest. To combine this, along with the BAM-H1, I have added the ligase enzyme. Ligase enzyme is added. So that what I have expect, BAM-H1 going to cut here. At this place, my gene of interest came and was attached with the help of this ligase enzyme. This didn't accept the alien DNA and it was resealed by the ligase enzyme. So that this is going to be the recombinant DNA, this is going to be the non-recombinant DNA. Which I want the recombinant DNA, but it is not able to identify here, DNA not visible. So for the selection, what to do? We are directly transferring it into the host. The process of transferring DNA into the host, we are calling it as what? Transformation. In this story also, let we talk about the host. The host here is going to be again E. coli bacteria. In the E. coli bacteria, for example, I have taken 2, many will be there. For our easy understanding, I have taken 3 here. So these plasmids I have transferred into the host. The process of transferring the DNA into the host is called transformation. First bacteria accepted the recombinant DNA. Second bacteria accepted the non-recombinant DNA. Suppose third bacteria did not accepted anything. Now these 2 are called as transferments. These 2 are called as what? Transferments. This is going to be called as non-transferment. Now I want to catch my transferment. I want to eliminate the non-transferment. Who will help me to find this? The selectable marker will help us to identify identification of transferments and elimination of the non-transferments. Who will do this? Selectable marker. So what I am doing, I am transferring this into the ampicillin plate. A plate containing the ampicillin. 3 types of bacteria I have added here. See which bacteria can grow here? The transferment bacteria will grow. Both are transferment. Which is non-transferment, it cannot grow. Why non-transferment is not able to grow? Because the non-transferment is not having the plasmid which is going to provide the resistance for the ampicillin antibiotic. So the non-transferment was unable to grow. Here at this the plate which is carrying the ampicillin, the non-transferment is eliminated and we are having only 2 options now. Both are transferments. One is transferment and recombinant, another one is transferment and non-recombinant. How to identify? We are transferring it into the another culture plate which is having the tetracycline antibiotic. In this the movement I have added, guess what? One is able to grow, another one is not able to grow. Guess who is unable to grow? The recombinant was unable to grow. The transferment and non-recombinant was able to grow. Why? Because the movement I have added BAM-H1, it is going to cut the tetracycline. So the recombinant DNA lost the resistance to tetracycline. This is called insertional inactivation. Insertion of one gene going to inactivate the another gene. That is going to be called insertional inactivation. So the recombinant DNA, the tetracycline resistance gene was inactivated, but still ampicillin resistance was activated. This ampicillin resistance helped the non-recombinants and recombinants to grow. But here in the presence of tetracycline, transferments and recombinants cannot able to grow because in the recombinants tetrasilin gene was inactivated, but the non-recombinants will grow both in ampicillin and also tetrasilin. Overall bottom line of the story, what we can say here, ampicillin help us to identify transferment and non-transferment, tetrasilin help us to identify recombinant and non-recombinant. The trick here to remember who are focusing on this NEET examination, this is the area more questions will be arised. The antibiotic which got inactivated, that will help in the identification of recombinants and non-recombinants. The antibiotic which is not inactivated, that will help in the identification of transferments and non-transferments. So, we will end up here. Tomorrow I will explain this single plate method of discussion. So, entire story what we can understand, this is the cloning RDNA technology method. So, simple revision, we have taken the PBR 322 into the test tube. The two vectors we are using BAM-H1. The moment I have used the BAM-H1, tetrasilin resistance gene got inactivated, so that it will lose the resistance to tetrasilin, whom recombinant, because at the place of tetrasilin who got added my alien DNA or gene of interest. What do you call this procedure? This is called as insertional inactivation. Insertion of one gene causes the inactivation of another gene. So, this recombinant DNA having the ampicillin resistance, but tetrasilin resistance was gone, but non-recombinant having resistance to both ampicillin and also tetrasilin. That is why we have, when we transferred into that one, the bacteria which got accepted the plasmids, those are called transferments, which is not accepted, that is called non-transferment. On the ampicillin plate, non-transferments cannot grow, but the transferments was able to grow, because both the transferments having the plasmid, both the plasmids are having the ampicillin resistance, it can grow. But onto the tetrasilin plate, when we transfer the transferments, non-recombinants able to grow, recombinants unable to grow. Why? Because non-recombinants having the resistance to tetrasilin, recombinants is not having the resistance to tetrasilin. I am repeating my again here, observe the selectable marker which got inactivated in this procedure, that is going to help the identification of transferment, non-transferment or recombinant, non-recombinant. The marker which got inactivated, that will help in the identification of recombinant and non-recombinant, which is not getting inactivated, that help us to identify transferment and non-transferment. It is a double plate method, which is a cumbersome procedure, heavy procedure. Tomorrow we will discuss about the single plate method, which is basically almost same. We are going to get a last step, a little bit changes there. Let we discuss it in the tomorrow's class. Who are really interested to understand this, once you take a screenshot about this one and compare it with the textbook lines, okay, it will be clear it off. So, happy to see you again in the tomorrow's class.
Good morning all of you. Amma. Today I am going to discuss about remaining part of the chemical bonding, that is main topic, very important topic, that is called hybridization concept. So every year they are asking 2 questions from the hybridization concept. So that's what we should focus on, hybridization concept. So before going to this hybridization, how to do the questions, how to solve the question, we should know the first what is hybridization, then based on the hybridization how to decide the shape, how to decide the bond pairs, how to decide the lone pairs, what is the shape, bond angle, then different questions are there. That questions you want to do, compulsory you should know the one chart. That chart I will tell you, then remember that first. Right. First one, I am taking the one molecule. The molecule representation is general representation A, B, E type. What is A, B, E? A stands for central atom. B stands for surrounding atom. Surrounding atom, that is called bond pairs. Surrounding atoms is called bond pairs. E is called as, this is also surrounding atom, this is called lone pairs. First we should know. So bond pairs to lone pairs. Before going to this bond pair, lone pair, we should know that. First, how to find number hybridization. Number of hybrid orbitals you have to find first. Number of hybrid orbital. If you know the number of hybrid orbital, you will get the hybridization. How to find the number of hybrid orbital? If any molecule will take number of bond pairs plus number of lone pairs, you will get number of hybrid orbital. Number of bond pairs means most of the sigma bonds, maximum sigma bonds only. That means here, why you are saying sigma bonds? In the compound having the pi bond also will be there, sir. Why you will not consider pi bond? Because one of the rule for the hybridization, hybrid orbitals are involved in the formation of sigma bond but not pi bond. That's what we will not include on the pi bonds in hybridization. Just we will include sigma bond. That sigma bond is called as number of bond pairs. Again, some other heteroatoms also having the lone pair. Lone pair means which are not involving in the bonding. That means those are called lone pair. Lone pairs plus bond pairs is equal to number of hybrid orbital. If you know the number of hybrid orbital, you will get the hybridization. Number of hybrid orbitals 2, 3, 4, 5, 6, 7. So number of hybrid orbitals 2, that is called sp hybridization. That means one s orbital, one p orbital, that is called sp. That means hybrid orbital 2. Number of hybrid orbital 2 is there, that is called sp hybridization. 3 are there, that is called sp2. 4 sp3, that means one s orbital, 3 p orbital. 5, that is called sp3d. 6 sp3d2. 7 sp3d3. Most of the sp3d3 is not there in our chemical bonding chapter. Mainly these 5 are there. Total overall hybridization classification, total 6 types: sp, sp2, sp3, sp3d, sp3d2, sp3d3, based on number of hybrid orbital. How to find number of hybrid orbital? By using this one. So in this number of hybrid orbital, sp 2, 3, 4, 5, 6, 7, based on that I told hybridization. In this, one s orbital, one p orbital. Actually, p subshell having the means p orbital having the 3 subshell, those are called px, py, pz. This is a very important question. Which orbital, which p orbital is involving in sp? That is what? Last which one is there? Pz. That pz orbital involving in sp. Which of the following combination is correct for sp? One of the time they ask the question. Not only this one, in this also. Observe here. Here which combination? S compulsory. First one is 2 p orbital means one is pz, other one is py. Here sp3 means S compulsory, pz first, next px, next py. So in these 3, pz is main because last terminal orbital means it is involving in the formation of sigma bond. Why you are saying sigma bond? In between two atoms, first bond is sigma bond. Without sigma bond, there is no pi bond. That's why compulsory first bond forms sigma bond. Sigma bond is formed by last pz orbital, terminal orbital. After formation of sigma bond, remaining any orbitals are there, those orbitals are involving in the formation of pi bond. Right. Here, s orbital, that means 3p orbital, that is called px, py, pz, one s orbital, 3p orbital, one d orbital. D orbitals are totally splitting into 5 d orbitals. What are those 5? dxy, dyz, dzx, dx square minus y square, dz square. These 3 orbitals are presenting in between the axis. This will get it in coordination compounds. These two are present in along the axis. Along the axis. So in this along the axis, these two in this 5, which one is involving in sp3 dihybridization? Very, very important. One of the time they ask the question, this one only now. So one s orbital compulsory, 3p orbital, on that d orbital, which one is the last terminal is there? That is called dz square, that is called dg square, that means dz square. Next, sp3d2, s orbital compulsory, 3p orbital, 2d orbital, one is compulsory dz square, other one is dz square after what is there? Dx square minus y square. This is the combination is involving in hybridization of sp, sp2, sp3, sp3d, sp3d2 and sp3d3. Here sp, 3p, 3z square, dz square, dx square minus y square. Remaining 3 are there, dxy, dyz, dzx. In these 3, which one is involved? On that 3, any one is involved because these are having the same orientation. These 3 are in between the axis, either dxy or dyz or dzx. Any one you can take, any one. This is the combination. So one of the time they ask the question is this one and this one, the NEET exam. Which combination, which of the following combination is correct for the sp3d and sp3d2? This combination. So based on this, I am going to say the finding of hybridization. This is the hybridization finding. Based on this, how to say what is the shape, bond angle, how to identify bond pairs, lone pairs, then observe clearly. Right. Any molecule we will take, representation is A, B, E. What is A? Central atom. What is B? Bond pairs. What is E? Lone pair. These two are called surrounding atoms. First one, type. AB2 type. That means central atom is A, surrounding atoms are B. Mean 2 B's. That means that meaning of that those 2 bond pairs, lone pairs are 0. 2 bond pair mean that is called bond pair plus lone pair is equal to number of hybrid orbital. That means number of hybrid orbital. Number of hybrid orbital how many there? 2, because these are 2. Next one, bond pairs. Number of bond pair. Next one, lone pair. Bond pairs how many there? 2. Lone pairs how many there? No lone pair, that is what 0. 2 bond pairs to 2 lone pairs, so hybridization is number of hybrid orbital 2 means which hybridization? sp. sp. So what is the shape? Shape is called linear. Linear shape is there, means that bond angle is 180 degrees. Next one, AB3, that means number of bond pairs are 3, lone pairs are 0, 3, that is called sp2 hybridization. Bond pairs are 3, except central atom remaining all called bond pair. Lone pairs are 0. 3 bond pairs to 0 lone pairs, sp2 hybridization, that is called trigonal planar. These shapes are very, very important. So many times they are asking the match the following. Last NEET also they asked the match the following. So this bond angle is 120 degrees. Next one, A, B to E. Observe here. Total 3 only now. Bond pairs 2, lone pair is 1. 2 plus 1, 3. That is called sp2 only. But how many bond pair? 2 are the bond pair. E is called lone pair, 1 lone pair. 2 bond pair, 1 lone pair. Adapt actually. Bond pair and lone pair. Bond pair electron, lone pair electron. What happen? Electron, electron, what will happen? Repulsion. This can be explained by This can be explained by Vesper theory, VSEPR theory. Valency shell electron pair repulsion theory. Because of bond pair lone pair repulsion, shape and bond angle will be disturbed, means destroyed, changed. Changed to what? Actual shape is trigonal planar because sp2. This trigonal planar changes to V shape, also called bent shape, also called angular shape. Bond angle is less than 120 degrees. Sometime greater than also you will get it based on the situation. Later you will get it to wait. So less than 120 you remember now here. Next one. Next one is AB4. AB4 means total number of bond pairs only 4. That is called sp3. Lone pairs are not there. That means 4 bond pairs, 0 lone pair. Shape is called tetrahedral shape. Bond angle is 109 degree 28 minutes. Some textbooks 109 degree 5 minutes. That is also correct. 109 degree 28 minutes. Again AB3E. Next one AB2E2. Here also 4 because 3 plus 1 bond pair to lone pair, but this also same hybridization. What is the shape? Means hybridization sp3 only now. Here 3 bond pairs to 1 lone pair. Here 2 bond pairs to 2 lone pairs. But hybridization is same. Hybridization shape means what you will expect now geometry tetrahedral. But tetrahedral geometry changes to some other shape. Why? Because of bond pair lone pair repulsion. This bond pair lone pair repulsion is explained by Vesper theory. Based on this, which one is more repulsion? Lone pair, very important. Lone pair, bond pair, again bond pair. These are the repulsions order. Which concept? Vesper theory concept. Lone pair is more repulsion than lone pair, bond pair. Less repulsion this one, more repulsion this one. Because of repulsion, shape and bond angle will be destroyed or changed. This shape is trigonal pyramidal. In case of ammonia, this bond angle is 107 degree. If you take ammonia, that is 107 degree. That means less than 109 degree. If you take pyramidal, if you take ammonia is the molecule. This is what? sp3 only now. Here 2 bond pairs to 2 lone pairs. Here also same repulsion. The shape actual geometry is tetrahedral. Tetrahedral geometry changes to shape is V shape or bent shape or angular shape. This one is 104 degree 5 minutes. That means if you will take the example is water, this is the exact bond angle. That means what happened? Bond angle will also decreases. That means less than 109 degree 28 minutes. That's why I told less than. Sometime increases. One of the example is there. Wait. This is called sp3. Next one AB5. AB4E, AB3E2, AB2E3. This total number of hybridal 5 only now. 5 means only 5, that is called sp3d. Here also 4 plus 1 5 sp3d, 3 plus 2 5, 3 plus 2 5 sp3d, 2 plus 3 5. Bond pair, lone pair. Total this is sp3 hybridization. So here bond pairs 5, lone pairs 0. 4 bond pairs, 1 lone pair. 4 bond pairs, 1 lone pair. Here 3 bond pairs, 2 lone pairs. Here 2 bond pairs, 3 lone pairs. This is called regular shape because there is no repulsion, less repulsion. The shape is called TBP, trigonal bipyramidal. Bond angle is 2 bond angles are there, 90 and 120. Here 4 bond pairs, 1 lone pair. That means here also bond pair, lone pair repulsion will be there. Shape will be destroyed. That is called seesaw. That is called distorted trigonal bipyramidal. Also called seesaw. 3 bond pairs to 2 lone pairs. That is called T shape. 2 bond pairs to 3 lone pairs. That is called linear shape. Actually, linear shape means your bond angle how much? 90, 120. 90 and 120 means less than 90 and less than 120. Based on this, Actually what I told, sometimes it will be more, sometimes will be less. Here bond angle, linear means straight chain means actual bond angle is how much here? 180 degrees in case of I3 minus example. This is the information about sp3d. Next, AB6, AB5E, AB4 E2, that means 6, that is called sp3 d2, same sp3 d2, 5 plus 1 4 plus 2, that means 6 0 5 1 4 2, that means what? 4 2 bond pair to lone pair, bond pair to lone pair, bond pair to lone pair. The shape is 6 5 6 0, that is called what? Octahedral. Octahedral also called square bipyramidal, sometime like this they are given one of the time. Octahedral also called as square bipyramidal. 5 1, this is called square pyramidal. This is called square bipyramidal, this is called square pyramidal. Because of one lone pair, one pyramidal is lost. That's why you will get square pyramidal. This is square bipyramidal, also called octahedral. This is called square planar. Square planar. Last and final one, AB7, one of the example. AB7 means 7, that is called sp3d3, 7 bond pairs, 0 lone pairs. This is that much explanation not there, only this one only now. 7 0, that is called as PBP. What is PBP? Pentagonal bipyramidal. Pentagonal bipyramidal. Here bond angle is 70 and 90 degrees. Here bond angle is only 90 degrees. Octahedral. All bonds are equal in this. Here are different bond angles are there. One is 90 and one 120. I will explain using this concept. I will explain different questions. Observe clearly. This is called hybridization concept flow chart. If you know this chart, compulsory you will get the 2 4 marks questions. Very important. Observe here. Based on this, some example they will give you how to find out hybridization, shape, bond pairs, lone pairs and bond angle also. I will give the one trick. What the trick? Number of hybrid orbital. First you have to know the number of hybrid orbital. If you know the number of hybrid orbital, you will get the hybridization. Yes, correct only. So number of hybrid orbital you have to know that first. How to calculate? Number of hybrid orbital is equal to, how to find? Central atom group number plus number of hydrogens are halogen atoms, number of hydrogen atoms are halogen atoms, minus charge of cation, plus cation is there, you have to do the minus, because why do you have to do the minus means cation means loss of electron, that's why it is called getting negative charge. In case of anion is there, charge of anion means gaining of electron, that's why it is getting positive charge. Overall by 2 you will get number of hybrid orbital. If you know the number of hybrid orbital, you will get the hybridization. Observe here, one example I will give you. One of the example I am giving now. Before going to the example, you should know the group number, central atom group number. Overall I am giving to you. First one, lithium, sodium, potassium, rubidium, cesium. These are called first A group. Next one, beryllium, magnesium, calcium, strontium, barium, radium. Remaining example we don't want to know. This is the second A group. Groups you should know first. Boron, aluminium, gallium, indium, thallium. Indium, thallium, okay. Indium and thallium. Third A. Third A also called 13th group. Third A group also called 13th group. New numbering is 1 to 18. Old numbering is A and B. So S and P blocks are A category. D block is called B category. We don't want now. Now which numbering you have to consider? In this question we have to do now. Which number you have to consider means old numbering. Old number means AB. New numbering don't want. 18 up to 1 to number 1 to 18, that is we don't want now. This 3A also called 13th group. 4th A also called 4A, that is called carbon family. Carbon, silicon, germanium, tin, lead. 5th group, nitrogen, phosphorus, arsenic, antimony, bismuth. Still there, we don't want remaining. 6th A, oxygen family. Oxygen, sulfur, selenium, tellurium, polonium. 7th A, fluorine, halogens. Fluorine, chlorine, bromine, iodine, acetylene. We don't want remaining. This is actually 0, but in this hybridization concept you have to consider this also called 8th. That means what? Helium, neon, argon, krypton, xenon, radon. Mainly most of the questions they will ask from xenon, that is the 8th group. As per old numbering actually 0, now you have to consider 8th A, these are the groups. If you know the groups, automatically get the questions, answers. Observe, for example, I am giving XeO F2 or F3. Okay, simply XeO3 I am giving you one of the example. XeO3, xenon trioxide. What is hybridization? First you have to find number of hybrid orbital. Number of orbital means central atom group number. Which one is central atom? This one I know. Central atom group number is 8 plus number of hydrogens are halogens. Hydrogens and halogens only. Except central atom, remaining atoms you have to consider. Oxygens are there, but they are hydrogens or halogen. That's why it is not considered. That is 0. This is first you have to identify. This is neutral molecular, charged molecular. This is neutral molecule. Neutral molecule means there is no charge. That means cation. This is not a cation. This is not a anion. That you don't want. Overall by 2. Then what I am getting? 4. 8 by 2. 4. What is 4? 4 is called number of hybrid orbital. Number of hybrid orbital 4 means before I told which hybridization? sp3. After that sp3 decide bond pairs to lone pairs. One of the time they ask the question bond pair, lone pair also. Except central atom, very important, observe clearly. Except central atom, remaining any atoms are there, those are called bond pairs. How many bond pairs are there? 3. That means 3 bond pairs plus total must be 4 because sp3 hybridization. Already 3 completed bond pairs. Remaining 1 is called lone pair. That means 3 bond pairs to 1 lone pair. This is only main. Sir, how we decide, sir? Once again observe bond pairs. Except central atom, remaining any other atoms are there, those are called bond pairs. How many there? Oxygen 3, those are called 3 bond pairs. 3 bond pair plus 1 lone pair. So 3 bond pair, 1 lone pair. Hybridization is sp3. What is the shape? In this table I given, the shape is called pyramidal or trigonal pyramidal. Pyramidal means bond angle, how much I told? 107 degree. That's all. Like this you have to do. Some other example. XeF2. So 8 group number. 8 plus halogens are there. Hydrogens are halogen. Halogen how many there? 2. 8 plus 2 by 2 because neutral atom, no charge. How much here? 5. 5 means sp3d. sp3d. How many bond pairs are there except central atom? Except central atom bond pairs, how many fluorines are there? 2. That means 2 bond pairs. How many lone pairs? 3 lone pairs. Why sir 3 lone pairs? How to know sir? 2 lone bond pairs already there. Total must be 5. Total must be 5 means how many lone pairs required? 3 lone pair. 2 plus 3, 5. 2 bond pair to 3 lone pair, which hybridization? sp3d. sp3d. 2 bond pairs to 3 lone pair. What is the shape? Linear shape. That means linear. Linear shape means what is the bond angle? 180 degrees. Like this you have to find. One neutral molecule, one charged molecule I will give you. NH4 plus, otherwise SF6, otherwise IF7, otherwise PCl5. Observe here, these are neutral molecules, this is charged molecule, other one is CO3 2 minus. Observe. Central atom is group number 5 because already given. Number of hydrogens are halogens 4. But the charge is positive charge. How much charge is plus 1? That means minus 1 by 2. 5 plus 4, 9. 9 minus 1, 8. 8 by 2, that is 4. 4 means which hybridization? sp3. sp3 means how many bond pairs? How many bond pairs? Except this. 4 bond pairs. What about lone pair? 0 lone pair. How to know? Total must be 4. 4 bond pairs, so 0 lone pairs. So 4 bond pair, 0 lone pair means what is the shape? Tetrahedral. Bond angle is 109 degree, 28 minutes. This one observe here, this one. That is okay easily. Central atom group number 4, carbon. Number of hydrogens are halogen. Hydrogens are not there, halogens are not there. No, don't need to consider. Plus charge is there, anion, that means plus 2 by 2. How much? 6 by 2, that is called 3. 3 means sp2. How many bond pairs? Carbon is central atom, except this. 3 bond pairs are there. 3 bond pairs are there. Plus 3 bond pairs are there. How many lone pairs are there? So lone pairs are 0. That is called trigonal planar. Bond angle is 120 degrees. Like that, you have to solve this question. SF6. Central atom group number 6. Oxygen group number. Oxygen sulfur, this is group number. Oxygen sulfur family. 6. 6 plus 6. 12. 12 by 2. Again 6. Like that you have to find. Iodine 7. Halogens are 7. 7 plus 7 by 2. Here phosphorus. Phosphorus group number 5. 5 plus 5. Because halogens are 5. 5 plus 5 by 2. Like that we have to find any one of the example. Like this you have to solve the questions related to hybridization concept. Very, very, very important. So many times they asked. Now this time also, next incoming NEET also they will ask the compulsory one, match the following question. One of the example I am going to give related to hybridization. One of the year they ask the question. Observe here. Very, very important. One of the example is ClF3. What is the hybridization of central atom? Central atom is chlorine 7 group number plus surrounding by 3 halogen. Number of hydrogens are halogen. Halogens are 3 by 2 because neutral atom. Total 5. 7 plus 3, 10, 10 by 2, 5. 5 means what? Which hybridization? sp3d. Okay, very good. sp3d means how many bond pairs here? 3 bond pairs. Except central atom, 3 bond pairs. 2 lone pairs. What is the shape? Shape is T shape. Observe clearly. Right? That is okay. Now T shape you have to draw first. That means this is actual geometry is trigonal bipyramidal because sp3d. Observe here, trigonal bipyramidal, observe clearly. That means example PCl5 I will take. This is PCl5 is trigonal bipyramidal. Central atom phosphorus. How to know? 5 plus 5 by 2. 5 plus 5 by 2. Again 5. 5 means sp3d. How many bond pairs? 5 bond pairs. 0 lone pair. That means trigonal bipyramidal shape. Trigonal bipyramidal shape, observe clearly. Observe here. That means central atom phosphorus, these 3 chlorines are in one plane. This is called horizontal plane. That means total number of atoms in one plane is phosphorus and 3 chlorine, total 4 atoms are in one plane. This plane is called as equatorial plane. Very, very important. Equatorial plane. This plane, one is above and other one is below. One CL is below, other one is above the plane, below the plane. This is called vertical plane. Vertical plane is called axial plane. Axial plane. That's why 2 different planes are there. That's why these bond angles are 2 bond angles are different. This equatorial bond angle, your bond angle is 120. Here bond angle is 90. That means I told sp3 dihydrogenation two bond angles, one is 90 and one is 120. Here one important point, more bond angle, less repulsion, more bond angle, less repulsions and more stable. Very important, more stable. That means which one is more stable finally? Which one is in the more bond angle? Equatorial bond angle is the more bond angle, because less repulsion means which is having the less repulsion, that is having more stable. That means finally more stable arrangement is equatorial arrangement is the more stable than axial. That means these all 5 bonds are not equal. Very important point, one of the point statement. All 5 PCl bonds are equal. That is not equal. That statement is wrong. Equal means that statement is wrong. Not equal means that statement is correct. Why? Because it is equatorial plane, this is axial plane. That means here equatorial plane is what happened, more bond angle, less repulsions, more stable. This bond angle, this distance both are different. That is above and below the plane. Finally, which plane is more stable? Equatorial plane is more stable than axial plane. That's why this is the explanation. Using this, our example ClF3. So structure they will give you which of the following structure is more stable. Very important. Which shape? T shape. Central atom chlorine. How many bond pairs are there? 3 bond pairs are there. Observe here, 3 bond pairs. These are called 2 lone pairs. That means what I told, central atom and 3 chlorines are in one plane. Central atom and 2 lone pairs and chlorine are one plane. Sorry, this is F. Observe. Central atom, fluorine and 2 lone pairs in one plane. This is called equatorial. That means lone pairs are arranged in the equatorial plane. This is one of the possibility. Second possibility, central atom, 1 lone pair here, again other lone pair here. That means one lone pair is axial, other lone pair is equatorial. This is second arrangement. Third arrangement, central atom, this is other arrangement. That means 2 lone pairs are in axial. These 3 are the arrangement. Other than 3, which one is not? Other one is not possible. These 3 only possible. These 3 are the arrangement. In these 3 stability order, they are asking. One of the time they are asking neat question. Which one is more stable? Which arrangement is the more stable? So already I told. What I told? More bond angle, less repulsions and more stable. Which one is more bond angle? Equatorial. So equatorial is more stable than axial. That's why lone pairs arrangement in equatorial is more stable than axial. That's why all lone pairs are where it is present? Equatorial. Here one is equatorial and axial. Axial and equatorial. Here both are axial. That's why it is least stable, it is more stable, it is intermediate. Stability order is first one, second one and third one. How we will decide? Observe here. This lone pair, where it is present lone pair? Equatorial. Equatorial lone pairs are influenced on the axial bonds. What I told the point, observe now. Equatorial lone pairs influenced on the axial bonds. So that means equatorial lone pairs, how many there here? 2. This lone pair influenced on this one. This one means, that means this is lone pair bond pair. This is also lone pair bond pair. That means lone pair bond pair, lone pair bond pair, repulsion. Lone pair bond pair, lone pair bond pair, repulsion. So how many lone pair bond pair repulsions are? Lone pair bond pair, lone pair bond pair, lone pair bond pair, lone pair bond pair. That means lone pair bond pair repulsion total 4 here. Observe here. 2 different is there now. This is axial. Axial means axial lone pair influenced on the equatorial bonds. Equatorial lone pair influenced on the axial bonds. That means this observe now. This one, where it is present? Axial. Axial means it is influence on equatorial. Equatorial how many there now? This one. That means lone pair, bond pair, lone pair, bond pair, and again lone pair, lone pair. That means lone pair is there. Lone pair, bond pair. How many lone pair, bond pair? 2 lone pair, bond pair. In case of this means this lone pair, where it is present? Equatorial. Equatorial lone pair influenced on the axial. That means what? Lone pair. Already lone pair is there. Lone pair, here also one lone pair, 2. Again lone pair, bond pair. Lone pair, bond pair means again 1. Total 3. That means 2 lone pair and 3 lone pair, bond pair in this case. Observe here. In this case, these all are present on equatorial only. Axial only now. This axial lone pair influenced on the equatorial bond angle. That means this one influenced on lone pair, bond pair, lone pair, bond pair, lone pair, bond pair. How many in this one? 3. This one lone pair, bond pair, lone pair, bond pair, lone pair, bond pair, lone pair, bond pair. Total how many there now? Total 6. There 3, above 3, below 3. So which one is having the more repulsions? Here 4 lone pair, bond pair. Here 6 lone pair, bond pair. Here 3 plus 2, total 5. Here 6, here 5, here 4. Which one is having the more repulsion? This one. More repulsions, less stable. Less repulsions, more stable. More repulsion, which one? This one. That's the least stable. Which one less repulsion? This one. This is the more stable. What I told already, stability order. This one, this one, this one. Because less repulsions, more stable. More repulsions, less stable. This is the explanation. Right? This is the order one of the time they ask the question. Very, very, very important. Right? This is the statement based question they asked. That means finally what I have to conclude? Axial, it's called equatorial bond angle, equatorial lone pairs influenced on axial bond angle, bond lengths or axial bond angle. Axial bond angles influenced on equatorial bond angles, like that. That's what that we have to understand. Right. Next one. By using this, I am going to say the final other point now. Dipole moment or what do you call MOT concept. Okay, most of the they asking instead of dipole moment, they are asking most of the questions based on dipole moment. So dipole moment questions observe now. Dipole moment concept. This is the information about hybridization concept. Hybridization and Vesper theory concept. Dipole moment, that is represented by symbol is mu. Mu means that is called mu equal to q into d. So why you want to study dipole moment? Polarity of the polar molecule is expressed in the terms of dipole moment. Mu equal to q into d. What is q? Charge on the pole. What is d? Distance between the poles. For example, observe here, I am taking HF molecule. So the HF molecule, which one is the more electronegative? Fluorine is the more electronegative. Fluorine is the more electronegative, means electron towards fluorine side, because electron attracted towards fluorine side. Electron moving which side? Which direction it is moving? Fluorine. That's why representation is like this. This is the representation of the dipole moment, that is called crossed arrow. This is called head, this is called tail. Head indicates negative charge, tail indicates positive charge. Representation of dipole moment is crossed arrow. This is a vector quantity. Dipole moment is a vector quantity. Vector, it is not a scalar. Vector means both magnitude and direction, mainly direction. Magnitude means charges. Direction means which direction it is moving. Which direction it is moving. Which one is in the more electronegative, that's when it is moving. This is called representation of what you call dipole moment. One of the time they ask the question, it is a vector quantity or scalar quantity. It is a vector quantity. It is represented by crossed arrow. Crossed arrow means this is called head, this is called tail. Head indicates negative, tail indicates positive. Finally, Q into D. Q is called charge, D is called distance. Charge unit is coulomb, SI unit, I am saying now. coulomb into distance is meter, coulomb meter, otherwise coulomb meter is also called dBi. Actually dipole moment unit is dBi. 1 dBi is equal to 3.33 into 10 power minus 30 coulomb meter, cm. C is coulomb, m is called meter, one of the conversion. This is called SI unit. Again 1 dBi is equal to CCS unit, 10 power minus 18 ESU centimeter. This is not coulomb meter, this is called centimeter. Observe now. C dot m, coulomb meter, without dot, that is called centimeter. ESU means electrostatic unit for charge. Centimeter is the unit for distance. That finally 1 dBi is equal to both are the conversion. In case of SI unit is 3.33 into 10 power minus 30. 1 dBi is equal to 10 power minus 18 ESU centimeter. One of the time they ask the question in the NEET, this one only. Now, using this dipole moment, I am going to say this some applications, very, very important applications. Observe clearly. One of the question they ask this is HF, HBr, HCl, HI. Write the increasing or decreasing order of dipole moment. So, dipole moment purely depends on the dipole moment means dipole moment is expressed in the terms of polarity I told. Polarity is based on electronegativity difference. Which one is in the more electronegativity? That more electronegative element attract toward that side only. That's mean in this fluorine, chlorine, bromine, iodine, which one is the more electronegative element? Fluorine. Next bromine, next chlorine, next bromine. So, dipole moment order, HF is more than HCl than HBr than HI. How can you decide, sir? Because fluorine is the more electronegative. This example is decided by electronegativity concept. Electronegativity. More electronegativity, more charge separation. More charge separation means more polar. More polar means more dipole moment. Next one. I am taking the example this one. H2O and H2S. One of the time they ask the question. These two will exhibit dipole moment. Right? These two will exhibit dipole moment means how to know the dipole moment first. Observe. First we have to decide hybridization. What is the hybridization of H2O molecule? Central atom is oxygen. Oxygen group number 6. 6 plus number of hydrogens are 2. 6 plus 2, 8. 8 by 2. 6 plus 2, 8 by 2. Hybridization I am saying now. 6 plus 2, 8. 8 by 2, 4. 4 means which hybridization? sp3. How many bond pairs? Except central atom 2 bond pairs and 2 lone pairs. 2 bond pair, 2 lone pair means what is the shape? V shape, bent shape, angular shape. This also central atom sulfur group number 6. 6 plus 2, 8. 8 by 2, 4. 4 means 2 bond pairs to 2 lone pairs. Both are having the same shape, V shape. Both are in the same shape, but which one is having the more dipole moment? Very, very, very important. Without drawing the structure, we can say very easily. How to know? In the central atom, oxygen and sulfur, which one is having the more electronegative? Oxygen than sulfur. So, H2 is the more dipole moment than sulfur. Otherwise, structural representation. Central atom, two bond pairs to 2 lone pair, V shape. So, dipole moment is representation, which direction it is moving? Oxygen and hydrogen, which one is the more electronegative? Oxygen is the more electronegative than hydrogen. That is why electrons are moving towards oxygen side. This is the representation of dipole moment, already I told, crossed arrow. This also oxygen and hydrogen, which side is moving? Oxygen side. Oxygen and lone pair, which one is the more electronegative? Lone pair is more electronegative than oxygen. That is why it is moving like this. Oxygen to more lone pair and oxygen, which one is the more electronegative? Oxygen is the more electronegative, lone pair is more electronegative than oxygen. This resultant dipole moment, any cancellation is there or not? How to observe? Cancellation means opposite direction. Anyone is in the opposite direction? No. No one is in the opposite direction. All are in the same direction. Same direction means overall dipole moment is equal sum of these all four. That means overall dipole moment is moving on upward direction. This also same upward direction, same like this explanation. So both are having the dipole moment. Dipole moment means mu not equal to 0. Mu not equal to 0. Both are not having the 0. That means both are having the dipole moment, permanent dipole moment. Those are called, dipole moment is there, that molecule is called polar. Dipole moment is not there, that molecule is called non-polar. So both will exhibit dipole moment. Okay. This which one is the more dipole moment? Experimental value. H2 is more than H2S. How to know? Our explanation. Oxygen is the more electronegative than sulfur. That's why H2O is more dipole moment than oxygen. H2. Oxygen is more dipole moment than sulfur. Some other examples. Right. Next one, NH3 and NF3. Observe here. NH3 same hybridization, group number 5 plus 3, 5 plus 3 by 2, that is called 4. sp3. 3 bond pairs to 1 lone pair. 3 bond pairs to 1 lone pair. Observe here. Central atom group number 5, 5 plus 3, 8, 8 by 2, 4. That means again sp3. How many bond pairs? Both. 3 bond pairs to 1 lone pair. 3 bond pair, 1 lone pair means what is the shape? Trigonal, pyramidal shape. Both are in the pyramidal shape, like that. In this two, which one is the more dipole moment? Observe clearly. I am drawing the structure. This is the pyramidal shape of NH3. This is the pyramidal shape of NF3. Right. Dipole moment representation. In nitrogen and hydrogen, which one is the more electronegative? Nitrogen. That's why electrons are moving towards nitrogen side. That is the representation of dipole moment. In nitrogen and hydrogen, nitrogen, which one is the more electronegative? Nitrogen. Like this is moving. Now, nitrogen and lone pair, which one is the more electronegative? Every time more electronegative and lone pairs are there. Lone pair is the more electronegative than nitrogen as per Vesper theory concept. Why? Because lone pairs are occupying more space around central atom than bond pair. That's why it is more electronegative than central atom. Lone pairs are more electronegative than fluorine or oxygen or nitrogen. Why? Lone pairs occupies more space around the central atom than bond pairs. That's why it is more electronegative than remaining any other elements. Right. That's why nitrogen and oxygen, nitrogen lone pair, which one is the more electronegative? Lone pair. That's why lone pair also more electronegative means electrons are moving towards opposite upward direction. A resultant dipole moment all are in same direction. That means upward direction. If there is no cancellation, mu not equal to 0. That molecule having the dipole moment, permanent dipole moment. That's why this molecule is called polar. In case, observe this one. Nitrogen and fluorine, which one is the more electronegative? Fluorine. That means electron towards downward. Now here, downward. Because nitrogen and fluorine. In this, nitrogen and fluorine, downward, like this. Here, nitrogen and lone pair is the more. Then what happened here? This upward and downward. One lone pair is upward, other one fluorine bond pair is downward. Both are opposite direction. Here cancellation will be there. That means not complete cancellation, partial cancellation will be there. One bond pair will be cancelled by one lone pair. Remaining, these two are there. These two are in downward direction. Overall resultant dipole moment is downward direction. But this is also mu not equal to 0. But compared to this, this is little bit dipole means less dipole moment than this one only now. Why sir? Here partial cancellation will be there. Here there is no cancellation. Overall resultant dipole moment is sum of all 4. But here overall resultant dipole moment is sum of all 2 only. Because 2 are already cancelled. That's why this also not equal to 0, this also not equal to 0. But here partial cancellation, here there is no cancellation. That's why it is more dipole moment than this one. very very important, right? Then what I have to conclude, observe here clearly, here H2O and H2S, NH3 and NF3. H2 and H2S, which one is more electronegative, which one is more dipole moment? H2O. Here NH3 and NF3, which one is the more dipole moment? NH3. That means what you have to observe clearly, if more electronegative atom is central atom, if more electronegative is central atom, here more electronegative, less electronegative. So these are less electronegative. More electronegativity central atom is there, that is having the more dipole moment. Here more electronegativity the surrounding atom is there, that is having less dipole moment. Observe here, in these two, nitrogen, nitrogen, hydrogen, hydrogen surrounding atom, which one is the more electronegative? Fluorine than this, that means this surrounding atom. This is also surrounding atom. This is here, more electronegative is oxygen and sulfur, oxygen the more electronegative, surrounding atoms are less electronegative. That means what you have to conclude, if the electronegative central atom is more electronegative than remaining other, so that is only more electronegative. Now in this case, surrounding atoms are more electronegative in these two, that means which one is having the surrounding atoms more electronegative, that is having the less dipole moment. Next, some other point, some other application. One of the question very very important, one of the time they ask the question, this one only. This is alkene, alkene. This is cis alkene, this is called trans alkene. How to know? Double bond is there. Similar groups are present on same side. Similar groups are present on opposite side. That is called cis, this is called trans. Now cis, which one is cis? This one. So dipole moment observe now. Carbon and chlorine, which one is the more electronegative? Chlorine is the more electronegative. That's why electrons are moving towards the chlorine side. Carbon and chlorine, which one is the more electronegative? Chlorine, electrons are moving towards chlorine side. Carbon and hydrogen, which one is the more electronegative? Carbon, so electrons are moving towards carbon side. Here carbon, hydrogen, carbon side. Now here resultant dipole moment is, there is no cancellation, resultant dipole moment is upward direction, that means mu not equal to 0, that is called, it is having the permanent dipole moment. This is called polar. Now this one observe now. This upward because carbon and chlorine. Here downward. This is leave it now. Hydrogen leave it now. Main these two. Opposite direction. Opposite direction means what happened? Cancelling each other. Cancelling each other means what you call mu equal to 0. Mu equal to 0 means that is called polar or non-polar. This is called non-polar. This is called non-polar. Non-polar molecule. Observe important point here. Based on cis and trans, some other physical properties I am going to say based on the dipole moment. Dipole moment order, first point. Which one is the more dipole moment? Cis is more dipole moment than trans because mu not equal to 0, here mu equal to 0. Which one is having the dipole moment? Dipole moment is there, that molecule is called polar. Now which one is polar? Polar nature. Cis is polar than trans. Cis is polar. Cis is polar means what about trans? Mu equal to 0 means that is called non-polar. There is no charge separation. There is no charge separation means that is called non-polar. That's why trans. Trans is non-polar, cis is polar. Next one, solubility. Solubility in water. Solubility in water, which one is more soluble? Solubility in water means water is the polar solvent. You know all of you. Polar compounds are soluble in polar solvent, like dissolve in like. Non-polar compounds are soluble in non-polar solvent. Now what I am saying now? Solubility in water. So which one is the more soluble? Cis is more soluble than trans in water because water is polar. Polar means cis is polar because mu not equal to 0. That is mean dipole moment is there. So cis is polar, trans is non-polar. It is insoluble. It is soluble. In case of non-polar solvent. Non-polar solvent means like benzene, carbon tetrachloride, ether, acetone, those are called non-polar solvent. That time solubility. Trans is more than cis because trans is non-polar. Non-polar compounds are soluble in non-polar solvent. Next point is boiling point, very important. Boiling point. Boiling point depends upon polarity. That means boiling point directly proportional to polar nature. Which one is the more polar? That is having the more charge separation. More charge separation means it is required more boiling point. That means boiling point is cis is more than trans. In case of melting point very important. Melting point is depends on symmetry. Symmetry means what here in our point of view? Symmetry means equal distribution, that is okay. But here symmetry means I will take solid, liquid, gas. Which one is having the more symmetrical compound? Solids are more symmetric than liquid than gas. That means all the particles are, all the ions are regular arrangement of the particles or atoms are called as symmetrical molecule. In the solid, liquid, gases where the ions or particles are arranged in regular manner, solids. That means symmetrical molecules. Which one? Solids. In the symmetrical molecule, which one is the symmetrical molecule? Which one is the trans? Which one is the non-polar molecule is there? Non-polar molecule is called more symmetry. Non-polar compounds are more symmetrical because mu equal 0, both opposite direction. That means if you cut into that two equal opposites, you will get it, that is the reason it is a symmetrical molecule. That means non-polar compounds are symmetrical compound or symmetrical molecule. Symmetrical molecule means symmetrical molecules having the more melting point. That means finally melting point depends on symmetry, boiling point depends on polar nature. So melting point finally trans is more than cis. These are the most of the physical properties, very important. Match the following type or statement based question. One of the time they ask, these are called applications of what you call dipole moment. Now I will give other example to the dipole moment, then you have to do. Now today what I explained the concept, dipole moment and hybridization concept, compulsory 3 questions. Dipole moment related question compulsory 1 question. Hybridization concept compulsory 2 questions. So that's why compulsory how to focus on these concepts. One of the example is I am giving CH4, I am giving CO2, I am giving BF3. These are what? Which one is the permanent dipole moment? Which one is the non-zero dipole moment? Non-zero means without zero. How to know? First I find the hybridization. So instead of doing this all concepts, just simple I will give one point to you. Which molecule having the only bond pairs? That molecule is not having the dipole moment. That means mu equal to 0. Only bond pairs. Next point. Bond pairs plus compound and the bond pairs plus lone pairs are there. That compound is mu not equal to 0. Mu not equal to 0 means this is called non-zero dipole moment. That is having the dipole moment. Now mu not equal to 0 means polar, mu equal to 0 means non-polar. Observe clearly. Hybridization. How to know bond pairs, lone pair based on hybridization? Central atom group number 4 plus 4 by 2. 4 plus 4, 8. 8 by 2, 4. 4 means sp3. Very good. How many bond pairs? Except central atom, 4 hydrogens are 4 bond pairs are there. What about lone pairs? 0 lone pairs. So because total must be 4. 4 bond pairs, 0 lone pairs. So sp3 hybridization, this compound is not having the lone pair, there is having only bond pair. That means this compound mu equal to 0 without drawing like these structures. CO2, carbon 4 plus 0 by 2 because their oxygens are there. Now we want hydrogens and halogen. 4 plus 2, 4 by 2, 2. That means sp. How many bond pairs? 2 oxygen, 2 bond pairs, lone pairs are 0. That means this also mu equal to 0. BF3, group number 3 plus 3 by 2 because 3 fluorines. That means sp2. How many bond pairs? 3 bond pairs, 0 lone pairs. 3 bond pairs, 0 lone pairs, that is equal mu equal to 0. Now what about this? Observe here. What about this example? Simply I will tell H2O or XeF2. Observe H2O, central atom group number 6, 2 hydrogens by 2, that means sp3. How many bond pairs? 2 bond pairs. How many lone pairs? 2 lone pairs. That means here lone pairs are there. What I want? Bond pair plus lone pair is there. That means mu equal to 0, mu not equal to 0. Na? Mu not equal to 0. That means this molecule having dipole moment. This one observe. Group number 8, 8 plus 2, 10, 10 by 2, 5, total 5. 5 means sp3d. That means how many bond pair? 2 bond pairs. How many lone pairs? 3 lone pairs. 2 plus 3, that means the lone pairs are there. That means this is called mu not equal to 0. Mu not equal to 0 means this compound having the polar, this compound also having the polar. These are called non-polar. Like this, you have to identify the compound. This is the information about dipole moment. Right? Now, okay ma, today I am going to stop the class. Next class, next means Monday, some other concept. Okay, some other concept that is called structure of atom. I will start on Monday. Okay, right? Thank you, ma.
Yes, my dear students, good afternoon all of you. Today I am going to discuss collisions. Okay, these are collisions. In this year we will cover impulse, law of conservation of linear momentum, elastic collision in one dimension, inelastic collision in one dimension, semi-elastic collision. So among these 5 topics, so which one is the most important? So most of the questions so given on the impulse. After that, this elastic collisions. After that, here inelastic collisions. Okay, these are the importance of your topics. First of all, let's discuss the impulse. So what is meant by impulse? Impulse. So, it is the product of large force acting in a short interval of time. Okay, that is J bar is equal to F bar into delta T. This J bar is equal to F bar into delta T. From Newton's second law, we know that here force is equal, force acting on the body is equal to change in momentum of the body. From that here F into delta T is equal to what? Change in momentum. So that impulse also defined as a change in momentum of the body. This J bar also is equal to this change in momentum of the body. This is equal to final momentum minus initial momentum. Okay, impulse is equal to change in momentum of the body, that is equal to final momentum minus initial momentum of the body. Because generally, so now this impulse, whenever two bodies are collided, force acting on one body to another body, that force is called impulsive force. That time is called impulsive time. Impulsive time this is. Okay, so this is impulse this is. Next. Now let us discuss the elastic collision in one dimension. So what is meant by collision? Collision means here the strong interaction between the two bodies. So is called here collision. During the collision, bodies may be contact or may not be contact. Sometimes here may be contact, sometimes may not be contact. Suppose if you take a fundamental particles like electrons and protons come closer like this, okay, their direction changes due to repulsive forces. In this case, though there is no physical contact, okay, there is also collision. So basically these collisions are two types. One is elastic collision, another one is inelastic collision. So what is elastic collision? The collision in which both momentum and kinetic energy are conserved, whereas in the non-elastic collision, inelastic collision, the only momentum is conserved, kinetic energy is not conserved. First let us discuss elastic collision in one dimension. In one dimension. So one dimension means that bodies before collision, after collision moves along a straight line. That is called one dimensional collision. Now let us consider two bodies of masses m1 and m2 moving with velocities u1 and u2. So this is a body of mass m1 moving with velocity u1. This is a body of mass m2 moving with velocity u2. Suppose u1 is greater than, if u1 is greater than u2, first body approaches the second body, this is during the collision, this is during the collision. This is called line of impact, this is called common normal, this is a common tangent, this is a common tangent. So after collision, first body moves with velocity v1 and second body moves with velocity v2. Okay, this is before collision, this is during the collision, this is after collision. In this here, so in this elastic collision, both momentum is conserved, kinetic energy also conserved. Means here momentum is conserved, means here total momentum before collision is equal to total momentum after collision. So this is total momentum before collision. This is initial momentum, Initial momentum is momentum of the first body plus momentum of the second body. This is m1 into u1 bar, m2 into u2 bar. This is final momentum. So total momentum after collision is called final momentum. This is m1 v1 bar plus m2 v2 bar. And also in this kinetic energy also the initial momentum is equal to final momentum. So this momentum is equal to this momentum, because external force 0 in this here. So force acting on this is internal force acting on one body to another body is internal force, that is not external force. In this has external force 0, momentum is conserved. So that this initial momentum is equal to final momentum. And also in this kinetic energy also conserved. Okay, in this here kinetic energy, initial kinetic energy is equal to total kinetic energy before collision. That is kinetic energy of first body plus kinetic energy of second body. Kinetic energy of first body is half m1 u1 square plus half m2 u2 square. That kinetic energy of the second body, Kf is equal to what? Sorry, final kinetic energy after collision. So this is a total kinetic energy after collision, kinetic energy of first body plus kinetic energy of second body. Kinetic energy of first body is half m1 v1 square plus half m2 v2 square. In this kinetic energy also equal. If you solve this, you will get finally velocity of first body and velocity of second body. That velocity of first body, how much this velocity of first body is equal to m1 minus m2 divided by, if you solve these two equations, okay, by applying conservation of linear momentum and conservation of kinetic energy, after solving that, you will get here velocity of first body and velocity of second body. Velocity of first body after collision, v1 bar is equal to m1 minus m2 by m1 plus m2 into u1 bar. And also this 2m2 divided by m1 plus m2 into u2 bar. Similarly, velocity of the second body after collision, v2 bar is equal to 2m1 divided by m1 plus m2 u1 bar plus m2 minus m1 divided by m1 plus m2 into u2 bar. This is the velocity of the first body, this is velocity of the second. This is the most important formula, these two formulas. Because this in one dimensional elastic collision, remember these two formulas. From some special cases are there. First, the two bodies have same masses. If m1 is equal to m2, then what happens? This velocities. Whenever m1 is equal to m2, this is equal to 0. These are your 2m by 2m1, so that v1 is equal to, this v1 bar is equal to your u2 bar. Similarly, here also, so m1 is equal to m2 means this term will be 0. So this 2m by 2m cancel, so that v2 bar is equal to, so this v2 bar is equal to u1 bar. If you observe this condition, that both bodies have same masses, their velocities are interchanged. The first body acquires the initial velocity of second body. A second body acquires the initial velocity of the first body, so that the velocities are interchanged. So while doing the problem, remember these conditions. Next, and second one, if m1 is equal to, here m1 is equal to m2, and the second body is at rest. The second body is at rest means that this is equal to 0. m1 is equal to m2 means that this is also 0. So that first body comes to rest after collision. Next, according to this second body rest means u2 is equal to 0. But m1 is equal to m2 means v2 is equal to how much? So v2 bar. So v2 bar is equal to u1 bar. Means sir, first body comes to rest, second body moves with the velocity of first body. Next, if m1 is very greater than m2, means sir, first body is a heavier body, second body is a lighter body. Okay, so now m2 can be taken as 0, this is, and also u2 is equal to 0, second body is at rest. This is 0. Yes, in this here u2 is equal to 0. Oh, m2 is equal to 0, this is 0, this is 0, so that v1 is equal to how much here? Then v1 is equal to u1 bar. What does it mean? Velocity of the body, first body does not change. When the first body is heavier body, here collide with the second body is at rest, lighter body is at rest, velocity of first body does not change. That is v1 bar is equal to u1 bar. And also this is v2 bar. Okay, v2 bar is equal to how much? Okay, this is m1 is second body means this is 0. Here m2 is equal to 0. This is means here m1 cancel, so that v2 bar is equal to here 2 into u1 bar. Means here second body moves with the double the velocity of your first body. Okay, next, fourth one. If m1 is very less than m2, and second body is at rest. Mr. First body is a lighter body, second body is a heavier body, and second body is at rest. Then what is the velocity of bodies after collision? Well, second body is at rest, this is 0. Take m1 0, this is in this here. Oh, m1 0, this is also 0. You will get v1 bar is equal to minus u1 bar. Means here whenever lighter body collide with the heavier body, then the lighter body here return back, minus means here return back with same velocity. Next. So what is the velocity of this here heavier body? Now this is u2 is equal to 0 and m1 is equal to 0, this is 0 means here. So that here v2 is equal to 0. Means here second body, heavier body does not move, is at rest. Whenever lighter body collide with the here heavier body always rest. Next, air condition. What is the kinetic energy retained by the first body? This is kinetic energy retained by the first body. Means that this is called kinetic energy of the after collision, kinetic energy of the first body. So after collision, what is kinetic energy of the first body? Half m1 v1 square. Half m1 and second body is at rest. In this here consider second body is at rest. Second body is at rest. Whenever second body is at rest here, then so what is kinetic energy retained by the first body or what is kinetic energy of the first body after collision? This is equal to kinetic energy of the your final kinetic energy of the first body. Because this is Ke1 final, this is okay, final. Okay, this is equal to half m1 v1 square. But v1, if this is equal to 0 now, v1 is equal to how much here? m1 minus m2 divided by this. Finally we can write this is equal to half m1 u1 square m1 minus m2 divided by m1 plus m2 whole square. Okay, this is a initial kinetic energy of the first body. This is a kinetic energy retained by the first body. Similarly, kinetic energy transferred from first body to second body. Whenever first body collides with the second body is at rest, some kinetic energy transferred from first body to second body, that is called kinetic energy of second body after collision. This is a kinetic energy of second body after collision, final kinetic energy. This is equal to how much here? Half m2 v2 square. v2. This is u2 is equal to 0. v2 is equal to substitute. So finally you will get this is equal to half m1 u1 square 4 m1 m2 divided by m1 plus m2 whole square. Because this is final kinetic energy of second body or kinetic energy transfer from first body to your second body, or this is initial kinetic energy fraction. This is fraction of kinetic energy transferred from first body to second body can be written as this is equal to Ke to F divided by this is initial kinetic energy. With this initial kinetic energy of the first body, this is equal to 4 m1 m2 divided by m1 plus m2 whole square. This is a fraction of kinetic energy transfer from first body to second body. Because this is the most important theory. So elastic collision in one dimension. Similarly, let us discuss inelastic collision in one dimension. Okay, during the elastic collision, after collision, so these are both bodies move separately. Next we will discuss the inelastic collision, one dimension. One dimension inelastic collision. In this before collision, after collision, both bodies move along a straight line. But in the case of inelastic collision, only momentum is conserved, kinetic energy not conserved. Best example, collision between the vehicles. So whenever vehicles are collided, This is some energy, kinetic energy converted into sound energy and light energy and heat energy and also elastic potential energy like this. There is some loss of energy. That is why kinetic energy is not conserved. Okay. In this here, let us consider two bodies of masses. These are m1 moving with velocity u1, second body of mass m2 moving with velocity u2. But u1 is greater than u2. So these are during the collision. So after collision also after collision, both bodies move with the same velocity, common velocity. Mr. After collision, both bodies move together in this. Okay. In this only momentum is conserved. Whenever momentum is conserved, now this initial momentum is equal to final momentum. Mr. Total momentum before collision is equal to total momentum after collision. So what is the total momentum before collision? Total momentum before collision is momentum of first body plus momentum of second body. This is m1 u1 bar plus m2 u2 bar is equal to total momentum after collision. This is equal to m1 plus m2 into vc bar. That when this common velocity is equal to how much? Common velocity is equal to m1 u1 bar plus m2 u2 bar divided by m1 plus m2. So while applying this u1 and u2, consider sign convention. Both are moving the same direction, take positive. Suppose moving opposite direction, u1 positive, u2 value is negative. That way I have written vector form. This is a common velocity. Next. And also in this here, during the collision, some energy is lost. Mr. Kinetic energy converted into sound energy and also heat energy. That is called loss of energy. Loss of energy, how much here? So this loss of energy is equal to initial kinetic energy minus final kinetic energy. This is initial kinetic energy minus final kinetic energy. Okay, this is initial kinetic energy, final kinetic energy, substitute there and solve. You will get one formula, that is delta K is equal to half m1 m2 divided by m1 plus m2 into u1 bar minus u2 bar. u1 bar minus u2 bar whole square. This is whole square. In this also, suppose two bodies are moving the same direction. This is u1 minus u2, opposite direction. This is u1 plus u2. This is. Okay. Next. So this is the loss of kinetic energy during the inelastic collision. Okay. Next one, now let us discuss a semi-elastic collision. Semi-elastic collision. So in this here, consider two bodies of masses m1 moving with velocity u1. This is second body of mass m2 moving with velocity u2. This is u1 is greater than u2. Okay, this is during the collision. After collision, first body moves with velocity v1 and second body moves with velocity v2. Okay, this here. Remember, what is velocity of first body, velocity of second body after collision? Remember these formulas. This is v1 bar is equal to, this is velocity of the first body after collision. This is equal to m1 minus em2 divided by m1 plus m2 into u1 bar plus 1 plus e into m2 divided by m1 plus m2 into u2 bar. Next, V2 bar is equal to 1 plus E into M1 divided by M1 plus M2 into U1 bar. Next, this is M2 minus EM1 divided by M1 plus M2 into U2 bar. This is the velocity of the first body after collision, this is velocity of the second body after collision. Similarly, loss of kinetic energy formula. Loss of kinetic energy is equal to 1 by 2 m1 m2 divided by m1 plus m2 into u1 bar minus u2 bar whole square into 1 minus e square. So this is 1 minus e square. This is. Here also consider sign convention. Both are moving same direction u1 minus u2. Opposite direction u1 plus u2. So this is a loss of kinetic energy. Remember these formulas in the case of semi-elastic collision. Next. In this area, where E, what is meant by E? E is a coefficient of restitution. E is a coefficient of restitution. So, coefficient of restitution depends on the nature of the material of the bodies, not depends on the velocities of bodies. This is a coefficient of restitution. E is equal to how much? E is equal to relative velocity of separation by relative velocity of approach. This is a relative velocity of separation divided by relative velocity of approach. Relative velocity of approach. In this, while considering this velocities, all velocities along the common normal direction. Common normal, this is a common normal, this is a common tangent, this is. Take all velocities, before collision and after collision, take velocities along the common normal, this is along the common normal. If you apply this formula for this, we can write your coefficient of restitution E is equal to relative velocity of separation. Separation means this is V1 and V2. So that this is equal to V2 minus V1 divided by relative velocity of approach U1 minus U2. So this E is equal to V2 minus V1 divided by U1 minus U2. Okay? So this is a coefficient of restitution. It depends on only nature of the material of colliding bodies. It does not depend on the velocities of the bodies. Okay? Next. So remember some applications of coefficient of restitution. This coefficient of restitution, E is equal to formula, basic formula, E is equal to what? V2 minus V1 divided by U1 minus U2. In this all velocities along the common normal direction. Okay, suppose, it's one question, listen carefully. A body is dropped. This body is dropped from certain height. It reaches the ground with velocity V1. It rebounds with velocity V2. In this ball is the first body. Ground is the second body. Okay, so that ground is second body means here this is U2 and V2 values. Finally, you will get here this is a common normal direction. This is all velocity. This is V1, this is V2. So that in this here coefficient of restitution E is equal to this is V2 by V1. Remember, V2 by V1. So that here V2 is equal to how much here this V2 is equal to E into V1. This V2 is equal to E into V1. This is. Okay. Next, another question. If a body is dropped from certain height, it reaches the ground with velocity V1. After first rebound, go with velocity V1. Go to second rebound with velocity V2. Third rebound with velocity V3 and so on. Nth rebound this is nth rebound, this is Vn. Remember, velocity after nth rebound formula Vn is equal to how much here? E power n into V. Okay, if you take here side by side, V2 is equal to EV1. Here also, we can write V1 is equal to EV. V2 is equal to EV1. V3 is equal to EV2. Okay, next. One more question. If a body is dropped from, certain height, h1, okay, and rebounds to height h2, this is when velocity is equal to how much? Root over 2gh1, here velocity v2 is equal to how much? Root over 2gh2. We know that formula v2 by v1, no? Finally you will get E is equal to what? Root over h2 by h1. Or from this here we can write H2 is equal to how much here? E square into H1. H2 is equal to E square into H1. This is. So another question, if a body is dropped from certain height H this is, it rebounds to height H1 after first rebound and height H2 after second rebound and after here Hn this is. Then the height rises after nth rebound is equal to, remember this formula, e power 2n into h. Okay, these are some important applications of E is equal to V2 minus V1 by U1 minus U2. Okay. Now let us solve some questions. So given in the previous year, yes, 2025 question. This question given on the impulse. First I will write the question. A ball of mass 0.5 kg, this is a ball of mass 0.5 kg is dropped from a height of 40 meter. The ball hits the ground. The ball hits the ground. Hits the ground and rises to a height of 10 meter. Height of 10 meter. The impulse and also given G value 9.8 meter per second square. Find the impulse imparted to the ball during its collision with the ground. Impulse is equal to how much? This is impulse. Impulse is equal to how much? Okay, this is given values. This is. Okay, first of all, body is dropped from 40 meter height. Because the ball is dropped, this is a ground, this is a ground. The ball is dropped from some height h1, this h1 is given, this h1 is equal to 40 meters. And rebounds, so this rebounds to height h2, this is. So h2 is equal to given 10 meters. What is the impulse? Now this m is the mass of the body, this is. Okay, what is the impulse exerted by ground on the ball? Okay, this impulse is equal to how much? J is equal to how much? Okay, generally, so whenever ball dropped from certain h1, so velocity v1 is equal to how much here? v1 is equal to root over, this is 2g h1. And this velocity v2 is equal to how much here? Root over 2g h2, this is. But directional velocity changes, this is a minus. So that generally impulse is equal to this final momentum minus initial momentum. Okay, impulse is equal to final momentum. What is final momentum? Mass into velocity, m into this v2 bar minus v1 bar. So that here j bar is equal to how much here? M into v2 bar. v2 bar means here minus of root over 2g into h2. Minus of root over 2g into h1. If you take only here take magnitude, j is equal to what? M into root over 2g into root h1 plus root h2, this is. Given all values, substitute there you will get answer. Then the here J is equal to impulse, J is equal to M is given 0.5 and root 2 into G value 9.8 into a root 40 plus root 10. So this is impulse. If you calculate, you will get this is equal to here 21. So this is here 21 Newton. This is Newton seconds. These are 21 Newton seconds. Okay, this is a 2025 question. Next. Next 2024 question. The 2024 question. This question based on inelastic collision. This is completely inelastic, undergo inelastic collision. Got two bodies. Two bodies, A and B. A and B of same mass. Same mass undergo completely inelastic collision. Inelastic one-dimensional collision. One-dimensional collision. Collision. The body A. The body A moves with velocity v1. With velocity v1. While body B is at rest. Before collision. Before collision, the velocity of the system after collision is v2. The velocity of system after collision is v2. The ratio v1 is to v2 is dash. Is a dash. Okay. In this two bodies have same masses. This are two bodies have same masses. The two bodies have same masses. This A body, this B body have same masses. The body A moves with velocity v1. This is, but body is at rest. This is equal to 0, velocity 0. This is equal to 0, this is, or u2 this is u1, initial velocity u1, u2 is equal to 0. But during the collision, inelastic collision, this is completely inelastic collision this is. That is why both bodies move together in this here both bodies here move together like this. This is a common velocity. This common velocity is given v2. Then v1 by v2 is equal to how much? In this only momentum is conserved. Total momentum before collision is equal to total momentum after collision. What is total momentum before collision? This is m into v1. This momentum is 0. What is total momentum after collision? This is equal to 2m into v2. Okay, here mm get cancelled. So that v1 by v1 is to v2 is equal to how much here? 2 is to 1. Very simple question. If you observe both the questions here, questions based on the concept and also direct formula. so that don't lose your marks. Revise total chapter concept and also clarity, concept clarity, then you solve the only formula, they are asking here only formula based questions. Next, here one more question. Okay, this is also 2023, very simple question given, so I will read out. A bullet of mass m hits a block of mass capital M elastically. The transfer of energy is maximum when? I told you a given conditions in the case of elastic collision. When the both bodies have same masses, their velocities are exchanged, means here maximum energy is transferred. So that in this case here condition is capital M is equal to small m. Okay, next. And so one more question. These are 2023 also, this question also 2023. This also question related to impulse. Or sir, force impulse means sir force exerted. Okay, okay. Now this your 1 kg block. This is a 1 kg block or 1 kg object. Object strikes a wall. With velocity 1 meter per second. At an angle 60 degrees. At an angle 60 degrees. With the wall. And reflects at the same angle and reflects with the same angle. If it remains in contact, contact with wall for 0.1 seconds. Then the force exerted on the wall is dash. Then the force exerted on the wall is dash. And the wall is dash. This problem also similar to this air impulse. This is okay. Now this R force, rate of change of moment of this this wall. This is okay. M is the mass of the object. This is m is the mass of the object is 1 kg with a velocity. So this one ball is hits the wall like this at an angle for theta. Theta is equal to given 6 degrees. It hits the wall with velocity v is equal to 1 meter per second. Okay, it rebounds with the same like this. Go with the same angle. This is theta is equal to 6 degrees with the same velocity. What the force exerted by the ball on the wall, then F is equal to how much? This F is equal to how much here? Here F is equal to, so time also. In this here, time also given 0.1 seconds. This is delta t is equal to 0.1 second. This is. According to Newton's second law, this F bar is equal to how much here? Change in momentum by time interval. This is. Change in momentum by time interval. What is the change in momentum? See, if you observe this, okay, now this velocity can be resolved into two components. This is like this. This here for V cos theta, this is V sin theta. This is. Here also velocity can be resolved into two components. Because this here V, because this V sin theta, V cos theta, this also V sin theta. This is. But change in momentum, both are same direction. Change in momentum along the wall is 0, but perpendicular to wall, because this if it is placed, this is minus. Change in momentum is equal to how much here? V sin theta plus V sin theta, 2V sin theta. So that this is equal to mass into this is change in velocity. This is divided by time interval. So that this is equal to the change in velocity is how much here? Here 2V into sin theta. Divided by time interval, this is equal to final, this is equal to what? 2mv sin theta divided by delta t. This is a force exerted by wall, by the ball. This is. But substitute, here given values, this is equal to, here 2 into mass is equal to 1 kg, and velocity is a 1, and also sine 30 degrees, 60 degrees. Divided by your 0.1, if you calculate, you will get your force. Sine 60 root 3 by 2, root 3 by 2 cancel. So there is finally this sine 60 value, here this is root 3 by 2 this is. Okay, this is equal to finally 10 root 3 newtons. This is a force exerted by ball on the wall. This is a 2023 question this is. Okay. Next. Now discuss the 2022 question. 2022. Question. This is a shell of mass m is at rest initially. It explodes into 3 fragments having masses in the ratio 2:2:2:2:1. If the fragments have equal masses fly off along mutually perpendicular directions with the speed v, the speed of the third fragment is what? This is a total mass. So initially total mass, this total mass is capital M. This is at rest. So initially this is at rest. This exploded into 2:2:1. But fragments having equal masses fly off along perpendicular mutually perpendicular direction. So this fly off like this. This after explosion. Because 2:2:2:1 means here this mass is, this is 2m, this also 2m, this is m, this equal velocity is v, this is. Okay, what is the velocity of the third piece? Find the velocity of the third piece is equal to how much? Because this is your question. Once again listen carefully, one bomb is given, its mass is, some mass is given, now the velocity is equal to 0. This divides in the ratio of, we explained ratio of 2:2:1. Suppose this total mass is 5m, go 2m, this is m. But equal masses move perpendicular to each other, this is a perpendicular. This is. Okay, what is the speed of the third fragment? V3 is equal to how much? In this here, according to law of conservation of linear momentum, so this bomb is a system, this is. External force is 0. Due to internal forces, bomb is exploded. So that your total momentum is conserved. That is total momentum before explosion is equal to total momentum after explosion. So this is a total momentum before explosion means your initial momentum. The total momentum after explosion is the final momentum. So initially before explosion this is 0 this is. After explosion this is a momentum of the first body plus momentum of the second body plus this is a vector sum momentum of the third body. Okay, this is a momentum of the third piece. So P3 bar is equal to minus of P1 bar plus P2 bar. This is. So then also P3 bar is equal to minus P1 momentum of first. This is. So this is first piece. This is second piece. This is third piece. Momentum. Suppose this x-axis mass into velocity. So that this is equal to 2 mv I cap. So B2 bar mass into velocity, this is 2m into Vj cap. If you take magnitude, then the P3 is equal to root over x component whole square y component whole square 2 mv whole square plus minus 2 mv whole square. This is equal to root 2 into 2 mv. So this is P3. This is P3 is equal to what? Root 2 into 2 mv. Okay, these are here momentum of the third piece. Momentum of the third piece. Next, one more question. So 2021. In 2021 also given impulse question. So in this year, same model is given. 2025 one question is given, no? Same model is given. This in this also. This is 2021. This is a ball of mass m is equal to 0.15 kg is dropped from a height 10 meters, height h1 for 10 meters. Strikes the ground, rebounds to height the same height, h2 is equal to 10 meter. The magnitude of impulse is equal to how much? J is equal to how much? In this year, one body is dropped like this. Certain height h1, it rebounds to height h2. This is. Okay, in this here, this is V1. V1 is equal to how much? Root over 2gh1 and V2 is equal to root over 2gh2. But impulse is equal to how much? Impulse is equal to change in momentum P2 bar minus P1 bar. Okay, so that here J bar is equal to this m V2 bar minus m V1 bar. So that momentum impulse is equal to mass into change in velocity V2 bar minus V1 bar. Substitute there, you will get answer. Same 2025 question this is. Okay, next. Next 2019 question. So what is the time now? 10 minutes. Yes. So my dear students, here one more question, 2019 question. This given body A of mass 4m. This is body A of mass 4m. Moving with moving with speed u, collides with another body, another body of mass to another body B of mass 2m at rest. The collision is head on and elastic in nature. Collision is head on, elastic collision. After the collision, the fraction of energy lost by the colliding body. Okay, after the collision, the fraction of energy lost by the colliding body A is dash. Okay, in this here, two bodies are given. This is because this is before collision, this is body A, this is body B, this is body A mass is 4m, moving with speed u. This is V is at rest, u2 is equal to 0. Because mass is what, 2m, this is during the collision. After collision, okay, after collision, here velocity of the first body is what, this is v1, and velocity of the second body is what, this is here v2, this is. Okay, this we have to calculate after the collision the fraction of energy lost by the colliding body. This is. So what is the fraction of energy lost by the A body? Means here, this initial energy, this final energy. Change in energy. How much here? This is equal to fraction of, this is half m. With this here, half m1. This is the first body, no? Mass of A into this is u1 square minus mass of A. So v1 square divided by initial velocity of ma into u1 square. This is a fraction of kinetic energy lost by the body A. This value how much here? Initial kinetic energy minus initial kinetic first body minus final kinetic first body divided by initial kinetic energy of the first body. So that in this here we know that u1 and mass of A, we need to find out v1. This is given head-on collision. Head-on collision means one-dimensional inelastic collision. In one-dimensional inelastic collision, we know that formula velocity after collision formula, this v1 how much, and this v1 is equal to formula. It was whenever second body is at rest, this is m1 minus m2 divided by m1 plus m2 into u1. But second body is at rest. So that v1 is equal to m1 is equal to 4m, m2 is equal to 2m divided by 4m plus 2m into u1. So that v1 is equal to 2m divided by 6m into u1. u1 means here, u1 is equal to u, this is u. get cancelled. Then v1 is equal to what? U by 3, this is a velocity, here v1 is equal to u by 3. This is a fraction of kinetic energy lost by the, this is a fraction of kinetic energy. Fraction of kinetic energy loss by A. Substitute. This is equal to half. M is equal to how much? 4m into u square minus 1 by 2 4m into V1. V1 is equal to u by 3. U by 3 whole square divided by 1 by 2 4m u square. If you solve this, you will get here this value here 8 by 9 this is. This value is how much here? 8 by 9. So answer is this fraction of kinetic energy lost by here A this is. Like this proceed to find out the problem. This is a 2019 question. Somewhat is different question. It is not a direct formula. Okay. Next. So one more question. Okay. 2018 question. My 2018 question. In 2018 question given a moving block having mass m. This a moving block having mass small m collides with another stationary block. Collides with another stationary block having mass having mass 4m. The lighter block comes to rest. After collision. When the initial velocity of the lighter block is v, when the initial velocity of lighter block is v, find the value of coefficient of restriction. E is equal to how much? This is a first block, this is of mass m, this is moving with velocity. This collides with another stationary block of 4m. First block moves with velocity vm. Means u1 is equal to v. But second block mass is 4m. This is E is at rest. u2 is equal to 0. This is during the collision. After collision, lighter block comes to rest. Means v2 is equal to 0. Okay, come to rest after collision. So now this is v1. This is 4m. This is v2. First we have to find out v2 value. Okay, v2 is equal to how much? Okay, how to calculate v2 value? This is. So we know that all values. So that by applying conservation of linear momentum, we can find out here v2 value. What is conservation of linear momentum? Total momentum before collision is equal to total momentum after collision. In this here, if you consider this whole system, this is internal force are acting, external force 0, so that initial momentum is equal to final momentum. In this here, initial momentum is equal to, this is equal to final momentum. Initial momentum was momentum first body m into v, momentum second body is 0, momentum first body is 0 plus 4m into v2 this is. So that m into v is equal to 4m into v2, here mm cancel, so that v2 is equal to v by 4. This is the velocity of the second body after collision. But this along the common normal, your coefficient of restitution is equal to formula v2 minus v1 divided by your u1 minus u2. Substitute E is equal to v2 is equal to v by 4 minus v1 is equal to 0 divided by v minus 0 this is. So that E is equal to what? 1 by 4. This is a coefficient of restitution. Okay, this is a procedure to find out the problem. Okay, if you observe all the questions are very simple and also formula based and also very conceptual. Okay, if you perfect concept clarity and also problem based, formula based problems if you practice, you can solve each and every question. Okay, yes. So now time is also over. Thank you. Have a nice day.
Okay. Good afternoon, dear students. Today I will explain concept from the microbes in human welfare. The topic is sewage treatment. Sewage treatment. So, first of all, what is sewage? Means the municipal wastewater generated from the cities and towns is called sewage, also known as wastewater, right? Then what are the components of sewage? So, sewage or wastewater generated from the cities and towns contains human excreta is one of the major component present in the sewage, and the second one is organic matter. A large amount of organic matter is also present, which is actually
harmful because organic matter causes pollution of water. So, to make pollution free water, organic matter must be digested. So, that organic matter digestion takes place by the microorganisms. So, the third important component of sewage is many pathogenic microbes are also present in the sewage. So, sewage contain mainly three important components. Number one, human excreta. Number two, organic matter. Number three, disease causing or pathogenic microorganisms. Then imagine such type of harmful sewage water if directly released into the water bodies, what will happen? The people, the organisms who are dependent on that water will be acquired many waterborne diseases. Alva? So, ಆ ವಾಟರ್ನ ಯಾರು ಕುಡಿಯೋದಕ್ಕೋಸ್ಕರ ಇಲ್ಲ ಬೇರೆ ಬೇರೆ ಪರ್ಪಸ್ಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೋ ಆ ವಾಟ್ರಲ್ಲಿ ಈ ಹಾರ್ಮ್ಫುಲ್ ಪ್ಯಾಥೋಜನ್ಸ್ ಇರೋದ್ರಿಂದ ಆ ಪ್ಯಾಥೋಜನ್ಸ್ ಅಕ್ವೈರಿ ಆಗಿ ಡಿಫ್ರೆಂಟ್ ಡಿಸೀಸಸ್ ವಾಟರ್ ಬಾರ್ನ್ ಡಿಸೀಸಸ್ ಬರೋದಕ್ಕೆ ಅವಕಾಶ ಇರುತ್ತೆ. ಆ್ಯಂಡ್ ಆಲ್ಸೋ ದಿಸ್ waste containing water in the many aquatic life also will be extincted. So, we should not do that. Then what is the best method? Means we have to treat that waste water or sewage with the help of sewage treatment plants. Okay? Sewage treatment takes place by the sewage treatment plants, STPs. STPs andre enama sewage treatment plants. This sewage treatment plant helps to treat waste water or sewage which is generated from the cities and towns and make it into less pollution of water. Such type of less polluted water we can release it into the water bodies, that is far better than the direct releasing. Okay na? Then how it is takes place means see in the sewage treatment plants, sewage or waste water treated by the microorganisms, heterotrophic microorganisms which are actually present inside the sewage only. So, in the sewage treatment plants, what will happen? Sewage treatment takes place with the help of heterotrophic microbes, where heterotrophic microbes are present in the sewage water itself only. Okay. Then this sewage treatment takes place by two steps. How many steps ma? Two steps. Step number 1, primary treatment. Primary step. First step in the sewage treatment is called primary treatment. And the second step is called secondary treatment. Secondary treatment. Here, dear students, the primary treatment, in the primary treatment, it is completely physical process. Primary treatment is completely physical process. That means do not involve any microorganisms in the primary treatment of sewage water. No microorganisms are involved. Only by the sequential filtration and the sedimentation by these two steps, large and small particles from the sewage water will be removed. So, the primary treatment is a physical process. Why? Because only physical removal of large and smaller particles from the sewage takes place by the two steps. What are the two steps? Number one, sequential filtration. Number two, sedimentation. These are the two steps involved in the primary treatment. So, how exactly treatment is going on with the help of sewage treatment plant, I will explain now. Listen carefully, okay? It's one of the most important concept. So, here first we are going to know about primary sewage treatment. In the primary sewage treatment method, how the sewage water is treated we will see now. First, you can take, it is a sewage from any city we got a sewage. So, what is sewage? Municipal waste water is called a sewage, we know that, right? Then this sewage is allowed into a sequential filtration. A sequential filtration. For example, see here, they will arrange some sequential grills. That grills may contains larger, smaller, like that. Different sizes grills are arranged here. In the sequential filtration, in the first step, when they allowed sewage into the first sequential filtration, where they trapped large sized particles whatever present in the sewage water. Large sized particles which are present in the sewage water will be eliminated. Again, the sewage water enters into the second trap, where whatever the substances escaped from the primary filtration will be trapped here. In the third step, somewhat smaller particles are separated. In the fourth step, somewhat very smaller particles are separated. Like this, dear students, when we allow the sewage water into sequential filtration, this is called sequential filtration. Sequential filtration. In the sequential filtration, what we do? All the large and smaller particles, nothing but floating debris. Floating debris. Floating debris may include large and small sized, especially large sized particles, ಅದರಲ್ಲಿ various sizes ಇರೋ water bottles ಆಗಿರ್ಬೋದು, plastic, cloths, sticks. So all these physical particles are trapped in a sequential filtration method and separated from the sewage water. As a result, at the end of sequential filtration, all the floating debris are removed from the sewage. Rest, sewage water, along with water, organic matter, and also soil and a small pebbles, stone-like structures may escape from the sequential filtration, right? That is allowed into the second step in the primary treatment is called sedimentation. Is called sedimentation. So, the sewage water now allowed into the another chamber known as sedimentation tank or settling tank, primary settling tank. So, this is called a primary settling tank. What is the name of this tank, ma? Primary settling tank. Yeah. Now, after the first step in the primary sewage treatment, all the floating debris are removed by the sequential filtration. Then the sewage water allowed into the primary settling tank. Where in the primary settling tank, all the solid particles go and settle down at the bottom of the chamber. In the primary settling tank, all the solids andre sewage water alli ಇನ್ನೇನು ಉಳಿದಿರುತ್ತೆ ಎಲ್ಲ ಫಿಸಿಕಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ರಿಮೂವ್ ಮಾಡಿದ್ದಾದಮೇಲೆ ಸಾಯಿಲ್, ಸ್ಯಾಂಡ್ ಅಥವಾ ಸ್ಮಾಲ್ ಸ್ಟೋನ್ ಲೈಕ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಮಾತ್ರ ಎಸ್ಕೇಪ್ ಆಗಿರುತ್ತಲ್ವಾ. ದೀಸ್ ಆರ್ ಸಾಲಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್. These solids will go and settle down at the bottom of the chamber known as grit. What do you call it, ma? Grit anta karitare. Here grit means it includes two substances. Maybe one is soil or maybe another one is pebbles. Soil and pebbles together called as grit. So that grit is solid particles, density particles. So they will go and settle down at the bottom of the primary settling tank. That sedimentation part is called grit. Grit composition is called soil and small pebbles. So this is collectively the sedimented part present in the primary settling tank is called primary sludge we call it. What do you call it, ma? Primary sludge. So these primary sludge, nothing but soil and small pebbles will be separated from this chamber and used as manure for agricultural land also. And rest, if all the solids are sedimented at the bottom of the chamber, the remaining supernatant is there, no? Floating part is present in the chamber, no? This floating part is called primary effluent. So, at the end of second step in the primary treatment, all the solids like soil and pebbles go down and settled together forms into grit, nothing but primary sludge. And rest of the floating part, supernatant in that chamber is called primary effluent. Dear students, now in the primary effluent, there is no physical particles are present, all will be separated. But still the primary effluent consists pollution, potentiality containing organic matter is present. Okay? To treat that organic matter, we need to enter into the secondary treatment. Okay? So here I repeat once again, sewage water or waste water is treated by two steps. First step is called primary treatment, second step is called secondary treatment. Primary treatment is physically processed. Why? Because all the large and small physical particles are removed by how many steps? 2 steps. Step 1, sequential filtration. By sequential filtration, what we removed? All the floating debris are removed. And what will be the second step? If the first step is sequential filtration, second step is called sedimentation. Sedimentation. In the sedimentation, what substances we removed from the sewage means grit is removed. Grit means what ma? Soil and pebbles will be removed. Now, these sequential filtration plus sedimentation, these 2 steps comes under the primary treatment. Primary treatment. Understand ma? So, what is primary treatment means this is called a primary treatment. It is a physical process because physical removal of large and smaller particles are removed by the 2 steps. One is sequential filtration, second one is sedimentation. By the sequential filtration, what we removed from the sewage? Floating debris. By the sedimentation, what we removed from the sewage? Grit. What is grit? Soil and pebbles. Is there any microorganisms are involved in the primary treatment? No. At the end of primary treatment, we get 2 substances. All the solids which sedimented at the bottom of the chambers are called primary sludge, and the supernatant is called primary effluent. Primary effluent still containing organic matter which is having high potential to causes pollution. So called the primary treatment, the primary effluent from the primary effluent from the primary treatment we are taking into the secondary treatment. Secondary treatment. Yeah. So, in the secondary treatment, 2 chambers are involved ma. In the secondary treatment, 2 not ma, 3 chambers are involved. One is large aeration tank. In the secondary treatment, total 3 chambers are involved. In that, first chamber is called aeration tank. This is called aeration tank. So now, after primary treatment, the primary effluent is taken into the large aeration tank. Now, in this aeration tank, what present? Sewage is present. Sewage contain what? Organic matter. Organic matter is present in the sewage water. This chamber is constantly, continuously and mechanically agitated. Andre stable agi, constant agi irdira, yavaglu moving positional irutte. Okay? So, as a result, the content whatever present in the aeration tank will be thoroughly mixed up. Clear ma? Now, so why this tank is called aeration tank means into this tank the air is pumped in. The air is pumped into the aeration tank. Why we are pumping air into the aeration tank means for the source of oxygen. For the source of oxygen. Then this oxygen from the atmosphere enters into the aeration tank where it will be dissolves in the sewage water. So, in the aeration tank, availability of oxygen is in which form? Dissolved state alli maatrane irutte. Now, so I already told you the sewage water contain organic matter and also heterotrophic microbes anta. Andre ಈ ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟ್ಗೆ ಬೇಕಾಗಿರೋ ಮೈಕ್ರೋಬ್ಸ್ ಇದೇ ಸೀವೇಜ್ ವಾಟ್ರಲ್ಲಿ ಆಲ್ರೆಡಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿರುತ್ತೆ. ಅಂದರೆ ಇಲ್ಲಿ ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟಲ್ಲಿ ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ರೋಲ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಹೆನ್ಸ್ ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಈಸ್ ಆಲ್ಸೋ ನೋನ್ ಆಸ್ ಬಯೋಲಾಜಿಕಲ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಅಂತಲೂ ಕರೀತಾರೆ. ಯಾಕಂದರೆ ಲಿವಿಂಗ್ ಆರ್ಗಾನಿಸಮ್ಸ್, ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟಲ್ಲಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಪರ್ಪಸ್ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅದು ಹೇಗೆ ಈಗ ನೋಡೋಣ. ನಾವು ಸೊ ದ ಆಕ್ಸಿಜನ್ ಈಸ್ ಅವೈಲಬಲ್. ಆಸ್ ಅ ರಿಸಲ್ಟ್ ಯು ನೋ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ಸಮ್ ಆಫ್ ದ ಏರೋಬಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ಇನ್ಸೈಡ್ ದ ಚೇಂಬರ್, ಏರೋಬಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ will be start to consume organic matter present in the sewage water. For that digestion it required dissolved oxygen. As a result within several hours what will happen? These bacteria will grow rapidly and multiplies into millions. So such type of masses of bacteria along with fungal filaments, masses of bacteria along with fungal filaments together forms into flocks will be formed. I repeat, a mass in the aeration tank, when the primary effluent enters into the aeration tank, the air is continuously pumped into this chamber for the source of oxygen. As a result, this chamber is continuously and mechanically agitating to mix up the content which is present in the aeration tank. As a result, many aerobic useful bacteria by utilizing dissolved oxygen and start to consume organic matter. As a result, multiply the number into millions. As a result, millions of or masses of bacteria along with fungal filaments together forms into flocks. You understand? So dear students, here flocks means flocks is equal to aerobic bacteria plus fungi. Aerobic bacteria plus fungi is equal to flocks are formed. Here dear students, if once flocks are developed on the sewage water in the aeration tank, these growing flocks will start to consume all the organic matter present in that sewage water. To digest, to oxidize this organic matter present in the sewage water, this aerobic bacteria utilizes dissolved oxygen. You remember carefully, for the oxidation of organic matter present in the sewage water, aerobic bacteria can utilizes dissolved oxygen. As a result, as the microbes utilizing dissolved oxygen from the sewage water to digest organic matter, the BOD of this waste water will be decreased. What is BOD? Biochemical oxygen demand. What is BOD? Biochemical oxygen demand. Biochemical oxygen demand. That means an availability of oxygen in the sewage water for the aerobic bacteria to digest organic matter. So called BOD is inversely proportional to ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ ಅಂತ ಕರೀತಾರೆ. ಯಾಕೆಂದರೆ ನಾವು ಯಾವುದಾದ್ರೂ ವಾಟರ್ ಸ್ಯಾಂಪಲ್ಸಲ್ಲಿ ಪೊಲ್ಯೂಷನ್ ಲೆವೆಲ್ಸ್ ಹೇಗಿದೆ, ಜಾಸ್ತಿ ಇದೆಯಾ ಕಡಿಮೆ ಇದೆಯಾ, ಐದರ್ ಪೊಲ್ಯೂಟೆಡಾ ನಾಟ್ ಪೊಲ್ಯೂಟೆಡಾ, ಇಫ್ ವಾಟರ್ ಈಸ್ ಪೊಲ್ಯೂಟೆಡ್ ವಾಟ್ ಈಸ್ ದ ಲೆವೆಲ್ ಆಫ್ ಪೊಲ್ಯೂಷನ್ ಅನ್ನೋದನ್ನು ನಾವು BOD ಟೆಸ್ಟ್ ಮೇಲೇ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ. ಹೇಗೆ ಅಂದರೆ, ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ವಾಂಟ್ ಚೆಕ್ ಪೊಲ್ಯೂಷನ್ ಲೆವೆಲ್ಸ್ ಆಫ್ ಅ ರಿವರ್ ವಾಟರ್, a lake water or any tank water ಅಂದ್ಕೊಳ್ಳಿ. ಅದರಿಂದ 1 ಲೀಟರ್ ಆಫ್ ವಾಟರ್ ಸ್ಯಾಂಪಲ್ಸ್ನ ನಾವು ಕಲೆಕ್ಟ್ ಮಾಡಿಕೊಂಡು ಆ 1 ಲೀಟರ್ ಆಫ್ ವಾಟ್ರಲ್ಲಿ ಎಷ್ಟು ಡಿಸಾಲ್ವ್ಡ್ ಆಕ್ಸಿಜನ್ ಇದೆ ಅಂತ ಕೌಂಟ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಟೆಸ್ಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇನ್ 1 ಲೀಟರ್ ಆಫ್ ವಾಟರ್ ಹೌ ಮಚ್ ಅಮೌಂಟ್ ಆಫ್ ಡಿಸಾಲ್ವ್ಡ್ ಆಕ್ಸಿಜನ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ more dissolved oxygen is present in that 1 liter of water ankolli, still microorganisms do not utilize as oxygen. That means organic matter is still present in the water only. That means more potentiality to the pollution anta artha madkobeku. Illa if that 1 liter of water is containing very less BOD, nothing but less dissolved oxygen, it means already microorganisms are oxidized organic matter, for that they utilize as oxygen. As a result less pollution potentiality ide anta ನಾವು ಹೇಳ್ಬೋದು. So very simple indication, if BOD is more, as a result the organic matter is also more. If organic matter is more means what we can understand, the pollution levels are also high ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಅಂದರೆ ಯಾವ ವಾಟರ್ ಸ್ಯಾಂಪಲ್ಸ್ ಅಲ್ಲಿ ಇಫ್ ಮೋರ್ BOD ಮೋರ್ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ ಇದೆ ಅಂತ, that means still microbes need to digest organic matter. As a result more pollution potentiality is available. If less BOD less organic matter less pollution ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಏರೋಬಿಕ್ ಮೈಕ್ರೋಬ್ಸ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಪ್ಲಸ್ ಫಂಗೈ ನಥಿಂಗ್ ಬಟ್ ಫ್ಲಾಕ್ಸ್ ಏನು ಮಾಡುತ್ತೆ, ಈ ಸೀವೇಜ್ ವಾಟ್ರಲ್ಲಿರೋ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ನ ತಿಂದಾಕುತ್ತೆ. ಅದು ತಿಂದು ಡೈಜೆಷನ್ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಅದಕ್ಕೆ ಯಾವ ಗ್ಯಾಸ್ ಬೇಕು, ಆಕ್ಸಿಜನ್ ಬೇಕು. ಆಕ್ಸಿಜನ್ ಯಾವ ಫಾರ್ಮಲ್ಲಿರುತ್ತೆ, ಡಿಸಾಲ್ವ್ಡ್ ಸ್ಟೇಟಲ್ಲಿರುತ್ತೆ. ಸೊ ದ ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಫ್ಲಾಕ್ಸ್ ಕನ್ಸ್ಯೂಮ್ ಮೇಜರ್ ಪಾರ್ಟ್ ಆಫ್ ದ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್. ಟು ಡೈಜೆಷನ್ ಪರ್ಪಸ್ ಇಟ್ ವಿಲ್ ಯುಟಿಲೈಸಸ್ ಡಿಸಾಲ್ವ್ಡ್ ಆಕ್ಸಿಜನ್. ಆಸ್ ಅ ರಿಸಲ್ಟ್ in this sewage water of aeration tank BOD will be decreased. If BOD is decreased means what you understand, the organic matter present in that sewage water will be reduced anta artha. That means pollution levels will be decreased. So until to decrease BOD, sewage water treated within the aeration tank only, they do not allow into the next tank. If once BOD is decreased, nothing but all the organic matter present in the sewage water is digested by the bacteria. Then that effluent we allowed into another chamber known as secondary settling tank. Secondary settling tank. So this is called a secondary settling tank, because second time the product will be sedimentation takes place. Okay, now the effluent which is already organic matter digested by the microbes will allowed into the secondary settling tank. Now guess what present inside the effluent which is coming into the secondary settling tank? Only sewage water plus flocks are present. Is it clear? Now, in the secondary settling tank, just they allowed for sedimentation. What they allowed to sediment andre? Bacterial flocks, because in the remaining content whatever it will comes here, adralli enirutte andre only density particles, nothing but flocks are present. So all that bacterial flocks will go and settle down at the bottom of the secondary settling tank. This sedimented part is called, this sedimented bacterial flocks present in the secondary settling tank is called activated sludge. Activated okay. On that. Ready? Okay, ma. So, in the secondary settling tank, all the bacterial flocks are allowed to sedimentation. That sedimented part in the secondary settling tank is called activated sludge, we call it, ma. Activated sludge contain what substances? Means very simple, aerobic bacteria. What present, ma? Aerobic bacteria plus fungi together called activated sludge, we call it, okay na? And the rest of the supernatant is called, floating part is called secondary effluent. What do you call it? Secondary effluent. Secondary effluent. Dear students, secondary effluent is now organic matter free or organic matter is very less. So, if these water allowed into the water bodies causes very less harm to the living organism. So called this secondary effluent is already treated, no? That treated secondary effluent we can directly release it into the water bodies. Released into the water bodies. Water bodies, like you can take rivers, lakes, ಈ ಥರ ವಾಟರ್ ಬಾಡೀಸ್ಗೆ ನಾವು ಅಲೋ ಮಾಡ್ಬೋದು. ಯಾಕೆಂದರೆ ಇದರಲ್ಲಿ ಪೊಲ್ಯೂಷನ್ ಕಂಟೆಂಟ್ ಏನು ಇರಲ್ಲ, ಆಲ್ರೆಡಿ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ ಡೈಜೆಷನ್ ಆಗಿರುತ್ತೆ ಇನ್ ದ ಏರೇಷನ್ ಟ್ಯಾಂಕಲ್ಲಿ, ಓಕೆನಾ? ನೌ ದ ರೆಸ್ಟ್ ಆಫ್ ದ ಕಂಟೆಂಟ್ ರಿಮೈನ್ಸ್ ಇನ್ ದ ಸೆಟ್ಲಿಂಗ್ ಟ್ಯಾಂಕ್ ಈಸ್ ಆಕ್ಟಿವೇಟೆಡ್ ಸ್ಲಡ್ಜ್. ಫ್ರಮ್ ದೀಸ್ ಆಕ್ಟಿವೇಟೆಡ್ ಸ್ಲಡ್ಜ್ a small part, very small part of the activated sludge sends back into the aeration tank, ma. From the secondary settling tank, a small part of the activated sludge, a small part of the activated sludge sends back into the aeration tank. You know what? It will be acts as inoculum. Inoculum. Inoculum means for the next treatment purpose it will act as a starter or also known as a source of microorganisms. ಯಾಕೆಂದರೆ ಈ ವಾಟರ್ ಇಲ್ಲಿಗೆ ಬಂದಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಸೀವೇಜ್ ವಾಟರ್ ಇಲ್ಲಿ ತಗೊಬರ್ತಾರೆ, ಸೆಕೆಂಡ್ ಟ್ರೀಟ್ಮೆಂಟ್ಗೆ ಸೋರ್ಸ್ ಆಫ್ ಮೈಕ್ರೋಬ್ಸ್ ಬೇಕಲ್ಲ. ನಿಮ್ಗೊಂದು ಡೌಟ್ ಬರ್ಬೋದು, ಸರ್ ಆಲ್ರೆಡಿ ಸೀವೇಜ್ ವಾಟರಲ್ಲಿ ಮೈಕ್ರೋಬ್ಸ್ ಇರುತ್ತಲ್ವಾ ಮತ್ತು ಇದನ್ನೇ ಯಾಕೆ ಅಂತ. ಅಂದರೆ ಇನ್ನೂ ಸ್ವಲ್ಪ ಆ ಎಫಿಷಿಯನ್ಸಿ ಲೆವೆಲ್ಸ್ನ ಮೈಕ್ರೋಬ್ ಕಂಟೆಂಟ್ನ ಜಾಸ್ತಿ ಮಾಡಿ ಬೇಗ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ನ ಡೈಜೆಸ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಈ ಸ್ಯಾಂಪಲ್ ಆಫ್ small amount of sludge we will send back into the aeration tank, and remaining large amount of activated sludge, we allowed into another important chamber known as anaerobic sludge digester. What is the name of this chamber? Anaerobic sludge digester. Anaerobic sludge digester. So now the remaining large part of the activated sludge allowed into the another chamber is called anaerobic sludge digester. In the anaerobic sludge digester, all this sludge will go and settle down at the bottom of the chamber. As usually this is called activated sludge, nothing but bacteria plus fungi is present, correct ma? What are the components of activated sludge? Bacteria and fungi. What type of bacteria? Aerobic or anaerobic? Anaerobic bacteria, not aerobic bacteria are present. Now in the anaerobic sludge digester already anaerobic microbes are present ma? In the anaerobic sludge digester anaerobic microbes are present. These are called anaerobic microbes. Aerobic microbes will do respiration in the presence of oxygen. Anaerobic microbes will survive in the absence of oxygen. So what type of microbes present in the anaerobic sludge digester means actually anaerobic microbes are present. After allowed activated sludge, now in the anaerobic sludge digester, anaerobic bacteria, nothing but anaerobic methanogens are present. Anaerobic bacteria or anaerobic microbes, also known as methanogens. Methanogens antanu karitare, remember. And aerobic bacteria and fungi is present. Now very clear what happens exactly in the anaerobic sludge digester means the anaerobic bacteria, nothing but methanogens, will digest aerobic bacteria and fungi. As the result produces mixture of gases known as CH4 produces, that is called methane, H2S, that is called hydrogen sulfide, carbon dioxide, that is called CO2. Okay. Now these three gases together forms into biogas. Andre sewage treatment ಮಾಡೋದ್ರಿಂದ ನಮ್ಗೆ additionally one more benefit also there. We got biogas. This biogas is eco-friendly gas. We can use it for cooking and lighting because it is inflammable gas. Is it clear ma? So this is what sewage treatment. Here you must have clarity that no microorganisms involved in the primary treatment, microorganisms involved in the secondary treatment. What type of microbes involved in the secondary treatment? Both aerobic and anaerobic microbes are also involved. You remember that. And in which chamber of the secondary treatment aerobic microbes are present? Aeration tank and a settling tank. Aeration tank is prime, okay na? And in which chamber anaerobic microbes or bacteria are present andre? In the anaerobic sludge digester, anaerobic bacteria or methanogens are present, okay? What are the mixture of gases produced in the anaerobic sludge digester? By the oxidation of aerobic bacteria and fungi by the anaerobic bacteria, means biogas. And what will be the result of secondary effluent andre, which is released into the water bodies? And why a small part of the activated sludge sends back into the aeration tank? Because it serves as inoculum. And what will happen? The remaining part of the activated sludge andre, it will send into the anaerobic sludge digester. Okay, clear ma? So in the primary treatment only one chamber involved along with one sequential filtration. In the secondary treatment 3 chambers are involved. One is aeration tank, secondary settling tank and anaerobic sludge digester. Here the sedimented part in the primary treatment is called primary sludge, which contain grit, nothing but soil and pebbles. The sedimented part in the secondary settling tank is called activated sludge, which contain aerobic bacteria plus fungi. You got it? And BOD, about BOD, full form. If BOD is more, that water samples contain more organic matter, more polluting potentiality is present at that. Less BOD, less organic matter, less pollution. Clear ma? And flux, aerobic bacteria, masses of aerobic bacteria plus fungi is equal to flux. Okay. Now, as the urbanization is increased day by day, I mean human population is increased, production of sewage water, waste water also increased, but number of sewage treatment plants are not increased. As a result, in many cities, untreated sewage water directly released into the water bodies, thereby some major rivers in India will be polluted, like Ganga and Yamuna rivers are the famous rivers which are highly polluted because of untreated sewage water releasing into them. Okay? So, to overcome that problem, MOEF, dear students, ಈ 3 chambers ನ ಸೇರಿಬಿಟ್ಟು ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಅಂತ ಕರೀತಾರೆ. ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟ್. Yeah. So next one, another important note ma, MOET. MOET. So MOET full form, Ministry of Environment and Forestry. Ministry of Environment and Forest. Yeah. So, Ministry of Environment and Forest introduced, started 2 action plans, initiated 2 action plans. One is Ganga action plan, second one is Yamuna action plans. Ganga action plan and Yamuna action plans. On what purpose they introduced? They started Ganga and Yamuna action plans by the Ministry of Environment and Forestry, means because of 2 aims. Aim number 1, to protect major rivers in India like Ganga and Yamuna from the sewage water. To protect the major rivers of India like Ganga and Yamuna is one of the main aim why they started Ganga and Yamuna action plans. Under this action plans, what they done? Actually, to protect the Ganga and Yamuna rivers, means they built more number of sewage treatment plants in every cities. If any sewage treatment plants are available in the cities, they must be treated sewage water, only treated sewage water they allowed into the water bodies, thereby Ganga and Yamuna rivers are making less pollution. Okay, this is about sewage treatment ma. It is very, very important, just you must focus on that. And one more clarity, BOD test is used to measure the amount of dissolved oxygen present in the water, you remember, followed by thereby indirectly they measure organic matter. ಒಂದು ವೇಳೆ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ BOD measures to ಅಂದರೆ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ ಇರುತ್ತೆ, ಕನ್ಸಂಪ್ಷನ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಇರುತ್ತೆ, and remaining options also may be there. First you can go for the based on the consumption of oxygen, dissolved oxygen in the water, thereby indirectly we came to know that organic matter percentage. Okay na? Availability of dissolved oxygen na measure ಮಾಡೋದ್ರಿಂದ ನಮಗೆ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡೋದ್ರಿಂದ ಆಕ್ಸಿಜನ್ ಅವೈಲಬಿಲಿಟಿ ಗೊತ್ತಾಗಲ್ಲ. ಓಕೆನಾ? ಸೋ ಕಾಲ್ಡ್ BOD ಡೆಫಿನೇಷನ್, ದ ಅಮೌಂಟ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಯುಟಿಲೈಸ್ಡ್ ಬೈ ದ ಏರೋಬಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಟು ಆಕ್ಸಿಡೈಸ್ ಟೋಟಲ್ ಆರ್ಗಾನಿಕ್ ಮ್ಯಾಟರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ 1 ಲೀಟರ್ ಆಫ್ ವಾಟರ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಕ್ಲಾರಿಟಿ. ಓಕೆ ಮಾ, ಕ್ಯಾನ್ ಐ ಅರೇಂಜ್ ದಿಸ್ ಒನ್? ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್, okay. Next, another important topic, antibiotics. Yeah. So, the term antibiotics was coined by Walkman. Who coined the term antibiotics? Walkman uncle. In the year of 1942, Walkman uncle discovered the term antibiotics. Then the term antibiotics was derived from which language? So that is Greek word. The word antibiotics was derived from Greek words. In Greek, anti means what ma? Against. Biotic means what ma? Life. So the overall meaning of antibiotics is called against life. Against life. Here very clarity, antibiotics meaning against life means against life of microorganisms, especially disease causing microorganisms. Harmful microorganisms ke maatrane idu against, not for the human beings. For human beings, antibiotics are pro-life. Remember, for human beings, antibiotics are not against, they are pro-life, they increases our lifespan. Okay na? So here against life to disease causing microbes. But for the human beings, for the humans, antibiotics are pro-life. That means they do not cause us any harm to the human beings. And remember, against to disease causing microbes means, you may be got doubt, right? Sir, there are many varieties of microorganisms are present in the nature. No, against which microorganisms these antibiotics will work? Andre against bacteria only. Bacteria, against bacterial diseases or to kill bacteria, these antibiotics will work. Antibiotics against only bacteria, not other pathogens, you remember. Understand? Now, what are antibiotics? So, antibiotics are just a chemical substances, chemicals are derived from produced from some microorganisms. These chemicals have capacity to kill the other disease causing microbes like bacteria, or maybe they retards the growth of the disease causing microbes. That is the definition of antibiotics. Okay? And then one more important point, which is the first antibiotic discovered andre penicillin. Penicillin was the first antibiotic. It was discovered by Alexander Fleming. Alexander Fleming. Tell me, dear students, who discovered penicillin ma? Alexander Fleming. Penicillin is the first antibiotic. It is the first antibiotic. You know, in the 20th century, the discovery of or the production of antibiotics by using microorganisms, one of the greatest discovery among them, this is the penicillin. So, penicillin is the first antibiotic which was discovered by Alexander Fleming uncle from the microorganism known as Penicillium notatum. Penicillium notatum. I repeat, penicillin is a first antibiotic. It was discovered by which microorganism? Penicillium notatum. Penicillium is the genus name, notatum is the species name. It is also commonly known as a fungi. A fungi. Now the question is, how the discovery of penicillin takes place? So penicillin discovery is not intentionally, it will be accidentally happens. So when Alexander Fleming uncle, while working on one bacteria name called, Staphylococci. Staphylococci, very very important ma. Staphylococci, while working on Staphylococci bacteria, accidentally he was discovered penicillin. How means actually? So on one of his unwashed culture plate, actually he was doing an experiment on the Staphylococcus bacteria, no? So sometimes, some days he forgot maybe to cleaning that culture plates. So such type of, on one of his culture plate, a growing mold is he was observed. So around that mold there is no growth of any Staphylococci bacteria. So later he was found that mold which is growing on a culture plate, the mold which is growing on a culture plate, this is a culture plate, this is called a mold. Here around this mold there is no growth of Staphylococcus bacteria, this is called a Staphylococcus bacteria. So later he was found that a chemical released from that mold, is called penicillin. Because of this chemical only, bacteria could not grow around the mold. Later he was found that mold is called Penicillium notatum. That means he was discovered penicillin, but he don't know what are the uses of penicillin, andre adanna navu hege use ಮಾಡಬೇಕು, ಏನಕ್ಕೋಸ್ಕರ ಯೂಸ್ ಮಾಡಬೇಕು ಅನ್ನೋ ಕ್ಲಾರಿಟಿ ಅಲೆಕ್ಸಾಂಡರ್ ಫ್ಲೆಮಿಂಗ್ಗೆ ಇಲ್ಲ. ಬಟ್ ಅವ್ರು ಏನು ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ದಾರೆ, ಈ ಫಸ್ಟ್ ಆಂಟಿಬಯೋಟಿಕ್ ಪೆನ್ಸಿಲಿನ್ ಅಂತ, ಈ ಪೆನ್ಸಿಲಿನ್ ಇರೋ ಪ್ಲೇಸಲ್ಲಿ ಈ ಕೈಂಡ್ ಆಫ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಅನ್ನೋದು ಗ್ರೋ ಆಗೋಲ್ಲ ಅನ್ನೋ ವಿಷಯ ಮಾತ್ರನೇ ಅವರು ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ದಾರೆ. ಲೇಟರ್ ಸಮ್ ಅದರ್ 2 ಸೈಂಟಿಸ್ಟ್ ಅಂಕಲ್ಸ್ ಲೈಕ್ ಎರ್ನೆಸ್ಟ್ ಚೈನ್ and Howard Florey. These 2 scientist uncles explained full potentiality of penicillin as an antibiotic. So, as an antibiotic ಆಗಿ ಈ ಪೆನ್ಸಿಲಿನ್ಗಿರೋ ಲಿಮಿಟೇಷನ್ಸ್ ಏನು, ಕೆಪಬಿಲಿಟೀಸ್ ಏನು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದಾರೆ ಎರ್ನೆಸ್ಟ್ ಚೈನ್ ಮತ್ತು ಹವಾರ್ಡ್ ಫ್ಲೋರಿ. ಸೋ ಕಾಲ್ಡ್ ಆ ಕ್ರೈಟೀರಿಯಾದಲ್ಲಿ ಅವ್ರು ಏನು ಮಾಡಿದ್ದಾರೆ, ಈ ಪೆನ್ಸಿಲಿನ್ ಅನ್ನೋ ಆಂಟಿಬಯೋಟಿಕ್ನ ದೇ ಯೂಸ್ಡ್ ಟು ಟ್ರೀಟ್ ಅಮೆರಿಕನ್ ಸೋಲ್ಜರ್ಸ್ who wounded in the World War II. So, ಸೆಕೆಂಡ್ ವರ್ಲ್ಡ್ ವಾರ್ ಅಲ್ಲಿ ಯಾರು ಅಮೆರಿಕನ್ ಸೋಲ್ಜರ್ಸ್ wounded ಆಗಿರ್ತಾರೋ ಅವರೆಲ್ಲರಿಗೂ ಟ್ರೀಟ್ ಮಾಡೋದಕ್ಕೆ ಈ ಪೆನ್ಸಿಲಿನ್ನ ಆಂಟಿಬಯೋಟಿಕ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ನಾವು ಹಿಯರ್ ಫಾರ್ ದ ಡಿಸ್ಕವರಿ ಆಫ್ ಪೆನ್ಸಿಲಿನ್ ಟು ದ ಅಲೆಕ್ಸಾಂಡರ್ ಫ್ಲೆಮಿಂಗ್, for explaining full potentiality of penicillin is an antibiotic for Chain and Florey. They got Nobel Prize. To these 3 scientist uncles for the discovery of penicillin for the discovery of penicillin for Alexander Fleming, for explaining full potentiality of penicillin is an antibiotic for Chain and Florey, they got Nobel Prize. And later after the discovery of penicillin, many other scientist uncles also discovered many other antibiotics from the different sources like Bacillus species ಇಂದ, Streptomyces species ಇಂದನೂ ಈ antibiotics discover ಮಾಡಿದ್ದಾರೆ. So these antibiotics improved our capacity to treat some deadly diseases. Very important, to treat some deadly diseases at 20th century like plague is one of the deadly disease. This disease caused by one of the bacteria. Against this disease we use antibiotic. And second one, whooping cough, also known as coliconcy. Remember the alternative names also. Whooping cough is also known as coliconcy. It is also caused by the bacteria. To treat this disease we use antibiotics. Third, diphtheria is also known as gallgoto. And fourth one is called leprosy, also known as Kusht rog. And last one, pneumonia. So etc. This type of very dangerous and deadly diseases ಟ್ರೀಟ್ ಮಾಡೋದಕ್ಕೂ ಆಂಟಿಬಯೋಟಿಕ್ಸ್ ಅನ್ನೋದು ತುಂಬ ಹೆಲ್ಪ್ ಆಗಿದೆ. ಓಕೆಮಾ? ರೈಟ್. ಸೊ ಪ್ರಿಪೇರ್ ವೆಲ್, write well. Okay, thank you. We'll meet you in the next class. Time ainda?